Hi everyone and welcome to PrepFusion. Welcome to another R-PYQ series video. So in this video we will be covering complete integral calculus, that is basics of integration, multiple integrals like double and triple integrations, then few miscellaneous concepts like improper integrals, then how to find out whether a series will converge or diverge, or summation of infinite discrete series. Those things we'll discuss, and obviously differential equations. That is also another chapter itself that we are covering in this video itself. So we will be covering complete differential equation, linear differential equations, ordinary differential equations. Then there are many methods to solving differential equations that we will discuss. But one thing I can guarantee is whatever we will discuss, we will try to reduce our formulas as less as possible. So the way that I have explained to you, that you don't need to remember any formulas. Few times you might have to in differential equations, like for solving higher order differential equations, there are like when your roots of the auxiliary equation will come out to be real distinct, or they will come out to be real and equal, or they will come out to be complex conjugate, then those things you have to remember what is the case. But other than that, the double integration part is the most difficult part, right? And once you see my explanation, then it will be just cakewalk for you. Any double integration question you will be able to easily solve, and you don't need to remember anything like what is my vertical step, what is my horizontal step. The way that I have taught you, you will be easily able to solve any double integration question. Just once see, you will understand. So one request from my end, if you are enjoying the R-PYQ series, please do hit the like button. Please comment down below whichever concepts you are enjoying, so that I can get to know like how you are enjoying the R-PYQ series, and like that will motivate me to bring the more content, like more R-PYQ series, basically for more chapters, right? For mathematics like probability and control systems. So if you want this series to continue, you have to show your support. So yeah, with that we will start with the first topic, that is basics of integration. Let's start with basics of integration. So like I hope you have basic idea what is integration, but of course we'll discuss about that. So basically integration is nothing but the opposite of differentiation. Okay, integration is the reverse process of differentiation. It is also called as primitive or antiderivative. So if I am differentiating a function g of x, and the differentiation of the function g of x is f of x, if I apply the integration operator, what will I get back? So if I integrate on both sides, so I will get back g of x. So basically, if the differentiation of the function g of x is f of x, then the integration of the function f of x will be g of x. There will be a constant. Okay, why? Because when I differentiate my f of x, right, when I differentiate my f of x, this will be differentiation of g of x plus differentiation of the constant, that is 0. So like if this constant is not present, then like I am not able to call for the family of curves. So let's take example. We know that I have a function, just let me choose the pen properly here. Okay, so we know the differentiation of x plus 4. What is the differentiation of x plus 4? That is 1, right? The differentiation of x plus 5 is also 1, right? So these constant can be anything, correct? That's why there is always a c, because when I differentiate this, the constant is automatically gone. So that's why whenever you will integrate without limits, the limits are currently not there. If limits are not there, this constant of integration will always be present. Okay, like because integration has two types. First one is the indefinite, next one is the definite. So definite means I'm integrating from point A to point B, like x equal to A to x equal to B. Okay, graphically also I will show you how it happens. And this is known as indefinite, which has no limits. Okay, like we are just writing the general equation. So this is a very basic example. So if I'm integrating just 1, I am just integrating 1 dx. Okay, so what is the integration? Integration, so y equals to integration of dx. We know the integration of this comes out to be x plus c, correct? So if I plot the x plus c, right, so for x equal to like for c equals to 0, it will be a y equals to x line. For c equals to 1, it will be a y equals to x plus 1 line, and so on. Like I can vary my value of c. So basically we have a family of curves. We get a family of curves, because if I differentiate, right, if I differentiate this function, this will be 1. Like x plus 1 differentiation will be 1, right? X minus 1 differentiation will be 1. So I am able to get back to my previous function. This was 1 into dx, right? Just give me 1 second. this was 1 dx. 1 second now. Yeah. So this was 1 dx. Now as if I differentiate this function, I am getting back to 1. If I differentiate this function, I am getting back to 1. So for both functions, I am getting back to 1. Correct? So that is the thing over here. That is the thing that's why we have to write this C, because it represents a family of curves. Currently, what family it represents? It represents a family of straight lines whose slope is 1. It represents a family of straight lines whose slope is 1. Okay. So basic formula are there. So you have to remember here what are the basic formulas. Okay. I will obviously not go through each one of them. Okay. Then one more thing is there, that y, if you see, whenever I integrate 1 by dx, right, we have log of mod of x, because you know basically this x, right, inside log function I cannot provide negative. I cannot provide negative value, so that's why we have this mod. So I have also proven, you can see the proof how it is coming, like how it is coming, like mod of x, because if you differentiate this log s, right, log of mod of x, what will be the differentiation? So differentiation of mod x, right, is not actually equals to 1. Okay, it is simply equals to mod x upon x. Why? Because x has two definitions. Correct? When mod x is when x is less than 0, mod x is replaced by minus x, so the differentiation will be minus 1. So for x less than 0, the differentiation is minus 1. For x greater than 0, mod x will be replaced with plus x, so differentiation will be plus 1 for x greater than 0. So basically now the differentiation of this function, right, you put here, if x is less than 0, this will be replaced with minus x, but this will be still x, right? So x and x will be cancelled, minus 1. And if I replace my x with positive number, so this will be mod of x will be replaced with x, x by x will be 1. Okay, so yeah, it is 1 and minus 1, 1 and minus 1. So this will be basically, so differentiation of mod of x will be mod of x upon x. So what will be the differentiation of mod of x? Log of mod of x. So I will apply the chain rule. First I will differentiate the outside function. So this will be 1 by mod of x. Then the differentiation of the inside function, that is mod of x. So mod of x will be cancelled. This will be 1 by x. Okay. So here like the differentiation can be both, x can be here both negative and positive, but I cannot put inside the log, I cannot put my negative number. Negative number is not allowed inside the log function. That's why we have here mod of x. Okay, I hope that part is clear. And of course, your x can never be 0. If x is 0, this will be some constant by 0, which is undefined. Okay, so yeah, you can have a look at the formulas. These are the most important ones. These ones you have to remember anyhow. This ones you have to remember anyhow. Like these are very basic and you have to remember. Like mostly you will be able to remember these ones, because what was the differentiation of tan x? Sec square x. What was the differentiation of cot x? Minus cos x square x. It was minus cos x square x. So that's why extra negative sign will be there. So integration of cos x square x will be minus of cot x. So whatever is the differentiation, it will be just the opposite. Differentiation will be just the opposite. Okay. So that is the thing over here. So what are the few things that you must remember? Like this one is you have to anyways remember. Maybe you will forget this. So if you remember the differentiation, like how can I remember? Just remember one thing, differentiation of a raised to power x was a raised to power x, right? It was a raised to power x log of EA. Okay. So what will be the integration? So this is just a constant number, right? Log of EA is just a constant number. So if I integrate on both sides, so this will be integration of differentiation of a raised to power x, that is equals to integration of a raised to power x log E is just a constant number. Log base E is just a constant number, correct? So this will be basically differentiation and integration will be cancelled, correct? This will be with respect to dx. So this will become yeah, this will be only integration of a raised to power x dx. This will be equals to my, now this is a constant, so sorry what I'm doing. So this differentiation and integration will be cancelled, so only I will be left with a raised to power x, correct? Because differentiation is the opposite of integration, so this will be cancelled. So on the left hand side I will have a raised to power x. I can get this constant outside the integration, because if I have a constant is not a function of x, so I can take it outside the integration. So this will be upon a raised to power x log EA equals to integration. This will be left, only this part will be left, correct? That is a raised to power x dx. So that's how you can remember the formulas. So if you remember the differentiation, right, you will be able to remember the integration. Okay, if you ever tend to forget the integration, you write the differentiation, right, this formula, and then you integrate both sides. So you will be able to get back to your integration result. So that's how you can remember the integration of like the typical functions. Okay, so yeah, like integration of tan x. Now integration of tan x is also again very important. Integration of tan x will be log of cos x plus c, or it is log of sec x plus c. This you have to remember, log of mod of sec x plus c, integration of tan x you have to remember. Integration of cot x, it will be log of sin x plus c. Okay, like at least remember the tan x and cot x. Other ones you don't need to remember, these ones you can ignore. Okay, these ones you can ignore, but at least remember the tan x and cot x. I remember the tan x. Okay, I also tend to forget the cot x. So these things you do. There is a derivation, I'm not going into the derivation for now. Now these are also very important. Out of this, these are the most important ones. These you can like it's okay if you are not able to remember, but these four are the most important ones. So what is the integration of square root of under root of 1 minus x square? So it will be sin inverse x. Okay, and if I have in place of x by a, what will be here? So what you will do is you will swap a variable, t will be equals to x by a, and then you will integrate using substitution. So this will be, if I do dt will be dx, a is just a constant, into dx. So you will replace your dx, right, with a dt, and you will replace your x with sorry, you replace your x by a with t. That's it. Okay, here in the integration. So I hope like that, I think that we will learn in substitution, because like always this integration will not be in standard format. This will be 4 like 4 minus x square. Then what you will do, you will take the 4 common. Okay, so this will be 1 by 2, and here this will be x by 2 whole square. So you will replace x by 2 to a variable t, and then you will do this substitution. So like I'm just revising, I hope you know all these things, right? So just how, that's how you do the substitution, you do the variation. Okay, so one more thing is there, that previously in differential calculus also I have proven it to you, that sin inverse of x plus cos inverse of x is equals to pi by 2. Okay, sin inverse of x plus cos inverse of x is equals to pi by 2. So if I know the integration of sin inverse, I know the integration of cos inverse, it will be just negative, because if I integrate on both sides, correct, I know the integration, this will go on the left hand side. So there will be some constant, integration of this pi by 2 will be some, sorry what am I talking, sorry, if I know the differentiation of sin x, right, I will be able to figure out my differentiation of cos x. So because I've told you the ddx of cos inverse of x will be negative of ddx of sin inverse of x, because I am just differentiating and this is just a constant, this will be 0. Okay, this I have proven in the previous video. So that's why this will be negative. Okay, so I can write here sin inverse plus x or negative of cos inverse plus x. Okay, this also is one of the solution. Then like dx over 1 plus x square, this integration will be tan inverse of x, or it can be minus of cot inverse, because tan inverse plus cot inverse x is equals to pi by 2. Okay, so these formulas you remember. Now there are few like basic theorems. So if I am multiplying some constant k that is not a function of x, so I can take the k outside. Like I hope you know all these things. If I am adding two functions, right, so the overall integration of the addition of the two functions will be individual integrations plus minus. So it follows the property of linearity. Integration is a linear operator, so it will follow homogeneity and superposition. Okay, now like if I'm differentiating a function, okay, and I have a constant multiplied by this, right, so I can take the constant outside. So similarly that's what I have done here. So I'm differentiating not this one actually, but here, right, I could have taken the like constant term outside, so I use the property of linearity. Okay, so like these are basic theorems, these I know you know, just we are revising. So here, right, basic things, what will be the integration of 10 raised to power 10 into e raised to power x? So it will be simply 10 into e raised to power x plus c, because it is a indefinite integration. Okay, so this will be 10 into e raised to power x plus c. Okay, then what is the integration of this? Now this will be e raised to power x plus 2 raised to power x log of e base a. A is 2. This is a raised to power x, right? So this will be a raised to power x. Now, will this be multiplied? No, this will be divided, right? For integration, it is the opposite property. We just have done it. It will be divided here. So this will be by 2. So don't make this mistakes. Like, I know you will be confused. So make sure you are writing the formula properly. Okay. So yeah, it will be divided plus c. So this will be plus c. Because don't forget, obviously, don't forget the constant of integration. That is also very important. So yeah, that was it. Now there are many methods to solve the integration, right? So from this particular topic, questions will be asked, but they will be very simple question. You will be able to solve. But I will take many examples. The weightage of this topic is slightly less, okay? But still questions will be asked. So basically the integration part, right? The theory is a lot, and the weightage is slightly on the lower side. So there are mainly three methods by which I can integrate, perform integration basically: substitution, by parts, and partial fraction. So we will see one by one. So what is substitution? So if I have a function and that function is multiplied by its derivative, okay, then I can simply integrate that function. How? I will show you. So let's take this example, right? Okay, this is the basic example actually. Sorry, this is the most basic example. Like this one is very simple, right? What is the integration of x square? That is x cube divided by 3 plus c. So x raised to power n plus 1 divided by n plus 1. Now what is the integration of this function? So I can use some substitution. So what I will do, I will assume my t equals to 2x plus 6 as a 2x plus, sorry, why have I assumed here 3? I should have assumed 6. So I will assume my t to be equals to 2x plus 6. Then I will differentiate with respect to x on both sides. This will be dt upon dx plus dt upon dx will be equals to 2 plus 0, right? Differentiation of a constant is 0. So this will be dt will be equals to 2 into dx. Okay, dt will be equals to 2 into dx. So dt is equals to 2 into dx. Now I will replace that. So I will replace my t, my 2x plus 6, right, with t. This will be t square, and I will replace my dx. What will be dx? So dx will be equals to dt by 2. Okay, so I will replace my dx to be dt by 2, and then I will perform the integration. So now this, like this, I forgot to tell you, this x, right, is just a dummy variable. This x is just a dummy variable. This can be here, this can be t raised to power n dt, this can be anything, lambda, gamma, y, z, anything. X is just a dummy variable. Okay, so here this is just a dummy variable. I know the formula for this, right? What is the formula? Like t square dt, this will be t cube by 3. So that is t cube by 6, okay, plus c. Remember, this is t cube by 3 and by 2 is just a constant, so t cube by 6 plus c. This will be my answer, but of course, as they have given me in terms of x, I have to back substitute. So I will again do the back substitution. So this will be 2x plus 6 divided by 6 whole cube. I don't know why I have written 3 here. This should be like 6, right? Okay. So this will be the answer basically. Plus c, don't forget the plus c. There will be a constant of integration plus c. Okay. So yeah, that's how you use substitution. Okay. So now there are few standard integrations. There are few standard integrations. Like I can tell you few of those. Like one is the I forgot to tell you here, right? If let's say instead of this, now you know what is substitution. Instead of this, right? If I have dx upon a square plus x square, can you do the integration for me? What I will do, I will take a square common. So this will be 1 by a square. 1 by a square will be outside. Okay. Integration dx 1 plus x upon a whole square. Okay. I will again perform the substitution. So you will substitute, t will be equals to x upon a, and if you solve this, right, your solution, your answer will come out to be 1 by a tan inverse x upon a. So this is a very good handy equation for you to remember. Like basically the integration of this thing, right, will be 1 by a tan inverse x upon a. This will be used. Like I think they have asked this multiple times. So if you remember it, good. If you are not able to remember this one, okay, and then use substitution to derive your answer. Similarly, you can derive for other values as well. Okay. Now one more important formula is there. I think that is not present over here. Yeah, the other important formula. This has low probability of getting asked, but if you are able to remember this one. So dx x square minus a square. This will be 1 by a, okay, sorry, 1 by 2a ln of x minus a will be at the top, then x plus a will be at the bottom plus c. So if you are able to remember this formula, that's good, but it's no problem if you are not able to remember, but this has a probability of getting asked, but low probability, okay, because like I am expecting GATE examiner also don't expect you to remember formulas, right? They want you to go into the concept. So that is the main purpose. They want to see whether you understand the concepts or not. That is their main purpose, okay. So this was a few important things. Now more more important things are there, like if anywhere you have this a square minus x square, then you can do this handy substitution, like x equal to a sin theta, right, or x equal to a cos theta, and then you can solve that. Like I'm telling you what are the methods to solve indefinite integration, right, with substitution. So if I have a square minus x square, what I can do is I can simply substitute. I can substitute x equal to a sin theta. So what will this equation become? This will become a square cos square theta, because I know this property. Sin square theta plus cos square theta is equals to 1. If I can use that property here. So whenever you will have something like this, right, some constant square minus x square, so you will substitute your x equal to a sin theta. If it is x square plus a square, if it is plus, then you will substitute x equal to a tan theta. Why? Because I will use this property. 1 plus tan square theta equals to sec square theta. So these things should come into your mind whenever you have a term a square minus x square. You will use this substitution. If you have x square plus a square, you will use this substitution. If you have x square minus a square, you will use this substitution. Okay. So only these two are important. Okay. This anyways you can take negative sign common, right? You can take the negative sign common and use this. Okay. So these are the standard integrations that I was talking about. So remember at least these two. Other ones it's okay. If you are not able to remember the other ones, I will not force you. So this one again the same thing, right? If I have a square minus x square, what will be the like integration? This will be sin inverse x upon a. So you will do the substitution. So I know what is 1 square minus x is x square. So I can easily calculate the back integration. But what am I thinking is, okay, is this correct? Let me just do once. Let me just prove it once. So this will be, let's take x. Oh yeah, this will be correct actually. Yeah. If I take a square common, this will come out to be 1 by a. And here I will have a term that is dt by a, right? So that a and a, not dt by a, sorry, a into dt. Yeah, that a and a will be cancelled. Yeah, this is correct. So basically I have proven here, right, tan inverse. So you saw that I had to replace my dx with dt into, like if I differentiate both sides, this will be dx will be equals to a into dt. Okay. So this will be dx will be equals to a into dt. So here what will happen? I will replace my so I will replace my dx with a into dt. So already a square is there. So one a and other a will be cancelled, right? That's because here a square was there, but here in the bottom there is, where is it? Yeah, here in the bottom if you see, if I take a square common, right, this is under root. So if this is under root, this will become a. So a, another a at the top will be cancelled. So that's why there is no constant term here. So intuitively also you can understand like what is happening. Why is there not 1 by a? So in your brain all these things should click. Okay. So these are the formulas. Just remember the sine inverse ones, this one and these one. These three are the most important ones. Other ones are there, of course, for like in comprehensive course we tell you to remember everything, but we are at the end stage now, so we have to ignore a few things. Now the second way to solve any integration is integration by parts. Okay. So if I have two functions u into v, I can use this formula. So what does it mean basically? If I have to, like, it is similar to chain rule. It is similar to chain rule, right? So because I am using the chain rule, I have derived this, like how this comes, but let us try to remember how can I write it. So what you will do, if I have two functions, right, u into v, so one function will be very easy to integrate, let's say x, and the other function will be very difficult to integrate, right? Let's say some very weird function, like sine square of x or something like that, right? Sine square of x or something like that. So if it is difficult to integrate, then what you will do, you will use this integration by parts. So you will integrate the easier function with respect to x, and you will keep it outside, you will keep the u outside, and then subtract it by integration of the differentiation of the difficult function multiplied by the again the integration of the previous function, and then ultimately I will integrate it. So we will do one example, and from there I guess we will understand it. So where is a example? Where are all the yeah, okay, this one is very difficult. Yeah, I can show you one example, very simple example. I can show you this function x into sine of x dx. Okay, so what will be the integration of this function? So seems very difficult, right? So what I can do is I can assume these two my v and these two my u. Why? I will tell. Like there is a rule, there is a eyelet rule, which one shall be chosen as u or v. There is a rule. So I will explain that, but let's solve this one first. So this, if I solve this one, right, this will be so I will use my formula by parts. So first I will integrate this one and I will keep it as a constant. Why? I will explain. So this will be treated as constant. This will be sin x dx plus, then I will integrate. Now I will differentiate this function because this was treated as constant, that is 1 into the integration of the inside function again, that is sin x into dx. So this will be equals to minus of x cos x. Remember, okay, yeah, sorry, this will be plus only, right? So because the differentiation of sin x was what? Cos x. So that's why integration of sin x will be, integration of sin x will be minus of cos x. Okay, don't mess this up. So because this is here as well. So like I know this confusion will be there. I think, yeah, here. So integration of sin x will be minus cos x. Why? If I differentiate on both sides, this will be sin x, and differentiation of cos x is minus sin x. So minus into minus will be plus. So yeah, this confusion is there. So please practice a bit more so that this confusion gets clear. Like differentiation and integration are both opposite, dual, right? So be careful. So x into cos x plus, and this will be again integration of sin x, that will be again minus of cos x, and plus c is also there. Okay, so this will be the integration basically. So this seems bit complicated, but here it is simplified. Okay, so why have I chosen x to be my like u? Because if I would have chosen x to be my v, right, then here it would have been simple. This would have been x square by 2, no problem. But this would have been more complex, right? So here integration of, so differentiation of sin x would have been cos x, but integration of x would have been x square by 2. So this would have complicated my stuff, right? So I have to integrate this function, which would have been more complicated. So always try to think of something that will make my u, like differentiation of u, some constant or something that will be easier for me to solve. Okay, so there is a rule known as eyelet rule. So first, which one shall be chosen as your like integration function? So if I have some inverse trigonometric function, never choose that. That will be the most difficult, right? So if you have exponential, that will be chosen as your integration function. So basically, if I have some x into e raised to power x, so which one shall I choose to integrate? Obviously, your e raised to power x, right? If I choose x to be the integration function, right, then this will become x square by 2, and then again I have to integrate this one. That will be very difficult, correct? So whichever ones are easier to integrate, you will choose that. So there is a eyelet rule. So eyelet meaning I for inverse trigonometric functions, L for logarithm, A for algebraic functions, T for trigonometric, E for exponential. So your order should be this one. So if you have exponential, that shall be your function to integrate. If you have, then after that you can choose trigonometric. So between, like, this is a algebraic function, this is a exponential. Which one will get the priority? Exponential. If I had x into sin x, as we can see from the example, so if I have a algebraic function, a trigonometric function, which one will be given the priority? Trigonometric function. Okay, so that's how you solve it. Now you don't even need to remember actually this one. Okay, I will tell you a very simple method to remember, that is the DI method. So how to solve using DI method? So you don't need to remember all these things. You don't need to remember because DI method will be used later on as well. Okay, DI method will be used later on as well. So let me show you what is the DI method. So let me take a new page. So if I show you what is the DI method, so in DI method, right, I will write my, so I have to integrate this function x into sine of x dx. So I will write here d, I will write here I. So I will be the function that I need to integrate. Here what I need to integrate, I lit. So e is exponential is not there, then I have trigonometric. So trigonometric function is there. So I will integrate my trigonometric function. So I will write here sin x. Okay, and what function I need to differentiate x. So now I will just follow a step. So I will differentiate x, that will be 1. Again I will differentiate, that will be 0. I will integrate my sine, that will be minus of cos x. Again I will integrate my cos x, that is plus of sin x. So this will be minus of sin x. Now you will write here plus minus plus. This is just a method, and trust me, this will help you immensely. You don't need to remember that like UV rule, right? So what you'll do now, you will multiply these two, and you'll go on, like if I have some function here, you go on till the multiplication is 0. Because I have a 0 here, I will stop, because 0 times anything will be 0. So I will stop. So I will write my, directly you will write your answer. Your answer will be x, like x into minus of cos x into minus sign is there. Okay, so okay, sorry, one thing I made a mess of it here. Negative sign was there, right? So this will be actually negative. Don't forget, negative sign was there, so this will be negative. So that's why these things you can forget, but this one you will never forget. This is a very good method, DI method. So I watched in YouTube only. So yeah, this will be x into minus of cos x, then plus, like you will not change the sign. This will be plus. What is the sign here? Minus. So minus into, like this will be plus, no problem. Minus into 1, like minus 1 into minus of sin x. Then plus 0 into anything is 0 only. So that is gone. So this will be minus of x. So this will not be sin x, right? Hold on a second. Oh, sorry. Because I had integrated this one. This will be minus cos x. Then again I have to integrate. Okay, that's what happens in this, like in this rule. I have to again integrate. So this will be integration of cos x is sin x. So minus will go outside. This will be x minus x cos x plus sin x. So yeah, that's why I don't like this method. So I can make mistakes. So yeah, here you will always get the correct answer. So this will be plus of sin x. Obviously at the end you will write constant. Now if you have to perform a definite integration, so let's say from x equal to 0 to x equal to pi by 2. So what you will do after you write this expression, right? If you have to perform a definite integration, what you will do, you will write here, like this same function, you will write x cos x plus sin x 0 to pi by 2. Okay, 0 to pi by 2. So then you will put the limits, because if I'm doing definite integration, constant will not be there. So you just put the upper limit and lower limit and solve this. So this was the indefinite integration solution. If you have to find out the definite integration, simply you put the upper limit here once, lower limit. So basically here once I will put this function equals to pi by 2, I will put all the values equal to pi by 2, and then I will subtract the lower limit equal to 0. I will put x equal to 0. That's it. So this is the best way to solve. I can take one more example, like let's say I have this example, right? So x into e raised to power x, okay, and I have to solve from 0 to 1. So I'm just telling you the definite integration here itself. So how will I solve it? Simply, which one shall I use as integration? E raised to power x. Which one shall I choose as differentiation? My x. So this can be like now this is much simpler. If this is, let's say, x cube, if this is, let's say, x cube, okay. So if you would have solved using this method, right, it will take you the whole exam. It will take you 2 hours to solve using this UV, like UV simple formula, right? Why? I will explain just in a second why. So this will be I, this will be d, okay, and here my d is x cube and my I is e raised to power x. So if I differentiate my x cube, this will be 3x square, and if I integrate my I, like e, this will be e raised to power x, and this will be 6x, this will be e raised to power x, this will be 6, this will be e raised to power x, this will be 0. Okay, then I will stop. Once I will get 0, I will stop. Okay, I will stop in that row. So now again plus minus plus minus plus. Okay, so this will be, I will multiply these two function, these two function, these two function, these two function. So this will be x cube e raised to power x minus 3x square e raised to power x plus 6x e raised to power x. I hope you get the point, right? But if I would have solved using my basic UV rule, right? So this would have been, so I would have chosen this to be my integration function, so differentiation function, right? X cube and this e raised to power x minus, I can put the limits later, and this will be integration of the differentiation, that is 3x square x e raised to power, integration of e raised to power x is e raised to power x dx, right? Don't like sometimes if I forget to write the dx, right, please forgive me, okay, because we are in a revision course, I have to follow the things pretty quickly. So now how do I integrate this? Again I have to apply UV rule. Again to integrate this, again I have to apply UV rule, and again another term will come x e raised to power x, like this will be 6x e raised to power x. Again you have to apply the UV rule. Ultimately you will get some 6 e raised to power x, then you will stop. So this will be very lengthy, right? So automatically whatever I'm telling, right, that is taken care of here, automatically those things are taken care, right? So this will be much lengthy for you to solve. So if you are enjoying this concept and if you enjoyed the DI method, put in the comments below, I have understood the DI method and I enjoyed it, and of course like the video. Okay, so yeah, this is a very good method to keep in mind. This is a very good trick. Okay, so use this trick. So that is my integration by parts. Now trigonometric integrations, I will tell you, not that important. I am expecting they will not ask. I'm expecting they will not ask from trigonometric integration. So we come back to our definite integration. So I hope you know bit about definite integration. So basically if I have indefinite integration, right, so I get a primitive. So to find out the definite integration from point A to point B, I will put the value of that primitive at B and A. So we can do few examples, and yeah, from that we can simply understand how to like solve this. Okay, so I think there was one more thing, trigonometry by partial fractions. That part is not there, but I don't think partial fractions would be that important, but I can take a very small example, trigonometric using partial fractions, before coming into definite integration, right? Let me take an example, trigonometric using partial fractions. So okay, one example is already okay, this was I was solving. So let me solve using partial fractions. So if I have to solve, let's say integration 1 by x plus 1, okay, into x plus 2 dx. So you cannot directly solve it, so I have to use partial fractions. So I can write 1 by, so I can copy this thing, equals to a by x plus 1 plus b by x plus 2. Okay, so if I multiply by x plus 1 into x plus 2, this will be what? This will be 1 equals to a into x plus 2 plus b into x plus 1. Okay, so like I hope you know how to do partial fractions. So if you don't know, like you can Google it, how to do partial fractions, or you watch a YouTube video. So now I can find the value of a and b. Like there is very easy method to find the value of a and b. So you can put the value of x equal to minus 1. Now if I put the value of x equal to minus 1, right, this will go away. So a will be equals to, if I put x equal to minus 1, this will be 1. So a will be equals to 1. And if I put my b equals to, sorry, x equal to minus 2, so this will be 0. This will be gone. So this will be, b will be minus 1, right? If I put here minus 2, this will be minus 2 plus 1, that is minus 1. So b will be minus of 1. Okay, that is what my a and b are. So there are many ways to solve this. Another way is to equate the coefficients. So how? So if I equate the coefficient of x, so what is the coefficient of x here? If I get this a inside, this will be a into x, right? So coefficient of x is a plus I have b into x. So coefficient of x is b on the left hand side, and on the right hand side, what is the coefficient of x? On the right hand side, the coefficient of x is 0. From there I get a relation, that is a equals to minus of b. So I am telling you different methods to find out the this a and b of partial fractions. And what will be your like another equation I can get is equating the constant terms. So here this will be a into 2, so this will be 2 into a plus b. Just give me 1 second. Oh, this is lagging, man. Sorry about that. This is why this is lag. This lags very much. So this is b like 2a plus b is equals to 1, because on the right and left hand side the constant term is 1. So I will put my a equals to minus b here. This will be b will be equals to minus 1 simply, and a will be equals to 1. So that's how you can also solve. There are many ways, and after you break it down, like now I hope you can easily solve. So this will be 1 upon x plus 1 integration dx. Like my handwriting will be bad because I'm doing revision. I'm just teaching you the concepts. I'm not focusing on the handwriting and stuff. So this will be 1 upon x plus 2 dx. Okay, and if I integrate this will be what? This will be ln of mod of x plus 1. Again you can use the substitution, that is t equals to x plus 1, right? So you will see that this will come out to be 1 by t, and integration of 1 by t is ln of t. So t you will replace with x plus 1. Similarly you will do the same here. So this will become ln of x plus 2. So your answer will be, don't forget, here I have a minus 1. So your answer will be finally ln of x plus 1 minus of ln of x plus 2 plus c. So if I can write my answer in a one single term, this will be ln of x plus 1 divided by x plus 2, okay, plus c. That is what my log, that is what my solution will be. Okay, so yeah, this is my answer basically. So yeah, that's how you can use partial fraction. So this was the third way to solve an integration. Okay, so yeah, there are few trigonometric identities. We will ignore that because I am not expecting they will ask from that. So let's come back to our definite integration. Okay, so we will solve a definite integration like this, and we will see what I can do. So here we have a definite integration, so we have to integrate this function. So whenever the square root is there, I don't like square roots, so I will rationalize my term. So if I rationalize, like what I can do is I can multiply 1 minus x on both sides, on both numerator and denominator. So this will be, if I multiply 1 minus x on the numerator, under root, don't forget under root, right, or inside the under root. So this will be 1 minus x whole square, and this is under root, so this will become 1 minus x. So 0 to 1, 1 minus x divided by under root 1 minus x square dx. Okay, now I can again break it down. So this will be 1 upon under root of 1 minus x square dx. Okay, I will put the limits later on. Okay, don't shout in the comments below that put the limits. Okay, this will be minus of x upon under root 1 minus x square dx. Okay, now I know the integration of this. It is sine inverse of x, correct? But do I know the integration of this? I can again use some substitution. So what I can do is I have x over x into dx, and when do I get x into dx? So if I, like this, you will understand with more practice that what thing you have to take as t to properly solve this. So here my t can be x square. I can assume my t to be, can I assume my t to be x square? No, let us assume our t to be 1 minus x square. That will be the best assumption, 1 minus x square. Why I will tell. So if I assume my t to be 1 minus x square, so what will be my dt? Dt will be minus of 2x into dx. So what will be my dx? Dx will be minus of dt upon 2 x into dx, because I already know that x into dx is somewhere here at x into dx. So whenever you have x into dx, you always will try to substitute x square. I will not substitute just x square, I will substitute 1 minus x square. Why? You will see. So here what I will do, this will be equals to sine inverse of x, that is already there, minus, okay, minus, and already a negative sign is there, right? X dx is minus of dt by 2. So minus minus will become plus, and this will be dt by 2 under root of t. Okay, yeah, because t is 1 minus x square, so under root of t. So now if I solve this, this will be much easier for me to solve. This is nothing but like t raised to power, like I have to solve the integration. 1 by 2 can be outside, t raised to power minus half. I have to solve this particular integration, right? What will be the solution of this particular integration? The solution of this particular okay, whenever you are doing substitution, now you have to be a bit careful. You have to be a bit careful. Why? You have to take care of the limits as well, because what was the limits here? The limits was 0 to 1. Okay, but these limits were for x equal to 0 to 1, but as soon as I am doing some substitution, you make sure you are changing the limits, because here this is dt, this is not dx anymore. So if my x is 0, what is my t value? So when my x is 0, my t value is 1. When my x is 1, my t value is 0. So if x is going from 0 to 1, then my t is going from 1 to 0. So I will change my limits of t, so t will go from 1 to 0. So be careful regarding this. So whenever you are doing some substitution, you make sure you are changing the limits, or the other way around is, once you have solved the integration, right, in terms of t, you substitute back x. That will work, anyway will work, but I am comfortable with this one. So I will write here, this will not be 0 to 1, this will be 1 to 0. Okay, so t raised to power minus half dt. So this will be basically n plus 1. So half divided by n plus 1, that is half, and half is already there, this will be cancelled. Okay, and your t value will go from 1 to 0. So this will be, I will put the value of t equal to 0 in the first case, so this will be 0, and I will put the value of t equals to 1 in the second case, this will be 1. Okay, so overall this integration, like this integration comes out to be minus of 1. Okay, what about this integration? So here again I will put the limits. I will put the limits. So my limits will be x equal to, now this is the x, right? So x equal to 0 to x equal to 1. So this will be sine inverse of 1 minus sine inverse of 0. Okay, so this will be, what is sine inverse of 1? It is pi by 4, right? Sine inverse of 1 is pi by 4, or pi by 2, and minus sine inverse of 0 is 0. So this result comes out to be pi by 2, and this comes out to be minus 1. So your overall answer will be pi by 2. Overall answer will be pi by 2 minus 1. So it is 1.57 minus 1. So almost 0.57, right? Yeah, pi by 2 minus 1, 0.57. So 0.57 will be your answer. So that's how you will solve a definite integration. So we did substitution, we did a lot of things here. Okay, we rationalized, we understood a lot of things. So what is the geometric understanding of definite integration? So we mathematically solved it. What does this value mean, like 0.57? This value basically means the area. Like I know you have studied in your undergrad and your class 11, right? This value between a to b means nothing but the area. Okay, so definite integration gives the effective area between two limits, between a and b. Okay, like if I am, let's say, like this is my function. So if I plot the function over the graph, and if I have been given two limits a and b, if I perform the definite integration, I will get the area. So there is a concept called a strip. All those things are there, that we will discuss in multiple integrals. So we will not discuss here. So like now one more thing is there, that area can be, although we know that area is a positive value, area can never be negative, but mathematically area can be negative. So whatever area I am getting above x-axis, that will be positive. Whatever area I am getting below x-axis, that will be negative. I am not explaining you the strip and all those things because we don't have time. Okay, so whatever area I will get above x-axis, that will be positive. Whatever area I will get below x-axis, that will be negative. Okay, so I hope that part is clear. So again, if I have, we can use definite integration by parts. So without using this UV rule, right, I can directly use what? I can directly use my DI rule. That will be the easiest one. So I will always use my DI method. So here, if I use my DI method, so in this case, which function shall be chosen to integrate? So here I have only a single function ln x, but I can do one thing. I can multiply by 1. This will be 1 into ln of x, 1 to e dx. So whenever you are solving integration by parts, don't worry about the limits. Okay, just solve it normally, then put the limits at the end. So here, which function shall I choose to integrate? So simply what you can do is you can choose, just give me 1 second. Yeah, you can choose your this function as the integrating function, right? Because it was islet rule, islet. So first preference would be exponential, then trigonometric, then algebraic. So then logarithm, right? And this one is a algebraic function. It is nothing but x raised to power 0, correct? So I will choose this one as my integrating factor. So this will be integration. So I will again write d and I. So I will be this time 1 and d will be ln of x, okay? And this will be 0 and this will be 1 over x. Yeah, differentiation of this will be 1 over x, and this will be anywhere 0, right? So I don't need to go further. This product will be anywhere 0, correct? So I don't need to go, sorry, wait, let me properly write it. This is 1 0 0. So I don't need to write further. This will be, just give me 1 second. The differentiation of, sorry, so what I'm doing, I'm integrating, right? What am I doing? I'm integrating. So this will be x and this will be x square. And what will be the differentiation of this? This will be minus of 1 by x square. So this will go on. So this will forever go on. So when do I need to stop basically? So let me solve this for a second and then I will explain what do I mean by it. So this will be x ln of x minus 1 by x into this, right? That will be x. Now this will be again, this will be x square divided by 2 actually, integrating this. So this will be x by 2 and this will be x cube divided by 6. So here, right, this is becoming like a never ending series. So what I will do, I will stop till this point. So whenever this comes to be a never ending series, right, what you will do is you will perform this operation, okay, and perform this operation with integration sign. So if you are performing a linear operation, there has to be an integration sign. So this one thing you have to remember in DI method. So what you will do, I will multiply my ln of x into x, right? That will be there. Then minus sign is there, into 1 by x into x. Then as I am stopping here, right? Because of course this is never going to, this thing is never going to 0, neither is this thing going to 0, correct? So this integration sign I have to put because I am stopping in the same line. So I will stop in the same line. So I will put an integration sign. So this will be my answer, okay? And integrating this one is much simpler for me. So of course, if you are putting integration sign, you have to put dx, right? So this will be x ln of x minus of dx, that is x. And now you will put the limits. At the end, you will put the limits. So 1 to e, this will be equals to e will be ln of e is 1. So this will be e minus e, that is 0 only, okay? And minus 1 ln of this is 1, this is minus 1, this is already negative, minus of 1. So this will be 1. So 1 will be your answer. Now this is the answer, that's it. But if you want to verify, always you can verify, okay? If you ever feels like if you ever feel like I'm doing some mistake, like I'm talking about you're doing some mistake in integration, you differentiate this function. If you differentiate this, right, this will be x into 1 by x plus x into 1 by x plus ln of x minus of 1, okay? This will be ln of x. So basically the differentiation of this is ln of x. Now if I integrate on, just hold on a second, yeah, integrate on both sides, this will be integration of ln of x is this particular thing, right? So that is what we have solved. So if you are doing some integration and you feel like I'm making some mistake, always differentiate this and you should get back your same function that you try to integrate. As in our case, it was ln of x and I got my same function. So whatever we have solved is correct. So that's how you solve basically. If you have a never ending series, you will stop in the same line, which one you feel is very easy to integrate. So 1 by x into x will be 1. So that is very easy for me to integrate. So I will stop in this second line, okay? So now there is one more thing, that if my differential, right, it is not with respect to x, it is with respect to ln of x. So if I have a equation like this, right, where my x square d of ln of x. So this ln x is the limits of the integration. So your ln x will be equals to 2, that is my upper limit, ln x equals to 1 is the upper limit. So if I had here dx x square, then your x equals to 1 was your lower limit, x equals to 2 was my upper limit. But here I have ln x, so I have to integrate with respect to ln of x. I have to integrate with respect to ln of x. How can I integrate? So first method would be, if you are not comfortable with this, right, so what you will do, you will use substitution. So you will assume ln x equals to t. So my dt will be what? Dt will be 1 by x into dx, correct? 1 by x into dx, dt will be equals to 1 by x into dx, and yeah, that's it basically. And your, what will be my limits? So if ln x is going from 1 to 2, so your t is going from t is also going from 1 to 2. Now what is my x? X is equals to e raised to power t. So I will replace everything in terms of t over here. So x square will be e to t, x square will be e to t. This will go from 1 to 2, then d of ln x, that is dt. Okay, so this will be, remember these are my limits of t, and limit of t is same as limit of ln of x. So this will be e raised to power 2t upon 2, limit I will put 1 to 2. So this will be e square e raised to power 4 minus e square upon 2. Okay, that will be my answer for this question. Now if I would have solved it using a different method, so there is another method as well. If you want to solve, so what you can do, you can assume your d of ln of x. What is d of ln of x? So I can multiply and divide by dx. Okay, so dx dot d of ln of x upon dx. So what is d dx of ln of x? It is 1 by x. What is the differentiation of ln of x? 1 by x. So this will be 1 by x. So my d of ln of x is dx upon 1 by x. Now if your ln of x is going from 1 to 2, what will be your x going to? So what is my, so x will go from x equal to e to x equal to e square, correct? So the limits of x will be x equal to e to x equal to e square. So basically what I am doing, I am replacing everything in terms of x. So my integration, this will be x square, this will now be dx upon x. That is what my d of ln of x is. This will be e to e square. Okay, so this will be equals to x square upon 2 e to e square. So this will be equals to e square e square square, that is e raised to power 4 minus e square upon 2. Okay, so that will be the like answer for this particular question. So we can verify we are getting the same answer. So either way works. I prefer the first one, or second one is also very good. Okay, whichever is suitable to you. Okay, so that is the key point about definite integrations, that if I have a definite integration, we have to change the limits of integration every time we make a variable substitution. So just be careful regarding that. So few properties, there are many properties which we will use for definite integration, like this one. If I have an integration that is f of x, that is going from a to b, I can have same, it can be, I can replace my x in terms of t. So where x is just a dummy variable, it can be anything, right? It can be x, alpha, beta, gamma, anything. But make sure when you're doing this conversion, make sure you're also changing the limits. Limits can also be changed. Now one more thing, if I swap the limits, if let's say I don't want to go from a to b, if I want to go from b to a, then I have to just to I just have to multiply a minus sign. The proof has been given over here. Okay, so one more thing is one more property is that take a break. So if I have to, let's say, find out the integration from 1 to 3. Okay, so I can find out the integration from 1 to 2, and then again I can find the integration from 2 to 3. Sometimes that is convenient for us. We will see when that is convenience, we will use that property. Okay, so this is a property of integration. Now one more thing is there, for you to perform the definite integration, right? You have to understand that function must be continuous in this range, otherwise your integration will not work. You will not get a proper value for integration. Okay, so I will take an example like tan x. So we know tan x is continuous just from 0 plus, sorry, from minus pi by 2 to pi by 2, minus pi by 2 plus to pi by 2 minus, because exactly at pi by 2 it is going to infinity, correct, and exactly at minus pi by 2 as well it is going to infinity. So if I have to solve the integration of some tan function, right, that is from minus pi to pi, I can break it down. So I will not include pi by 2 because here pi by 2 and minus pi by 2 are getting included. So I can break my integration down. So I'm just taking an example. So I'll break it down into my minus pi to minus pi by 2, and then again I will solve from minus pi by 2 to uh, plus pi by 2, and like this. Then again I will solve from pi by 2 to pi. Just I'm doing this in rough, but I hope you get the idea. So I will not actually cross the point where my function is discontinuous. Okay, I will not cross the point. So there are few examples like this. Okay, the greatest integer function. So we know, let me first plot the function, the greatest integer. Okay, I have directly gone to x square. Directly we have gone to x square. So let me first plot the function. Okay, so x square, like we are going from 0 to 1.5. So while going from 0 to 1.5, if I plot the function, right, when my x is equals to 0 0.1, 0 0.2, 0 0.3, if it is less than 1, the square also will be less than 1, positive. So it always lies between 0 to 1, where 1 is excluded. So greatest integer of 0 to 1 is always 0. So when my x will lie between 0 to 1, it will be always 0, and at exactly 0 it will be 0, and at exactly 1, when my x will be exactly equals to 1, there will be open circle, and at exactly equals to 1 the function will be 1. Correct, the greatest integer will be 1. Now when will this be 2? When will this be 2? When my x square is exactly equals to 2. Before it will never be 2. So what is the value of x? So when my x is under root of 2, that is 1.414, right, then this function will be 2. Okay, so at x equals to, I will go from x equal to 1 to x equal to 1.414, not 2 anymore, and there will be an open circle here, and there will be closed circle here at x equals to 1.414, because my y will be 2 here, and it will go on. I don't care till what, but because I am only concerned for 1.5, if I do 1.5 whole square, it will be 2.25. And what is the greatest integer of 2.25? 2. So my concern is till x equal to 0 to 1.5. So I will only plot the graph from x equal to 0 to 1.5. So I see there are few discontinuities, like at x equal to 1 there is a discontinuity, at x equal to 1.414 there is an discontinuity. Okay, so I will break my integration. I will break my integration. So what I will do is I will integrate, because I can see the points of discontinuity. I will integrate from 0 to 1. Okay, I will integrate from 0 to 1 into the greatest integer. So what is the value of the function between 0 to 1? It is 0. So I will replace the value of the function with 0 dx, plus I will integrate from 1 to 1.414, because till then the function is constant. So I will integrate till that point. Okay, I am not integrating at 1, because if I include 1, right, there is a discontinuity. So I will never include 1. Okay, make sure you always break your limits wherever there is discontinuity. So this will be 1 to 1.414, or under root 2 I can say. And at under root 2, what is the value of my function? The value of the function is 1, right? So it is 1 into dx, then plus, next I will go from 1.414, that is under root 2, till 1.5. So what is the value of the function? 2. Okay, so we will start from under root 2 to 1.5. Just keep this in mind, we are never including this point under root 2, 1. We are never including this point, because at this point the function is discontinuous. So we are never including this point. So this will be 2 dx, and this will be equals to uh, this will be equals to under root 2 minus 1 plus under root 2, sorry, 1.5 minus under root 2. So ultimately this value will come out to be 1.5 minus 1, that is 0.5. So 0.5 will be your answer. Let me correct here, just give me 1 second now. Under root 2 will go 1.5. Yes, we are going from 0 to 1.5. Yeah. Yes. So yeah. Okay. One slight mistake I made. This is 2, right? Here I have 2. So this 2 will come outside. So this will be 2. So this will not be exactly 0.5. This will be 3 minus 1, that is 2, and minus under root 2. So 2 minus under root 2, that is 2 minus 1.414. So approximately whatever this value will be, that will be your answer. Now this is a very important thing, because from this concept, right, multiple times questions have been asked, and multiple times people have solved wrong. Like all the mathematics, like whatever solutions they gave you, right, they give you wrong answers, because what they do is they directly integrate like tan x from minus pi to pi, and they get some weird value. Okay, and they tell you that is the solution, but that is not the solution. Always whenever there is discontinuity, you have to break your integration. So be careful while solving the definite integration. So like what I am teaching you, right, even in full course they don't teach you all this. So in full course, if you go into other institute, they will teach you directly from the double integration part, because they expect that you already know all these things. But in PrepFusion we teach everything from basics, and obviously I will teach you the highest level. This is the highest level. Please take care whether the function is discontinuous or not in the given range, okay, for definite integration. Okay, so there is another question. This is the other question. So we have to solve this question. Okay, so this question is dx upon 1 plus 2 sin x. So don't worry, just see my solution, how am I solving it. You don't have to worry that, sir, will I be able to solve in exam, because few substitution I will make that might not be comfortable to you, and that is fine, because they gate also does not expect you to solve all this. But with this I am trying to explain a very important concept. Okay, so what we can assume is I have here 2 sin square x. So I will multiply by sec square x on both sides. Okay, on both numerator and denominator. So this will be sec square x. So let me reduce the size. Sec square x dx upon sec square x. Now sec square x is also 1 by cos. So this actually becomes sin by cos square x, that is tan. So this will be tan square x. Okay. So now I will make a substitution, that is t is equals to tan x. That's why I am telling you, don't take stress that how will I be able to solve this. I'm not expecting like these kind of questions will be asked, but I have to explain a very important concept. That's why I'm solving it. Okay, t equals to tan x, but like this one I hope we can do, right? So always whenever you have some sin square x, you can multiply by sec square x, and you know the differentiation of tan x is sec square x. That's why I will choose t equals to tan x. So what will be dt? Dt will be equals to sec square x dx. Okay, so what are the limits? So limits is t is going from tan x is going from 0 to pi. So if x is going from 0 to pi, what is tan 0? Tan 0 is 0, right? So if x is going from 0 to pi, so t will go from what? 0 to 0. And there is one property. There is a property basically, if I have same limits, right, a to a, any function I have, that will always be equals to 0. If I have a function that is always like the limits are same, basically the area will be 0, right? Because if I'm going from the same limit, I'm not crossing the graph, right? I'm just integrating a point, that is 0. So that's why this will be 0 if the limits are same. So your answer will come out to be 0. But you're wrong. Your answer will not be 0 here, because your function is not continuous in the range. Why so? Because if I put, once I make this substitution, I have to take care for the complete range x to 0 to pi, this should be continuous. But is this continuous? No. This is not continuous, right? This is not continuous, because at tan pi by 2 this is going to infinity. That is not a finite value. So I have to break my limits. So I cannot go from x equal to 0 to pi. I have to break it down. So I will go from x equal to 0 to pi by 2, and then I will go from pi by 2 to pi. So I will break it down into two parts. So what will be my limits of t? So t will go from 0 to infinity minus, exactly not infinity, infinity minus, because exactly at pi by 2 it is getting basically discontinuous. So it will be pi by 2 minus, and t will be very high value. Okay, t will be very high value, but not infinity, because I cannot ever be equals to infinity, right? Because infinity is always increasing. And again from pi by 2 plus, to pi again. So I will go from infinity to 0. So you will see what kind of difference it makes. Sorry, pi by 2 plus. So once if this is pi by 2 plus, right, my tan, I have told you what is the domain of tan. Domain of tan is from minus pi by 2 to pi by 2. Or if I plot my tan function, right, if I plot my tan function, so at pi by 2 minus, what is the value? It is very high value. Pi by 2 minus, it is very high value, that is something very positive infinity. At pi by 2 plus, what is the value? Because it is discontinuous about this point, right? At pi by 2 minus, it is very high positive value. At pi by 2 plus, it is very high negative value, minus infinity. I hope you remember the graph of tan. I have taught you the graph of tan x, right? So this will be minus of infinity. So that's why we had to break it down. So for pi by 2 plus and pi by 2 minus. So pi by 2 minus, I will replace my t with plus infinity. Pi by 2 plus, I will replace my t with minus infinity. So this will not be infinity, this will be going from minus infinity to 0. Okay, because pi by 2 plus is minus infinity. So now if I make the substitution, so I know my sec square dx is, so first of all I will break this integration. So currently this integration is from 0 to pi. So I will break this integration from I will break this integration from 0 to pi by 2 minus sec square dx, and I will break my integration from pi by 2 plus to 0, same value. Okay, not 0, sorry, pi by 2 plus to pi. So now I can use the substitution. Now the function is not discontinuous anymore, because there was a discontinuity here. This was plus infinity, this was minus infinity. There was a discontinuity here, right? So now I can break it down, properly write it down. So this will be right. So the first integration will be now t x0, that is t0, x pi by 2 minus, that is t infinity, and sec square x dx is nothing but dt. So I have dt here upon sec square x. Okay, let me convert this thing. So I can convert this thing, right? So what is sec square x minus tan x? So I know my sec square x minus tan square x equals to 1, right? You can derive it from sin square x plus cos square x, that you can derive. So I can replace it over here, right? I can replace my sec square x with 1 plus tan square x, because I want to write everything in terms of tan, because t is equals to tan x. So sec square x will be 1 plus tan square x. So this will be 1 plus three tan square x. Okay, this will be 1 plus 3 tan square x dt upon 1 plus 3 tan square x, and same for the other one as well. This will be going from minus infinity to 0 dt upon, give me 1 second, 1 plus 3 tan square x. Now one property I know, not tan square x, sorry, one yeah, this will be 1 plus 3 tan square x, and what is tan x? Tan x is t, so I can directly replace this with 3t square, okay, dt upon 3t square. So I can solve this equation now. This will be what? This will be if I take my so I can use this substitution. So because I know this formula, right? I know 1 like 1 upon 1 plus t square. This integration will be tan inverse of x or tan inverse of t. So I hope we can do the substitution now. So once you will do the substitution, like I'm not doing it, the final answer, like I have it written over here, that will come out to be is pi by root 3. You can solve it. The final answer will come out to be pi by root 3. Like what I am trying to explain, it is not 0. It is not 0, right? Here I have solved it 0. It is not 0. So just be careful regarding this. My purpose of taking this question was to show you that yes, you have to solve properly. Otherwise, if you make substitution and if your function is discontinuous between the points, then you'll mess up. So just be careful regarding that. And trust me, no one will teach, like no one will give more emphasis on this. And in GATE, these type of question has been asked. These type of question has been asked in GATE examination. So that's why I'm putting emphasis on this question. Okay. So yeah, that's how you will solve like this question. One more property I can use, as this is a even function, right? So if I replace my t with minus t, I can write this. This is a even function. Okay. So for a even function, if I replace my t with minus t, this will be same. So I hope that point is clear. Like I wanted to just explain, wherever the definition of the function will change, you have to be very careful. Like I will give you an example. Let's say minus 1 to 1. Okay. Mod of x dx. So where will the definition of the function will change? Definition of the function will change at x equal to 0, because before x equal to 0 it was minus x, after x equal to 0 it is plus x. So you must break your integration down to two parts. 1 to 0 it will be minus x, and 0 to 1 it will be plus x. So you must not directly integrate, you must break it down. So that's why this take a break property is very important to understand. Okay. So yeah, there are many more properties of definite integration. One is this: if I am going from minus a to a, right, this can be same as 0 to a f of x plus f of minus x. So we will use this property when my function is neither even neither odd. Okay. So let's say if I am going from 1 to 1 x cube plus x square, okay, dx. So this can be minus 1 to 1 dx. So this can be equals to basically 0 to 1 f of x, that is x cube plus x square, plus f of minus of x, that is minus of x cube, and minus of x square is x square only. So what happens? So ultimately this will be cancelled, this will be left out. So this will be 2 into 0 to 1 x square. Why so? Because x cube is an odd function, and if I integrate a odd function, right, if I integrate a odd function, if I am integrating from minus 1 to 1, what will happen? Basically the area, the negative area, like my drawing is bad, the graph will be somewhat like this. Okay, don't see my drawing. So negative area will be same as positive area. So both of these will cancel each other out. So ultimately ultimately that is what we will get. Negative area will be equals to positive area. That is what we will get. So for a odd function, the area will be 0. If I am going from minus a to a, the area always will be 0 for an odd function. And for an even function, if I show you the x square graph is this. So whatever is the negative side area, right, same is the positive side. Like for negative values of x, same area I am getting here. So it will be simply multiplied by 2. So that's why this became 2 times x square. So like from this property, there is a subset property, that is this one. If I'm going from minus a to a, and if my function is even, then this will become 2 into 0 to a, and if it is odd, then this will become 0. So if you want to remember it, you can obviously remember. Also you can understand it graphically. How am I solving it? Okay. So there is a proof. I will not go into the proof right now. We don't need to understand the proof. Now there is another property. Now if the limits are not same, if the limits are different, then how will I solve it? So if I have a limit function a to b, so that will be equals to integration of a to b f of a plus b minus x. This is a very important property, and this can help you out immensely sometimes. Okay, there is a proof, like proof is written over here. I will not go into the proof right now, but this property will help you out immensely. Like here, let's say I have to find out sine square of x. Okay, so this integration, let me write this. This is just a area, right? This will be some constant value. Definite integration will be some constant value. So I can assume that constant value to be equals to I. So I is equals to integration of 0 to pi by 2 sine square x dx. So I can again rewrite this one as f of a plus b minus of x. There is a proof, like that proof you can see in the notes. So this will be sine of, just give me 1 second, sine square of a plus b. So a is this one, b is this one. A plus b will be 0 plus pi by 2 minus of x dx. Okay, so this will be 0 to pi by 2, limits will not change. This will be sine square pi by 2 minus x, that is sine 90 minus theta. And what is sine 90 minus theta? Sine 90 minus theta is nothing but cos theta. Okay, so this will be integration of 0 to pi by 2 cos square x dx. This is equals to my I, right? So what I can do, I can actually add these two, both the left hand side and the right hand side. So if I add the two equations, so this will be 2i on the left hand side. This is just a constant number, right? I is just a constant value. So if I add the two and if I add the right hand side, right, I can take this integration inside, because for both of them the dummy variable is same, the limits are also same. So this will be 0 to pi by 2 sine square x plus cos square x dx. So what is sine square x plus cos square x? 1. So this becomes integration from 0 to pi by 2 dx 2i, and I is just a constant number. This will be, I will be equals to pi by 4. So this property can help you out immensely. Whenever you are in a doubt, this property can help you out immensely. Okay. So okay, one more property is there. So this is the most important one. This, if you want to remember, you can remember it, or if you don't want to remember, that is also fine. Like if f of a like is going from 0 to a, right, this will become a by 2 f of x plus f of a minus x. Like this comes from the proof of that previous property. Okay, there is some proof. If you want to remember it, that's okay. If you don't want to remember it, that is also fine. Okay, so now we will have few properties here for periodic functions. Okay, there are few properties for periodic functions. So let's say if I am integrating a function that is periodic with time period t, and if I am integrating from 0 to n times t, let's say for this example, let me take a periodic function. What function shall I choose? Whose area will be always okay. What kind of positive periodic functions we have? Okay, so if I choose like basic thing, I can choose sin x, right? So sin x dx, if I integrate it from 0 to 2 pi, it will be 0. If I integrate it from 0 to 4 pi, it will also be 0, because the area over 2 periods also will be 0, right? So 0 to n into pi, or n into 2 pi, sorry, will be always 0. So whatever is the time period of the sin x is 2 pi. That's why if it is n into t, right, it will be simply equals to n can come outside. Why? I can take an example. Let's say I have a periodic function something like this, and I know, okay, let me take this example. Let me take this example only. So 0 to t, then 2t. So I know the area from 0 to t, that is let's say a. Now if I am integrating from 0 to 2t, the same function, right? So I will get twice the area. So this will be 2 times a. So that is what is written over here. So if it is n times t, area will become simply multiplied by t, integration of a single period area. Okay, so that's how you can solve. Now if my function is shifted, right, if it's a periodic function, and if I'm calculating the area from 0 to 2 pi, that is 0 for a sin x, right? If I, let's say, calculate the area from minus pi to pi, that also will be 0. If you see, minus pi is here, and if I calculate this area, that also will be 0. So if I shift my function, right, both the limits are shifted by a, so that also will be same area. That area will not change because my function is periodic. Okay, that is the proof basically. So there are few properties over here, you can do it. If you ever tend to forget these properties, right, no need to understand it in formulae, just draw graph and understand it from there. Okay, so that's how you remember. Now this is the Leibniz theorem that I was explaining previously. Like if I have a function that is integration, okay, and if I want to, and the limits are both functions of x. So if I differentiate this function, right, the differentiation of the integration will be this value. Okay, the differentiation of the integration will be this value. This I have used in limits. Again, I will use. There is a proof. The proof is here. You can see the proof. Obviously, we don't have time for the proof, so I can use it. Okay, here. So if I have to find the limits, so I see if I put x equal to 0, this will be limit x going to 0 to 0. So this integration will be 0. This will also be 0. So 0 minus 0 is 0. 0 upon 0 is 0. So I am getting a 0 by 0 format. I can use my L'Hopital's rule. So you will differentiate this function. So if I differentiate the numerator and the denominator, this will be 1 minus differentiation of this. How will I differentiate? First of all, you will always differentiate the limits with respect to x. So differentiation of the upper limit will be 1 into, then I will put the value of the upper limit in this function. So this will be cos of x square minus differentiation of the lower limit. So if your differentiation, if your limits, right, are of constant functions, they are not functions of x, so it will simply be 0, because differentiation of a constant number 0 is 0. So 0 multiplied by anything will be 0, so I don't have to worry about that. Okay, if like this properly, if I would have written it, this would be cos of 0 square. That would have been a proper notation. That is what I have used here, and this I have already taught in limits. Again, I am revising the concept, and divided by whatever this differentiation is, this will be 3x square minus 6, and then you can solve the limits. I am not solving it because that is not of my concern. Okay, so yeah, now there is one very important formula. This unfortunately you have to remember. You have no other choice than to remember it. This has been asked previously, so I will tell you, please remember this formula. Without this, you will not be able to solve the questions that I am talking about. Okay, so here this is the basic formula. So if I have any function sin raised to power m into into cos raised to power n, then the answer, right, if I am integrating from 0 to pi by 2, the answer would be this. Okay, it will be either k times pi by 2 if m and n, that is basically both the powers, are even. If one of the power is odd, then it will be k. Even if one of the power is odd, then it will be simply equals to k. So that's how you will remember it. Okay, so if I have to integrate sin raised to power m into cos raised to power n, it will be k into pi by 2. Remember, the limits must be same. It must be 0 to pi by 2. Okay, it must be 0 to pi by 2. Then if both the powers are even, it will be k into pi by 2. If otherwise, it will be k. And what is k? K is this. Let me take an example. With that, we will understand. So if I have to integrate between 0 to pi by 2, this function. Okay, so what is n here? N is 0, so n is even. Cos raised to power 0, right? Cos raised to power 0 I have, and sin raised to power 10. So m is 10. M is 10 over here. So both are even. If both are even, the answer will be k into pi by 2, because the limits are also same, 0 to pi by 2. So answer is k into pi by 2. Okay, answer is k into pi by 2. But what will be the what will be the value of k? What will be the value of k? So the value of k will be equals to m into, I will start from m minus 1, m minus 3, and I will go on till 1 and 2. What do I mean? So here my m is 10, so I will start with m minus 1, then this will be m minus 3, and I will keep on reducing 2. This will be m minus 5, 10 minus 7, and 10 minus 9. So I will go on this till point. After this point, I will stop, because now this will become less than 0, that is negative. So I will go on till the point where this does not become negative, divided by, and already n is equals to 0. So if n is equals to 0, you don't have to write this term. You don't have to write this term, right? So divided by, now the bottom will be m plus n minus 2 till 1 or 2. So m plus n, right? What is m plus n in our case? M is 10, n is 0. So m plus n will be 10. And then I will go from 10, I will again reduce it by 2. So numerator I had m minus 1, this will be m plus n, and there will not be any minus 1. There will be minus 2, minus 4, and so on. So 10 into 8 into 6 into 4 into 2, and then I will stop, because if I do 2 minus 2, I will get 0. So I don't want 0. I would never want 0. So I will stop before I get 0. So this will be, the answer will be, this will be 9 9 into 7 into 5 into 3 into 1 divided by 8 into this, right? So 10 into 8 into 6 into 4 into 2. So this will be 3, this will be 2, this will be 2, this will be okay 3. I cannot divide by 3 anymore, I cannot divide by 7 also. So this will be 21 divided by what is this value, 4 into 4, 16 into 8, 16 into 16, 256, 21 by 256. So one more thing is there, I forgot to multiply by 3, right? So this will be multiplied by 3, 63 by 256, and remember this is just the value of k. What is my answer? K by 2. So my answer will be 63 by 512 pi. Now have I taken, yeah, I have taken this one. Before taking this one, I want to verify whether I am doing this correctly or not, whether this formula actually works or not. So let's take a very basic example. Okay, the example would be integration of sin x cos x from 0 to pi by 2. Or can I take something else? Yeah, let me take this only. So integration of sin x cos x. So by the formula, all the powers are odd, right? Sin raised to power 1, cos raised to power 1. So powers are odd. So my answer will be simply k. If any one of the power is odd, answer will be k. And what is the value of k? K will be starting from, so here my n is 1, right? So n and m both are 1. So I have told you, you have to stop in the numerator when your n, like n minus 1 or whatever the value is, it is 1, right? So for n as well and m both will be 1. So 1 into 1, because you have to stop at 1. So 1 into 1, okay, divided by, in the denominator it will be m plus n, that is 2. M plus n, then m plus n minus 2, that is 0. So I will stop at 2 because m plus n minus 2 is becoming 0, right? 1 plus 1 minus 2 is 0. So of course I will stop at the non-zero value, that is 2. And if already this is like 1 and 1, so I will stop at 1 itself. If let's say this was 2 and 2, then I would have stopped here at 2 itself. I would have stopped at 2 itself, because after 2, right, I will do 2 minus 1, that is 1 only, does not make any difference. And here also, like then after, if I want to subtract 2 minus 3, that will be negative. So definitely I will not do that. Okay. So this will be, k will be 1 by 2. So your answer will be 1 by 2. So let us verify it. So what is my sin x cos x? It is sin 2x upon 2, right? So this will be actually equals to 1 by 2 integration of 0 to pi by 2 sin 2x upon 2. 2 I have already taken outside. So this integration would be minus of cos 2x. So 1 by 2 can be outside, and 1 by 2, another 1 by 2 will be there. So minus of cos 2x 0 to pi by 2. So when I put here pi by 2, this will be minus of cos pi, that is minus of 1. So minus into minus 1 will be plus 1, and this will be cos of 0. Okay, just one thing, sorry, hold on a second. This negative sign I have already taken outside it. So let's not keep the negative sign again outside. I have already taken the negative sign outside. Okay, let me keep it. So cos of pi is minus 1, cos of 0 is 1, and I'm like, this is the lower limit, so this also will be minus 1. So minus 1 into minus 1 into minus 1 by 4, that is simply nothing but 1 by 2. And isn't that what we have done it here? Okay, so I'm just doing it quickly. So I hope you can do the integration. So you will get 1 by 2. So that is verified. So that's how you will solve basically. So there is another topic, that is definite integration versus area under curve. So these two things are actually different. Okay, integration takes into account the sign. Basically I can have positive area and negative area. The integration of definite integration from 0 to 2 pi of sin x will be 0. But if they are asking what is the area bounded by the x axis for y equals to sin x, is it 0? No. Basically we have to calculate the overall area. So I will take this as positive area, this also as positive area, overall area by the x axis. So what I have to do, I simply have to mod the function. So if they are asking me what is the area bounded by x axis, so I will do, area will be mod of f of x a to b. So So let's take an example, because when my function will be negative, the integration will be negative. But if they are asking area bounded by x-axis, then you have to consider both the negative and positive area. Okay, so just be careful. So similarly, we can do a question here. Find the area between the curve this and the x-axis. Okay, because this concept will be used in multiple integral, but let's stuck to basics right now. So from x equal to 0 to 2, if they're asking me area between x-axis and this, that means they're asking me the area bounded by x-axis. So it will be, this is my f of x. So my f of x will be integration of mod of x cube x yeah, this is x cube, right? No, this is x square. It has to be square, x square, because I will not be able to find out the roots of a cubic. So this mod, so I have to check when this function goes to negative, then the definition will change, right, from 0 to 2. Okay, so let me break this function. This will be x minus 2 into x minus 1. Now what are the roots? X equal to 2, x equal to 1, and x equal to 2. So if x is greater than 2, it is positive. Of course, I have odd roots, so this will be negative, this will be positive. So for x between 1 and 2, it is negative. So what will be my function replaced with? By the negative, correct? That is what my modulus tells me. So I will break my limits, because there is a discontinuity in the definition of the function. So from 0 to 1, it will be positive, because between 0 to 1, right, this is my 0, the function itself is positive, so I don't need to do anything. This will be x square minus 3x plus 2. But from 1 to 2, I see that the function is negative, so I will have to add a additional negative sign. So minus x square plus 3x minus 3x plus 2. Okay, yeah, dx. Of course, if I am not writing dx, like it is understood that dx is there. Okay, so dx will be there. So this will be x cube divided by 3 minus 3 x square divided by 2 plus 2x 0 to 1 minus, this will be x cube divided by 3 minus 3 x square divided by 2 plus 2x 1 to 2. Okay, so you will solve it, you will get some value. I'm not solving it, you can get the value. Okay, that will be the area bounded by the curve. Now what will be the area bounded by y axis? How do I find out the area bounded by the y axis? So then you will have to replace your function with g of y and mod of that. So basically you will have to, like, if they're asking find the area between the curve y square equals to 4 into x plus 1 and y axis from y equal to 0 to y equal to 4. So you will have to replace, like you will do opposite, right? So previously what we should do, I should write y is a function of x. Now I will write x as a function of y, and I will integrate this x dy. That will be equals to, like, I will do mod of integration of x dy, that is mod of g of y and the limits of y, because now I have to find out the area bounded by the y axis. That's why I will do this. If I had to find the area bounded by the x axis, then we used to write this. If I have to find the area bounded by y axis, we have to put x equal to g of y. So that is what we will do here. So what is my x? X from here, right, I can get my value of x. X will be equals to y square by 4 minus 1. X will be equals to y square by 4 minus 1, and then I will calculate the integration of this particular function, that is y square mod of y square by 4 minus 1 dy, where my y goes from 0 to 4. Y goes from 0 to 4. So this will be, now when does it become negative? When my y square by 4 is less than 1, it will be negative. Now what they have already given me the limits of y. Let's say if the limits of x equal to 0 to x equal to 1 would have been given, what you would have done, you would have replaced your x here and would have found out the limit of y. Okay, so let me keep it x equal to 3. So then what you would have done, limits of x are given, but you have to integrate with respect to y. So you will find the limit of y. So when x is 0, what is y? Y is 2. Okay, I'm only talking about the positive side of the y axis. Y is 2. So when x is 0, y is 2, and when x is 3, y is 4. Okay, I'm just taking an example. If they would have given you the limits of x, right, you would have found out the limits of y. But here in the question, they have already told you that your y will vary from 0 to 4. Now you might have another doubt that y square is equals to, if x is 0 equals to 4, so y can be plus minus 2, right? So don't worry, if this something like this happens, right, in the question they will tell you only choose positive value of y. They will tell you, they will mention. Don't worry, okay? So that's why this doubt would have been there in your mind. So I'm trying to clear every single doubt that is in your mind. So now when will this be negative? When my y square by 4 minus 1 is negative, that is when my y is less than, like, y minus 1 into y minus y plus 1, right? This is my function, less than 4, when it is less than 4, okay? Okay, no, let me not solve it like this. This will be y minus 2 into y plus 2 less than 0 basically. So I can plot the wavy curve again. So if I plot the wavy curve, right, I have a root here, minus 2 and plus 2. So if y is greater than 2, it will be positive, then again it will be negative, then again it will be positive, right? So between 0 and 2, y is negative, and I am going from 0 to 4. So I have to again break my integration from 0 to 2 and then from 2 to 4, because the definition of the function is changing. So first of all, I will replace, initially between 0 to 2, this function is negative. So what will be the, what will I replace? This will be replaced with 1 minus y square by 4, and from 2 to 4 this function is positive, so I don't have to touch it, and then simply you put the value of y and solve it. Okay, simple polynomial, you will be able to solve it. Okay, that's how you solve. So there are few standard areas that you must remember. The area of a triangle is half base into height. The area of a trapezium is this, right, distance between the sides and sum of the parallel sides into half. Now area of a sector, if it's a circle, right, area of the sector will be half theta into r square. How does it come? So basically I know what is the area of a whole circle. It is pi r square. This can be also written as 1 by 2 into 2 pi r square. So if the whole area is 1 by 2 into 2 pi r square, then this is what 2 pi, right? So what will be half the area? Half the area will be pi r square by 2. So this will be, like, this is nothing but the angle, right? 2 pi is the angle. So this can be written as half into pi r square, which is pi r square by 2. So from here I get the formula, that is half theta into r square. So that's how you can remember the formula. That's how you can remember the formula. Okay. Now what is the area of an ellipse? It is pi into a into b. Basically a will be the radius of the major or minor axis, and b will be the radius of the minor or like the other axis. How do you remember? When your a will be equals to b, your area will become pi a square. That is nothing but a circle, right? So your area of an ellipse will be half into the area of the major and the minor axis. So not the area, sorry, half into area of the, not the area, half in, so not half, pi into the length of the major and the minor axis. Let's solve this question. Find the area of the region in the first quadrant enclosed by the circle x square plus y square equals to 4. So if I plot the circle, right, x square plus y square equals to 4, and I have to find out the area in the first quadrant. First quadrant meaning when my x and y both are positive. So this is called as the first quadrant, second quadrant, third quadrant, fourth quadrant. There is a concept known as octet, that is for a three-dimensional figure. That will be the next topic, that is multiple integration. So what is the area of this region? It is very simple, right? Whole area is pi r square. This is 1/4, so this will be pi r square by 4. What is the radius? It is 2, right? This is x square plus y square plus r square. So this radius is 2. So this area will be pi r square, that is 2 square by 4, which is nothing but pi. So pi will be the answer for this particular question. So now, yeah, one more thing is there. The area bounded between two parabolas. So this we will prove actually, don't worry. When we will solve multiple integrals, there this will be proved. But if you are able to remember it, that also will be helpful to you. Area bounded between two parabolas. Basically, the common area, right? This is the common area, would be equals to 16 into AB by 3, where the functions are like this: y square equals to 4x and x square equals to 4by. Okay, don't worry if you are not able to remember it, I will prove it. Okay, because the next topic is calculating area between two curves. That is the next topic. There we can prove it. Okay, so this is a thing that you can remember, or if you don't want to remember, no problems, we will prove it in the next topic, that is multiple integrations. So let's start with the questions. So this is the like first question. So we have a function that is integration, okay, and then f of x decreases in the interval, in which interval f of x would decrease. That is what they are asking me, right? What interval f of x will decrease? So what I can do is I can simply calculate the differentiation, right? And I know that the when my function f of x decreases, right, the slope is negative. How? So let me plot a graph. So here my value of the function is decreasing, right? So what is the slope? Slope is negative. Here the function is increasing, slope is positive. So if I don't know the sign of my slope f dash of x, I can definitely comment regarding the like whether my function is decreasing or increasing. So I will find out f dash of x. So for that I have to use Leibniz theorem, right? So I will use Leibniz theorem. This will be 1 times e raised to power x into x minus 1 into x minus 2, and the other side is 0 simply. So my f dash of x is this. So if I use my wavy curve, right, so I will have a root at x equal to 1 and x equal to 2. And if my x is greater than 2, remember this term is always positive. E raised to power x is always positive, so this will not affect in the sign. Only these two terms will be affected by the sign, right? So when x is greater than 2, my function is positive. When it is less than 2, obviously I have a single root, so the sign will change. Then again this will become positive. So they are asking me when does my function decrease, that is when does the sign of the slope becomes negative between 1 and 2. So x belongs to 1 and 2 will be your answer for this particular question. Let's solve the next one. Give me 1 second now. So this one is a good question. Okay, so here you have been given this integral and you have to find out the value, and this is actually a recent question. So they are asking from that concept. They are actually asking from that concept. So first of all, this is a even function, right? Because cos itself is even and I am raising it to the power of 4 and 2, right? So you replace your x with minus x, right? You will get back the same function. So I can use the property of even function. So if it is going from minus a to a, I can do 2 into 0 to a, that is pi, into the same function, that is cos raised to power 6 plus cos raised to power 4x dx. Okay. Now I know that this function, right, will also be periodic. What will be the period? So the period will be like I know the period of sin x is 2 pi. The period of sin square x is pi. Similarly, if you keep on squaring it, right, if you keep on squaring it, the period will be simply halved. This will be pi by 2 and so on. So I know at least the period will be pi by 2. Like one thing is there. If I say that the period is 2 pi, right, I can also say the period will be 4 pi. 2 pi is the fundamental period. 2 pi is the fundamental period. 4 pi is also period. Similarly, multiple 8 pi also will be period, right? So I definitely know that pi by 2 will be a period. I definitely know that like some multiple will be pi by 2, right? That I definitely know. Okay, because I can see that as I am squaring it, the period is halving, correct? So what I can say is, if I am integrating between 0 to pi, I can do this substitution. So I can multiply by 2 and this can be broken down into pi by 2. Cos raised to power 6 plus cos raised to power 4 x dx. Why? Because let's say I have a function that is periodic with 2 pi. So if I am integrating by a multiple of 2 pi, right, 4 pi, what will be the area? I have to multiply 2. So that's why if I know the function is definitely periodic pi by 2 with period pi by 2. So what will be the integration area of 0 to pi? I just have to simply multiply by 2. That's it. I simply have to multiply by 2. Okay. So that's how I am using my property here of integration. Now I can solve this. So now I know what is this value, right? This value is cos raised to power 6. So both are even here. So this will be k into pi by 2 for the first one, k1 into pi by 2, or let me write k6 into pi by 2 plus k4 into pi by 2. Okay. So what is my k6? It will be 6 minus 1 into 6 minus 3 into 6 minus 5, and I will stop here, divided by m plus n. M is 0, so m plus n into m plus n minus 2, that is 4 into 2, I will stop here. So this will be, for the first one, this will be 5 into 3 into 1 divided by 6 into 4 into 2. So this will be 3, this will be 5 divided by 24. What about, this is my k6, what is my k4? So k4 will be even easier, 4 minus 1 into 4 minus 3, I will stop, this will be 4 into 4 minus 2, that's it. So this will be 3 into 1 divided by 8. Okay, so yeah, this will be 3 by 8, that's it. So if I add these two, right, I can take pi by 2 common, this will be 5 divided by 24 plus 3 divided by 8. So this will become, I can multiply by 3, 9 plus 5, this will be 14, hold on a second, 9 plus 5, 14 divided by 24 into pi by 2. Okay, one mistake I have made here, this slide I am dividing this by 3, so this will be 2, that was my mistake. So this will become 16, this will be 16, so this will be 16, so this will be 11 by 16. Okay, and remember there was an extra 4 here, right? So my answer will be, my final answer I will be 4 times this, so this will be 11 pi by 8. So the answer will be C, option C will be my correct answer. So you will see, like, this is a very latest question, okay, and like there will be some big formula, they will use some gamma formula. So without the gamma formula we are able to solve it, okay, with Wallis formula. So like that's the beauty of this technique is. So you will see other solutions, you will see PYQs, they will use some formula, okay. So without that formula also you can solve it. So I have taught you how you can solve without the formula. So yeah, let's solve the next question. So we have this question where our function is given, that is 2 log of x, right, and we have to find the area bounded by f of x for the interval 0 to 2 on the x axis. So will this function ever go to like negative? I don't think this function will ever go to negative, because what is your e raised to power x? So e raised to power x, right, between 0 to 2 is always greater than 0. So that is, this is the graph of e raised to power x, right? So at 0 exactly it is 1, then it is always increasing function. So yeah, this will never be negative, so we don't have to worry about it. We don't have to worry whether the function will be go negative between the given range. But if it have been gone negative, then we would have had to take the mod function, okay. So the area bounded by this curve will be simply integration of ln of under root of x, that is e raised to power x raised to the power half dx, x varying from 0 to 2. So we know the property of ln of x, right? Anything is in the power, I can take it in front. So 2 and half will get cancelled. This will be 0 to 2 ln of e raised to power x, which is nothing but x. So simply they are over complicating things. I just have to find out the area from 0 to 2 of x dx. So this will be x square by 2 going from 0 to 2. Okay. So this will be 2. So answer will be 2. That's it. Answer will be 2. Option C. Let's solve the next one. The value of the integral from -1 to 1 x into e raised to power minus x. This will be simply 0. Why? For an odd function, right? If I am going from minus a to a, the integral will be 0. You can also solve it. But I can see if I replace my x to minus of x, what will happen? So this will be minus x into e raised to power mod of minus x. It does not matter. Mod always will make it positive. So it will be minus x into e raised to power mod of x, which is nothing but minus of f of x. So your f of minus x is minus of f of x. So it's an odd function. So integration will be 0. That's it. You can solve it as well without the property. Without the property also you can solve it. How can I solve it? So you will break your integration into two parts. -1 to 0. This will be x e raised to power minus x plus 1 to 0. Sorry, 0 to 1. This will be x e raised to power x dx, right? You will integrate, you will get the answers to be 0. Okay. So this answer will be 0. Let's solve the next question. So that's how fast you can solve the integration questions with property. Now this one is an interesting question. This also came pretty recently. We have to find out the integration of this series. So I think I have told you what is this series equals to. Okay, this series is actually equals to ln of 1 plus x. Now, yeah, I do understand that how will you remember it? It's difficult for you to remember. I totally understand that. So I'm not expecting this question to be asked from EC honestly. These kind of questions I think they will ask in mechanical, civil, those branches. Okay, from EC I'm not expecting they will ask this, but if they ask, so obviously toppers will be able to answer it because they will remember it, right? They will remember what is this series ln of 1 plus x. So this series is ln of 1 plus x. Simply have to integrate ln of 1 plus x dx. Okay, and do remember what was the integration of ln of x? We actually did that integration today, that is x ln x minus x, correct? But what will be the integration of ln of 1 plus x? So I can replace my x to be t, right? So this will be integration of ln of t dt, where your t is equals to 1 plus x and your dx is equals to dt, right? So this will be ln of t, sorry, t into ln of t minus t. So I can take this t common, t ln of t minus 1. So what is t? T is 1 plus x into ln of 1 plus x minus 1. Okay, this will be the answer basically, but this was not present in any of the options. So this was incorrect. Maybe I think they were trying to get to some other series. Okay, so they were trying to get to some other series. Maybe they were asking you the differentiation of this, like that was the proper question. If they would have asked the differentiation of the series, right, this series, then this would have been simply 1 by 1 plus x, because differentiation of ln of 1 plus x will be 1 by 1 plus x. That is what I can see here, right? So maybe they wanted to do that. I don't know what they actually wanted to do, but yeah, none of them were matching in the options. So here this was MTA. This was MTA. Okay, let's solve the next one. So here, like, this is the most easy question, right? You have to find out the integration of ln of x. This we already solved, that is x ln x minus x. So x ln x minus x plus constant, option A will be your correct answer for the question. We already have done it in the class notes. So this is like a class notes question, right? They are asking you questions from class notes. Now this one is actually good. Here you have to find out the integration of this particular function. So this is kind of, I'm seeing I have sine inverse, I have cos inverse. So I get the hint. Maybe I will get some sine inverse, right? That is the hint. So what we can do is, I know the integration of dx over under root 1 minus x square equals to sine inverse of x plus c. I know this thing, right? But this is not in my proper format. So let me make it in some format. So what I can do is I can make this, I can complete the square. So if I if I add and subtract 1, okay, plus 2x minus x square, this will not change anything, right? This will be same. So I will take the minus 1 common. This will be, okay, sorry, if I add and subtract 1, right, so what I will do, this will be plus 1, this will be minus 1. Okay, now this 1 is there, I am taking the negative sign common, so this will be 1 minus 2x plus x square. Okay, so now this is nothing but 1 minus x minus 1 whole square, right? 1 minus x minus 1 whole square. Okay, I hope you are able to understand 1 minus x minus 1 whole square. Now I will replace it, right? I will replace my function here, this thing, my integral, with dx over under root 1 minus x minus 1 whole square. Okay, like I have just done bit of manipulation. This is same as this one, no difference, right? I've just done bit of manipulation because I want to get to this format. Now what I will do is I will make few substitution. So I will make t is equals to x minus 1, and I don't have to worry about the limits because this is a indefinite limit. So your dt will be dx. So this will be converted into dt upon under root 1 minus t square. So integration of this will be sine inverse of t plus c, but t is x minus 1. So your option A will be correct. It will be sine inverse of x minus 1 plus c. So with it we are done with basics of integration. Now we will study about multiple integrals. So let's start with multiple integrals. Now this topic is very lengthy, topic is bit difficult, but I cannot surely say that this is a high weightage topic. I can say moderate. Sometimes questions come, sometimes it does not come. Okay, so if you are like, I don't want to demotivate or something. If you are feeling stressed, if you think you can skip a topic, you can skip this, because at least study the initial portion. Whichever portion is feeling bit difficult, you can ignore that, because like once you will solve the gate PYQs, you will see the questions that they are asking are very simple, but there are a lot of things in multiple integrals. So because I have to cover everything, and that's what I have promised, I will cover every single thing, I will not skip anything, right? So I have to cover every single thing. So few things might be bit difficult for you because I will be going at a much faster rate here, so ignore that. Okay, whatever you feel difficult, ignore that. Just at least understand the basics. Your basics should be clear. Okay, so multiple integral has mainly three things. First, we have to understand how can I trace a curve. What do I mean by curve tracing? I will explain. Then there will be two double integration or triple integration. Triple integration will be easiest, and double integration can be a bit tricky. Okay, so what do I mean by curve tracing, right? What do I mean by curve tracing? So okay, hold on a second here. So if all powers of y in the equation are even, then the curve is symmetric about x-axis. So few rules I will say. If all the powers of y are even, then the curve will be symmetric about x-axis. Example, y square equals to 2x. So here the curve is symmetrical about the x-axis. If all the powers of x is even, then the curve is symmetrical about y-axis. Example, y equals to x square. So it is symmetrical about the y-axis. Okay. If all the powers of x and y are both even, then the curve is symmetrical about the x-axis as well as the y-axis. Okay. Example, circle. Okay. Now, if the equation of the curve remains unaltered, if I replace my x and y, if I just swap my x and y, if it remains unaltered, then the curve is symmetrical about y equals to x. Curve is symmetrical about y equals to x. Okay. Let's take this example, like x plus y equals to 2. So this curve, right, here powers are not even, but if I swap my x and y, this will be x plus y equals to 2, which is same, right? So the function is same. So if I draw a line y equals to x, right? So I see that it is symmetrical about the line y equals to x. So that is the that is what this one is telling. This rule is telling us. Okay. Now uh, by default, if nothing is mentioned, you will always consider we are in the 2D domain. By default, you will always consider we are in the two-dimensional domain. That is, when we are in the xy plane meaning my z will be 0. If they are telling you xy plane, that means your z is 0. How? So this is my xy z. Okay, this axis is z. Let's assume this axis is z. So this is my xy plane. This is my xy plane, right? And what is the value of z at the xy plane? X and y can be anything, but z has to be 0 because I'm lying in this same plane, right? So now if I'm here, I will take a so this is somewhere here. Now this plane is also xy plane, but this is not on the xy plane. This plane is called as z equals to some constant. Let's say z equals to 1 plane, right? Which is parallel to my xy plane, but this is not on the xy plane. If I'm on the xy plane, then it will be z equals to 0 plane. Z equals to 1 plane will be a plane that is parallel to the xy plane. Okay, so I hope you understand what a plane is. This is a plane basically, right? A simple structure, plane. Okay. Let's not get into that. Now what I want to say is, can you plot the area below the curve? What is the area below the curve? Area below the curve is this, right? This is the area below the curve. How can I mathematically show it? So this is my line x plus y equals to 2, or y equals to 2 minus x. So if I choose any point here, right? Let's say I have chosen this point at x equals to minus 1, right? Let's assume that x equal to minus 1, what is my y? Y is 3. So what will be the value below it? The y value, like x value is same, right? X value is same, but the y value is lower than my actual curve. So y value must be lower than the actual curve. That is, this my y value must be lower than the actual y value, that is 2 minus x, because actual y is 2 minus x. So must be my y must be less than 2 minus x. So if I have to show a region that is below my curve, how will I show? Y less than equals to 2 minus x. So this will represent, you put any value of x, right? You will find out the region will be lower than my actual curve. So that's how we are actually plotting the surface. That's what is the meaning of this, right? We are just simply plotting the surface. Okay. So if you have to show a region that is below my curve, what you will do? You will just write the y equation, right? And you will make it less than the actual y. So this point, this y point must be less than the actual y point. So that's why I'm doing y less than the actual y. Actual y is 2 minus x. Okay. So y less than actual y. Okay. Or y of the curve basically. So if I had a curve like this, right? If I have a curve like this, x square, y equals to x square, and I only want to show the region below my curve, how will I show it? This will be y less than x square, because actual y is x square and my region will be below. So that's why y less than x square or equals to, because I will include this line as well. Okay, I'll include the line as well. Now if I have to show a region that is above my y, how will I show? So y must be greater than the actual y, right? Greater than or equals to actual y. So y will be greater than or equals to x square. Okay, so that's how you show the region basically. So now there are few structures. Okay, so we will discuss slowly. This is first structure, that is a line. So this is called as a line structure, single line. So does this line have any area? Does the line have any area? No, line does not have any area. but the area bounded by x-axis I can definitely calculate. That is definitely possible with the help of integration. But the line itself does not have any area. Now this is what, this is a surface. This is simply a surface. Okay. Now similarly I will have this structure, line structure, that is a parabola. Y square equals to 4x, that also is a line structure. This is a parabola. Okay. So now which region is less than my y? Can I plot it? Now this will be difficult actually, because here I have y square, right? So your y will be my plus minus of under root 4x. So I cannot comment like what will be this region. Yes, I can comment. I can comment what will be this region. Like this region will be, like if I want to just plot this region will be y less than actual y. What is the actual y here? Plus 4x, right? Because this is not a proper function, that's why there is a bit of problem. So this region will be under root 4x, and if I want to plot this region, so my y actually should be greater than minus under root 4ax. Why? Because now I am plotting above the curve, right? So that's why there is a bit of problem here. This is plus, this is minus on about the y equal to 0 line. Okay, so this region is greater because I am plotting above the curve, and for this curve I am plotting below, so that's why this is below. Okay, I hope this point is clear. But if I want to, let's say, want to plot on the left hand side of the curve, can I plot it? Yes, because x is a single power. So if I want to plot on the left hand side, so what is the x actual? X actual is y square by 4a. Now if I want to plot on the left hand side of x, so basically my x should be less than, because if I am going on the left hand side, x value is decreasing, so x should be less than x actual, that is y square by 4a. If I want to plot on the right hand side, x will be greater than x actual, because I'm on the right hand side, the x value is increasing. Okay, and this is again a line structure, right? What is the area of this line? 0. But what is the area of the parabola? That we can calculate, right? We can integrate and calculate. Okay, similarly again circle again is a line structure. By default, if nothing is mentioned, as I'm telling you, that you will assume z to be 0. So x square plus y square equal to 4 if it is given, and if nothing else is mentioned about z will be 0. 3-dimensional z will be 0. So this is again a, like you can assume this a ring, as a ring or a frame, anything, right? Frame, line structure is also called sometimes as frame. So what is the area of the frame? Area of the frame is 0. What is the area of the disc? The disc formed by the frame, this will be pi r square, that is pi into 4. Okay, so area of the disc is not 0, but area of the frame is 0. Now what is the region inside the frame, right? So my x square plus y square is the frame, so I have to lie below my frame, right? Because this frame I have to lie below it, I have to lie inside it, I have to lie inside it. So basically I can say that my x square plus y square must be less than or equals to 4. Why? Because if I try to plot a circle, right, x square plus y square equal to 3, that will be lying here. If I plot another circle, x square plus y square equal to 2, that will be lying here, and I can keep on drawing, right? So I can draw multiple circles that are inside my bigger circle, right? So that's why this equation is there, that x square plus y square can be anything less than or equals to 4. If it is more than 4, then I will have a circle that is greater than the radius of my initial circle, so that will be lying outside my circle. Because if I want to show this region, right, mathematically, this is how we can show my region. Okay, so I hope this part is clear. So let's solve a very basic question with this. Plot the common area between x equal to 0, y equal to 0 and x plus y equals to 2. By default, if nothing is mentioned, only this one equation is given, so they are simply asking you to plot the area between x equal to 0 and y equal to 0. This should be mentioned, but if that are not mentioned, but you will assume that you are required to plot the area between x equal to 0, y equal to 0. Okay, and obviously this curve. So if I plot this curve, right, this will be 2 minus x, right? So when x is equals to 0, y is equals to 2. When y is equals to 0, x is equals to 2. That is my curve. So this will be 2 comma 0 and 0 comma 2. Okay, and we have to plot between x equal to 0. What is my x equal to 0? At which line x is 0? This line. Here for all values of y, x is 0. So I have to plot between this x equal to 0 line and I have to plot between y equal to 0. So this line, right? So in this line, y is always 0. Any value of x, y is always 0. And I have to plot x plus y equal to 2. And I have to find out the area, common area. What is the common area? This region is the common region between the three. So I have to find out the area of the region. So just they are asking me to plot the common region. What will be the area of the common region? I have plotted the common region. What is the area? So area will be, this is nothing but a right angle triangle. So this will be half into base into height, that is 2. 2 units. 2 units squared. Okay, because let's say if x is unit, 1 unit, right? Because area has always a, area has a what do you call, I forgot. Area has a unit of unit square, right? So that is a, I forgot what is it called. Okay, I forgot. So that is what is it called? Unit square. So like basically area, the unit of area is centimeter square, meter square. So there must be a square, correct? Dimension. I meant the dimension. Dimension of area will be unit square. Now this statement is correct that x square plus y square will be less than 4. But of course I cannot have a circle, right, whose radius is less than 0. That is not possible, right? So what is the minimum value of my radius of my circle? That is 0, right? So I got my lower limit. So I got my upper limit and my lower limit. So that is what it is shown over here, that if I want to represent my surface, right, I can represent my surface as a form of lower limit and a upper limit. Okay, combination of circles whose radius lie between 0 to 1. This was a circle with radius 1. Okay, so again we have to plot the common area between this curve and this curve. Like writing this one will be difficult, plotting this one would be difficult, but if you are able to plot it, right, the common area always will be this region, right, in which where both the curves exist. Here is there a common area? No, this is like going to infinity, right? This is also going to infinity. Only this is the finite common area, right? So this will be my common area. How do you find out the common area? How do you find out the common area? First of all, you always will calculate, is my curve intersecting or not? If they are not intersecting, then the common area would be infinite. Okay, so we can do this example. Like let us plot the common area for this. So y greater than equals to x square, intersection x plus y less than equals to 2, intersection x greater than equals to 2. So okay, let me not show you, let me actually do it. Okay, just give me 1 second. Okay. So let me show you. So y greater than x square. So first of all, if you have to find out the common area, right, you will plot all the 3 functions. Okay, so let me plot all the 3 functions over here. Y equals to x square will be, y equals to, I will have to plot the function y equals to x square. Now the region is y greater than x square. So I will be lying above my y. So this will be y greater than x square. Now again x plus y less than 2. First of all, I will plot my x plus y equals to 2 and I have to lie below that. So this region, right, this is the region of x plus y below 2. Out of these two curves, what is the common region? This one is the common region. Now x greater than 0. This is my x equal to 0 line. X greater than 0 will be lying somewhere here, right? So out of these 3 regions, what is the common region? This one. So this will be my common region. Okay, what are my points of intersection? So I can see that when my x is equal to 0, right, this is line, it is intersecting both the yellow and the like deep yellow curve. So here my y is also equal to 0. So points of intersection, one point of intersection is x equal to 0, y equal to 0. So if you put here x equal to 0, y also will be equal to 0. And here if I put x equal to 0, my y will be 2. So this point of intersection will be 0, 2. Okay. Now Now where is it intersecting? Here. So x greater than equals to 0, x greater than equals to 0. So x greater than equals to 0, what is the intersection? So here my y is 0, right? Y is 0. So if y is 0, if I put y 0 here, what will be the x value in this function? This will be x will be 2. So this is also another intersection, 2 comma 0. Okay, so these are my, sorry, here it is intersecting, but actually the problem is this is not in my common region, right? My common region is this. So what is this intersection? Intersection between the yellow line and the deep yellow. So what is the yellow line? This. What is the deep yellow? This. So I have to equate these two. So here y is equals to x square. This curve is y is equals to x square. So I will replace my y value in this equation. So this equation will become x plus y. Y is x square equals to 2. So from here I can get the value of x. X will be equals to 1. So if x is equals to 1, y also will be equals to 1, right? Because y is equals to x, so y also will be equals to 1. So this will be 1 comma 1. Okay, this will be 1 comma 1. So we got our points of intersection. These are actually pretty important for calculating the area. First, step 1 is you have to trace the curve. What is my curve? This is my curve. Then find out the points of intersection, and then finally you will find out the common area, because we have to use integration. So how to find out the area between two curves? So the area between two curves with respect to x axis, this will be basically f of x minus g of x a to b. So don't worry about this thing, right? I will solve few questions, there we will understand. And if I have to find out the area between two curves with respect to the y axis, then we have to do f of y minus g of y and then take the mod. Here also we have to take the mod, because we are calculating the area. So don't worry, we will like solve a question like this. We have to find out the common area between the curve y equal to x square and y equal to x plus 2. So if I plot the function y equal to x square is this, and y equals to x plus 2 would be when x is 0, y is 2, this curve. So here this point will be, what is the intersection? What are my so what is the common region? Common region is this one. This is my common region, correct? So what is this intersection? So there are two intersections. And here they are not mentioning anything with respect to what axis. So there could have been two areas here. Actually, yeah, there will be this one area only, because yeah, this is the area between these two curves. Yes, correct. Yes. So there could have been two areas actually. You would have also no, there is only one area. This is the common region, right? So this is the common region. So by default, you have to calculate the area with respect to x-axis. Yes. So what are my points of intersection? So here my y is x square, here my y is x plus 2. So you replace your y, right? Because they are intersecting, so their points must be same. So I can replace my y with x square in this equation. So this will be x square equals to x plus 2. So from here I get one point, x is equals to, sorry, x square minus x minus 2 equals to 0. So minus of b, that is 1, plus minus b square, that is 1, minus 4ac, that is 8, divided by 2a. So this will be equals to 1 plus minus 3, 1 plus minus 3 divided by 2. So this will be minus 1 and 2. Yes, minus 1 and 2. So at x equal to minus 1 and 2, they will intersect. So x will be equals to minus 1 here, and x equal to 2 will be here, right? And what are the points? So what is the y value? So y is x square, right? So this will be 4, so 2 comma 4, and this will be 1 comma 1, correct? Sorry, minus 1 comma 1. Okay, so these are my points of intersection. Now how do I find out the common area? So what you do is, let's say if I had only this curve, so I have to find out the area from this point to this point. So let's say I have only I had only this function, right? What is the area? This is the area between whatever minus 1 to 2, correct? And if I had only this function, what is the area between minus 1 to 1? Sorry, minus 1 to 2. This will be the area between minus 1 to 2, correct? So actually what we are doing is we are basically calculating this area. We have to, like, what we can do is I calculate this whole area, right? And then I subtract this area. So I will get the area of the common region, right? That is what we are doing actually. So we are doing f of x minus g of x. So basically we are subtracting the area. That's it. We are subtracting this area, right? Because this area was extra. I did not need this area. I just need the common region area. So I will subtract the extra area. So that is what we have done. We have subtracted the extra area. That's why there is f of x minus g of x. Now why is there a mod function? Why is there a mod function? Because sometimes this will lie, like this function will be greater than this function, or sometimes what will happen, like, let me just draw a hypothetical function. Okay, let me draw a hypothetical function. Let's say, now this was for this one. If I draw a hypothetical function, right? Okay, just a hypothetical function, and I have to find out the common area. What will be the common area? Common area would be this area and this area. So the thing is, if you, like, this is, let's say this is my f of x and this is my g of x, correct? And I have to calculate the area from 1 to 2, minus 1 to 2. So for certain period f of x is positive, and for other period g of x is, like, not positive, sorry, for certain period f of x is greater than g of x, right, in this region, and in this region g of x is greater than f of x. So what will be the problem? The problem will be, if I don't have the mod sign, this will come out to be negative area. If I do f of x minus g of x, right? So in this region it will come out to be positive area, but here this will come out to be negative area. This is simply nothing, right? Just calculating the area under x axis, correct? So this, right, x equal to 0 is this line. So if I don't take the mod sign, right, so we'll have negative and positive area, but actually that is not, I am not interested in the integration. All I am interested in is calculating the overall area here, the common area. And I have told you why we have to take a mod sign. So that's why there must be a mod sign. And I will come to the y-axis, don't worry, I will come to the y-axis. So let's now solve this. So yeah, let's now calculate the common area. What will be the common area? So the common area, right, will be like this, right? Whatever intersection we found, this was mainly for finding out the limits. So I will integrate f of x minus g of x, but mod. But in our case, we don't have to take the mod, because this function, right, is always above my this function. So first, whichever one is above, I will write that. If this was the case, right, then I would have to taken the mod, then I would have had to break my integration. So this would have been my first limit, right, from minus 1 to this constant c. Then the second limit would be c to 2, because here the definition of the mod will change, because here this will become negative. Why? Because let's say previously, what do I mean? So I will do f of x minus g of x, correct? So f of x between minus 1 to c, let me assume this point c, is always positive in this region. So my mod will be always positive. But as soon as I will move after c, f of x will be lower than g of x. So this will be negative, and whenever inside the mod a negative comes, I will add a extra negative sign. So there is change of definition of the function. So I have to break my integration. I have to break my integration into two parts. So I hope that part is clear. But in our case, we are lucky, and mostly this will be the case. You will be lucky that only one function will always be above the other one. So you don't have to worry about mod. But actual concept is this. This is the actual concept. And trust me, in any other institute, they will never teach you this. Okay. They will just say, अरे इसको बस ऐसे कर दो, x plus 2 minus x square कर दो, हो गया, ठीक है. They will never teach all this, right? They will never say, बस थोड़ा सा ऊपर ऊपर पढ़ा दिया, बस हो गया खत्म. Like this is their full course, and this I am teaching in our crash course. Okay. So yeah, the solution will be this will be x plus 2 minus x square, and this will be dx. Okay, this will be equals to, now what is the limits? What are the limits? So the limits will be from x equal to -1 to x equal to 2, -1 to 2. So this will be x square by 2 plus 2x minus x cube by 3. X is going from -1 to 2. So like now I hope you can solve it. Okay, like there is no problem. Like I'm expecting that you are able to solve this question, right? Like there would not be any problem in solving this question. Okay, you can solve it, no problem. Okay, so yeah, this part is done. So there are a few more things. Like now we will discuss about 3D structure. Till now we had discussed about disk, right? Inside the circle disk, how to represent the disk. There is 3D structure. So where let's say z is equals to x square plus y square. So if z is equals to x square plus y square, what will happen? So basically now I have 3 variables. So if I have 3 variables, I will get a 3D structure. So z can be anything, right? Z like either they will provide the limit of z. So here the limit of z is provided that z is varying from 0 to 1, and limit of x and y varies from -infinity to +infinity. Okay, so I know if I put z equals to 0.5, okay, so this will be equals to x square plus y square. So this is nothing but the equation of a circle, and z is 0.5, right? So z equal to 0.5 will lie somewhere here, right? So my z coordinate is fixed. My z coordinate is fixed. My x and y are varying like a circle, right? This is the equation of a circle. Z point is fixed. So the center of the circle will lie at the what point? Center of the circle will lie when my x is 0, y is 0, right? And when my z is equals to 0.5. This is the center of the circle, and about this center I have a circle. Then again the z value will increase, so will the radius. So will the radius of the circle will increase. So this shape is called as a hollow paraboloid. This is like a bowl, just like a bowl, right? As you go in the top of the bowl, the radius increases, just like a bowl. Okay, I don't have a bowl here, but I hope you can understand. It is just like a bowl, hollow paraboloid, because bowl is like a hollow structure. Okay, so that's how we plot it. So then we will have, like, this was about the what is the axis of this hollow paraboloid? Z axis, because z was equals to x square plus y square. Now if y is equals to x square plus z square, what will be the axis? Y axis. So I will have a paraboloid about the y axis. Similarly, if I have hold on a second, if I have like x equal to y square plus z square, I will have a paraboloid about the x axis, like this, right? This is the paraboloid about the x axis. Now I want to, this is a surface, right? Surface, bowl is a surface. Okay, this is a surface, bowl is a surface. This is like a surface, right? It is a surface. It is not a frame. Previously, when I had 2D structure, it was a frame. What was varying? My x and y were varying there, right? X and y. Here 3 variables are varying. If 3 variables are varying, I will get a surface. If 2 variables are varying, I will get a frame. As you can see here, right? Where did the circle go? Here. X square plus y square equals to 4. X square plus y square equal to 4, I was getting a frame. Okay, but if I say x square plus y square less than 4, then it becomes a 2D structure, right? Disk. Similarly here, if I say that my x square plus y square is less than z, then again it will become a solid paraboloid. It will become a 3D structure. What does this mean basically? This basically means that my x square plus y square is less than equal to z. That means that my x square plus y square and z is between 0 to 1. So x square plus y square is less than equals to, when z is equals to 1, it is less than equals to 1. My x square plus y square is less than equals to 0.5 when z is equals to 0.5. And what is this? this is the equation of disk, right? So I will have multiple disks placed one after another. So first the largest disk will be there, largest disk, then below that I will have a smaller disk, I will have an even smaller disk, smaller disk, smaller disk, and this will keep on happening. So the disks, right, will make a solid structure. So if I have a disk here, then again below this another disk, another disk, another disk. So this disk will make a solid structure. So it will not be a hollow anymore. This will not be a bowl. This will be a solid structure. That's why it is called solid. So it is a volume structure. Okay, solid structure. So this was a solid paraboloid about the z-axis. Okay, because it was less than equal to. Now this again, I can plot it about the y-axis. I can plot it about the x-axis. Same thing. Cylinder, very simple. Cylinder is easier than this one. So what I will assume here that x square plus y square is not a function of z, it is constant. So x square plus y square, however I move, right, up or down, this will be always a simple circle. So this will always be a constant. Okay. Now my z is varying from 0 to 1, that is a separate thing. So if my z is 0.5, then also x square plus y square will be 1, that is a simple circle. If my z is 0.8, then also x square plus y square will be 1. So it will always be like same radius. That's why I get a hollow cylinder, because these are all simple circles, right? 1D structure. Now if I write x square plus y square less than equals to a square, then this will become a solid cylinder. Okay. Similarly for cone, what you can do, you can write x square plus y square less than equals to z square. So this will be multiple circles, right, whose radius will be keeping on decreasing, and your radius will linearly decrease. Your radius will decrease linearly, because here what was happening, how was my radius decreasing, although I have not shown you. So z is equals to x square plus y square. What is the radius of this? It is under root of z, right? So your radius, how is radius varying? 0 to under root of z. So that's why this function is a square root function. That's why this was a paraboloid. If it is varying like this, right, varying like this, x square plus y square equal to z square, what is the radius? Z. So your radius is varying linearly. That's why the radius is a linear function, right? Radius is the distance from the from the this z axis. Okay, and if it is less, again I will get a solid cone. That's the difference. Now we will get planes. We will get a planes as well. So if this line, right, this, I know this equation, x plus x by a plus y by b equals to 1. This is simply an equation of a line. Okay. Now if I have if I add a third variable, I will get a plane. The more variables I will increase, the dimension will increase, right? So here I was getting a straight line, here I will get a plane. So x plus y plus z equals to 1. This will be a plane. So here my z will vary from 0 to c, x will vary from 0 to a, and y will, like if I am just choosing my values, and y varies from 0 to b. So the plane that we will get is something like this. There will be a bit of angle. So this is the plane. It is not on the, like basically on the zy plane or the xy plane. It is here. So basically we are stacking multiple lines. So I can take an example. So when my z is equal to 0, when my z is equal to 0, I will have this equation x plus a by y by b equals to 1. So this will be my equation of the line. The equation of the line of this equation, right, is this. Now when my z is equals to, when my z is equals to 0. When my z is equal to 0. When my z is equals to, let's say, 1. So when my z is equals to 1, right, and let us assume that c is some value, like c is some value 2 or something, I don't care. So this will be 0.5. So basically the line will reduce, the equation of the line, x and y values will reduce, you will see, and the z also has been shifted upwards. So slowly basically this width will reduce and z will keep on shifting upwards till the point here. So once I will reach at the top, right, at the top, when this will be c, right, when my z is c, this will be 1, so this will be gone. So x by a plus y by b is equals to 1, is equal to 0 basically, and I know my x and y both are positive, so x and y both have to be 0. So basically the bottom line is, if you have this equation, right, this is not the equation of a line, this is the equation of a plane. Okay, if I had x by a plus y by b, that would have been equation of a line. This is the equation of a plane. Okay, I hope that point is clear. So if like here my x is always positive, x, y and z all are positive, so always I'm in the first octet. So let me explain one thing, like I think that will also come. So in a 3D plane, right, if I have 3D plane, okay, so I will have 8 octets, like 8 regions. I will have 8 regions. What kind of regions? So in one region, x, y, like x will be greater than 0, y will be greater than 0, z will be greater than 0. Other region will be x will be less than 0, y will be less than 0, z will be less than 0, and like this, right? I will have 8 regions. If you remember, in a simple 2D graph, I had 4 regions. So here x was positive, y was positive, here x was negative, y was positive, x negative, y negative, both negative, right? Similarly, a third variable will be added, that's why I will have 8 regions. And the region that is x greater than 0, y greater than 0, z greater than 0 is also called as first octant. It's called as first octant, just like this region is called as first quadrant, because it is divided into 4 parts, that's why quadrant. Here I am dividing it into 8 parts, so it will be called as octant. Okay, so when all of them are positive, that is the only important portion, that is known as first octant. So when all of them are positive, I will always be lying in the first octant. Okay, so here x is positive, sorry, not this. So x is positive in this direction, y is positive in this direction, and z is positive in this direction. So I am lying in this particular octant. Here my now I am not making my x varying from 0 to positive, right? I am varying my x from negative infinity to positive infinity. Y also same, z also same. So then you will not get a like this structure. This structure, right? This structure is called as a tetrahedron. You will not get the tetrahedron, like something like this you will get. Okay. So where I will cover everything, like I will also be covering the negative portion, positive portion also. Okay. So that is what I wanted to explain. So if I am only covering the first octane, right, we'll always get a tetrahedron like a structure. Okay. Now let's come to finally spheres. So in spheres, right, I hope you remember the equation of a sphere, x square plus y square plus z square equals to r square. That is simply the equation of a sphere whose, how is the radius varying? Radius is varying like this. Okay, from your x, y and z can be anything. Okay, that is the equation of an hollow sphere, because it is equal. As it is equal, right, we will only have a single sphere, right? So it is called as a hollow sphere. If I write my less than or equals to x square plus y square plus z square is less than or equals to, I will have a solid sphere, because multiple spheres, right? So I will have a what I can do, let's assume that r is equals to 2. So I will have a sphere, right, I will have a hollow sphere whose radius is 2. I can have a hollow sphere whose radius is 1, and I can keep on adding up spheres, right, together inside the structure. So there will be multiple layers of spheres, and all of them will make a solid sphere. This will not be a hollow structure, this will be a solid structure. Okay. So let's come to few concept of projection. How can I plot the projection? So here we have a equation given, z equals to x square plus y square, and z is varying from 0 to 2. So what will be the projection of the curve about the xy plane? How do I plot the projection? So simply what you do, what does projection means? There is a projector and it is projecting to the screen, right? So in our case, who is our projector? Sun. Okay, sun is our projector. So if they are asking plot the curve, the projection of the curve in the xy plane, so xy plane I have to plot the projection. So you will place your sun on the z axis. If they would have asked you plot the projection of the curve on the yz plane, where will you place your sun? On the x axis. So you will place it here. If they would have asked you plot the projection of the curve on the zx plane, then where will you place your sun? You will place your sun on the zx plane. So you will place your sun on the y axis. Okay. So sun is your projector. In our case, sun is our projector. Okay. So let's take few examples. Okay, this was the first one. If I have to plot this projection, right, about the xy plane, so what will I see? So I will see that this point, right, if I am plotting the projection, this shadow will come here, this shadow will come here, this shadow will come here, because I have multiple circles, right? All these points will come here, all these points will come here, all these points will come here, right? Come down. So it will make a disc. So how do I show you? So if I have no other thing to show you, right? How do I show you shadow? I don't have it wide up. So this is my hand, right? And if I have, if like you will keep your, if you keep your other hand like a bowl, you will see you're seeing the shadow, and it is totally covering your hand. The shadow is totally covering your hand, right? What is it? It is just a disc. It is like a disc, right? Because this bowl is covering everything in your hand. So shadow is covering everything, right? So that's why the shadow will be covering the whole xy plane, and it will be like a disc, because the object is still this point. So all these points, right, will come down. So that is the maximum value outer ring that I can go to, right? I cannot have a point here, right? Because here there is no object, nothing. So you will not get a shadow. You will get a shadow from here, correct? So ultimately this will be what? This will be the equation of a disc. So the projection of this particular curve about the xy plane will be the equation of a disc. And what is the equation of a disc? So equation of a disc is x square plus y square less than or equals to the radius. What is the radius of the outermost circle? Because this is the equation of the disc. So equation of the disc is defined by the radius of the outermost circle. What is the radius? This is the radius, right? This is the radius. The radius is simply under root 2, not 2, under root 2. So this will be under root 2 whole square. So what will be the projection? If I just want to plot in the xy plane, the projection will be simply a disc, x and y. Okay, that will be my projection. Now let's say I want to plot the projection of a curve. Similarly, if I have a curve x square equals to y square plus z square, okay, and I want to plot this projection of the curve on the yz plane. So first of all, what do I need to do? First I need to plot the function. So what is this equation? This equation is equation of a cone, right? And by y square plus z square is equals to x square. So it is a cone about the x axis, because my x is on the radius side, right? So if I keep on increasing my x, the radius of the cone also will increase, correct? So if I plot my function first, x, y, z. Now how do I write x, y, z? So you will always follow the right hand rule, right? So if I curl my fingers from the x axis to the y axis, right? So that will give me the z axis. My thumb direction will give me the direction of the z axis. Right hand rule, okay? So from the x axis, I am going in the y axis direction. So my thumb will give me the z axis direction. Okay, I hope that is clear, because your z axis can be both positive and negative, right? So you will use right hand rule, okay? So you will curl your fingers from x axis to the y axis. So you will get the direction of the z axis, okay? So yeah, now so if I plot the cone, so cone will be somewhat like this. Okay, this is the equation of the cone, right? So yeah, this is my cone, and one more, I'll give another condition, that my x has to lie between 0 and 1, okay? And I have to plot the projection about yz plane. So in which axis I should keep my sun? X axis. So my sun will be here, okay? My sun will be here. So what will be the projection? Basically, again, it will be a circle only, it will be a disc only, right? So again, all these points will come here, all these points will come here, right? All these points will come here. It will be like a disc. What will be the equation of the disc? The highest radius. What is the highest radius? 1, right? 1 is the highest radius. So what will be the equation of this disc? It will be y square plus z square equals to, not equals to, sorry, less than or equals to 1 square. That is the equation of the disc. So that's how you plot projection. So all these tools will be required to actually solve my double integration. Okay, so we will see. So double integration, right? First we will see when I have a constant function, like this is some constant number. So this double integration dx dy represents the area in a 2D region. Okay. So basically what we are doing, we are multiplying, we are taking a small strip dx, we are taking a small strip dy, and we are multiplying it and integrating over the region. So basically we are finding out the area of the given region. So there will be a region that will be given to you, and that will be the area. So area double integration of the given region dx dy is the area of the region in the xy plane. So if I project that particular equation in the xy plane, so the area of the projection will be this. Similarly for the other planes. Okay, and obviously we will do few questions, there will understand. Then what is my like volume? So if I do integration, double integration z dx dy, here it was 1 dx dy, it is z. So what is the unit? It becomes unit cube, right? It was unit square. Dx has a unit of unit like meter, dy has a unit of meter, meter square. This will be z has a unit of meter, this meter, meter, meter cube. Okay, so this will be the volume in the xy z plane, z dx dy. Similarly this can also be, you can also do this, right? Y dz dx and x dy dz, all of these are totally valid. Volume. Okay, volume. How to find out these things, don't worry, we will solve this. And triple integration is simply 1 dx dy dz, that is also volume v in the given region, whatever region they will give you, that is a volume v. Okay, so yeah, both of these actually are valid, this one and this one, both of these are same for the same function. So we will solve a question, through that we will understand how to solve. So let's say this is the equation, okay, and I have to find out the integration. Now this is not area, this is not area, okay, because I have x here. If I had 1 dx dy, then that would have been area, but this is not area. Okay, now the thing is, your limits are constant, so you don't have to take much stress. If your limits are constant, you don't have to take much stress. First thing is, they should have actually mentioned what are my, like, which is x limit and which is y limit. This could have been x equal to 1, x equal to 0, or this could have been x equal to 2, x equal to 0, right? But which is my x limit and y limit? So there is no, like, no fixed notation, but generally they will tell you like what is my x limit and y limit. If it is not if it is not mentioned, if I have dx written here, so this will be my x limit and the other one will be my y limit. Generally there will be some hint given to you in the question, with which you will be able to understand what is my x limit and what is my y limit. Okay, so currently nothing is given, so this will be my x limit. So 0 to 1, x equal to, so this is y equal to 0 to y equal to 1 to x equal to 0 to x equal to 1, x dx dy. So as this is very simple, right? So first I can actually solve this integral, then I can solve the outside integral, right? So first let me solve this integral. So if I solve this integral, this will be 0 x square by 2, and x is varying from 0 to 1 dy. There will not be any constant of integration because this is a definite integration. So this will be 1 by 2 basically. So 1 by 2 will be outside, okay, and this will be 0 to 1 dy, so which is simply 1 by 2. So answer will be simply 1 by 2. What will be the sorry, this will be y equal to, sorry, this was x equal to 0 to 2, right? Sorry, so this will be not 1 by 2, this will be 1. No, this will not be 1 by 2, so this will be 2. Yes, this will be 2. So this will be 2 basically, 2 unit square. Okay, 2 unit square. So the now will this be unit square? No, this will be unit cube, right? Is this volume? No, this is not volume, because I have x here, right? What is the unit of x? It will be meter. Just taking an example. Unit of dx, that also will be meter. Unit of dy, that also will be meter. Now we can there is a way we can solve this differently. So this was the third method in which I simply individually, like this was the first method in which I first solved the inside integration, then I solved the outside integration, correct? Then there is method 3. Method 3 is if my function is variable separable, right? If I have a function f of xy, right? If this function f of xy is variable separable like this, x into y, or x square y square, or x cube y cube, these are all variable separable. Basically I can write my x terms together and I can write my y terms together. So basically this is my f of x comma y, so I can write it in terms of two functions. So f of x comma y will be equals to g of x into h of y. If I am able to write it like this, right, then I can use this method. I will show you what is the method, but before that tell me, is this a variable separable function? If I try to take my x square common, right, this will be y square plus 1 by x square. No, because this here, right, this is not a purely a function of y, this has x as well, right? So this is not a variable separable function. So just be careful when you can use this method. So if I have a variable separable function, right, so then what I can do, then my double integration f of x comma y dx dy, I can break it down into two integrations. This will be g of x dx into h of y dy. Okay, so I can break it down into two integrations. So I hope that part is clear. How can I break it down into two integrations? Now yeah, so in this case what will be the case, in this what will be the solution in this case? So I can break it down as x dx into 1, like y is equals to 1, so sorry, y is over 0, 1 into dy, and I will put the limits of x. X is varying from 0 to 2, y is varying from 0 to 1. So this will be simply 2 into 1, so that is 2 unit cube. Okay, so this was the method in which you can use variable separable. If I can separate out my x and y. Now another method is there, that is changing of order. So what is changing of order? So here, right, my x was going from 0 to x equal to 2, and my y is going from 0 to y equal to 1. This was x into dx dy. And for some reason, if you ever feel that performing this integration is difficult, that situation will come. Don't worry, that situation will come. Then you can change the order of the integration. So now I can do dy upon dx. Then the limits will change. So now the limits will become y equal to 0 to y equal to 1 and x equal to 0 to x equal to 2. And x as x is a x will be treated as a constant of dy. So x can be outside the integration, x can be here. Okay, and this will be simply 1. Now you will say, sir, how have you just simply swapped the limits? Because in reality you will never be able to simply swap the limits. Here, as my limits are constant, I am able to swap my limits. But obviously we will take few examples. There you will see you cannot simply change, like swap these limits. There are certain rules that we will learn. Okay, so for now we can do it because x and y are constant. So this will be equals to basically if I solve this, first of all, again I'll solve this integration first, that is dy, integration of dy is y. So 1 minus 0, this will be y, this will be 1 only, right? 1 minus 0 into dx, x is varying from 0 to 2. Okay, so this will be equals to yeah, x squared by 2, 0 to 2. Okay, so this will be simply 2. So obviously you will get the same answer. Okay, but order will matter, we will see. But in our case, as the limits are constant, order does not matter. But when limits are not constant, order will matter. So when they are constant, right, we can change it. So that is what I have written here. If the limits are constant, we can simply swap them, no problem. Okay, we can simply swap them. But remember, if nothing is mentioned here, right, nothing is mentioned here, correct? So I will assume these to be the limits of x, these to be the limits of y. whichever one is near, that will be that limit. Okay, that is what I will assume. Like this, you can solve these questions. Okay, so we can either swap them or we can keep it as it is, whichever one is suitable for you. So if I will solve only like these two, you will see, you will verify whether you are getting the same answer or not. Dy dx and dx dy. So let me first solve the first one, that is integration. Just give me 1 second. Yeah, integration of 0 to 1 x minus y divided by x plus y whole cube. Okay, dy dx. So this will be the limits of y. Okay, so how can I solve it? So if I am solving with respect to y, right, x will be assumed to be constant. X will be assumed to be constant. But solving this will be a bit difficult for me. So what I can do, I can do some substitution. So x is a constant, right? X is just a constant. So what I will do, I will do this, t will be equals to x plus y, and remember x is a constant. So if I do dt upon dy, x is just a constant like this, t equals to 1 plus y. So if I differentiate, this will be dy. Okay, so dt will be replaced with dy. Now what will be the limits of t? No need to change the limits, I will put the limits later on. I will again back substitute my y, don't worry. So don't worry about the limits for now. Okay, so this is 0 to 1, don't worry about the limits. This will be, so what is my x minus y? So t is equals to x plus y, so x minus y. So y, what is y equals to? Y equals to t minus x. So this will be 2x minus t. Okay, that will be my numerator, and denominator will be simply t cube, and I will differentiate with respect to t because dy is dt. Don't put the limits now. Don't put the limits now. So this will be equals to 2x by t cube minus, just give me 1 second, 2x by t cube minus 1 by t square. 1 by t square. Yes. So this I will have to integrate with respect to dt. This is much simpler, right? X is a constant. X is a constant. So this will be 2 divided by minus 2 t square, right? Minus 1 by t. Minus of minus 1 by t. So this will become plus. So the integration will be 1 by t square, like 1 by t minus 1 by t square. Now I will replace back my y in terms of x and y. So if I write in terms of x and y, what is my t? T is equals to x plus y. So this will be 1 by x plus y minus 1 divided by x plus y whole square. Okay, so that is what my this t is equals to. Now I can easily solve it, but before that, okay, I forgot one thing. Here I have a x as well, right? So this will be x. X is treated as constant, so x will, you cannot skip the x will be there, right? So now I got the integration value, this integration value. Now I will put the limits. Now you put the limits of y. Y is going from 0 to 1, correct? Now you put, first solve the integration, then you put the limits. Once you are putting the limits, right, make sure your function is in terms of y, not in terms of t. Then everything will be sorted. So if I put here y to 0 to 1, this will be, when y is 1, this will be 1 by x plus 1 minus x divided by 1 plus x whole square and when y is 0, this will be 1 minus x. Yeah, okay. Sorry, 1 by x minus of 1 by x, and this will be plus of x by x square, that is simply plus of 1 by x. Oh, so this is 0 only. When y is 0, this is 0 only. So I get simply 1 by uh, 1 by x plus 1 minus x by x plus 1. So can I further simplify it? This will be x plus 1 minus x divided by x plus 1 whole square. So this will be 1 divided by 1 plus x whole square. Okay, 1 plus x whole square. So this will be the basically the answer of the integration. Okay, we are in the first step. So ultimately this integration, right, this inside integration is 1 divided by 1 plus x whole square, right? So then this will be 1 divided by 1 plus x whole square dx. So that is done. Now simply I will again use some substitution. So like either you can use it or you can not use it. So again I will put t equals to 1 plus x. So this will be basically minus of 1 by t, that is 1 plus x, and I will put the limits, that is 0 to 1. So if I put here x equal to 1, this will be minus of 1 by 2, and x equal to 0, this will be plus of 1. So this will be 0.5. Okay, so 0.5 will be the answer. Like I just wanted to show you how to solve these kind of limits, right? When your limit is constant, and the homework for you is you solve this one. When the limits are swapped, okay, you will see the same, you will get the same answer. Okay, so that was the purpose of solving this. So I hope that part is clear, how to solve constant limits. Okay, now if the limits are variable like this, let's say if I have y equals to x, then what will happen? If the limits are variable, then we have to take strips, vertical strip, horizontal strip, those kind of things we have to do. Okay, so we will actually, let me solve a question, with that we can actually understand it. Let me take a question. What is the yeah, here. So the common region bounded between these two curves above the x-axis. So region R is represented by the common region bounded by these two curves above the x-axis. So what is above x-axis? This is nothing but y greater than 0, y greater than equal to 0. That is what they mean by above the x-axis. So let me first find out my region. Let me first understand what region are they talking about. So the region is, this is my x, this is my y. Okay, so let me plot y equals to x square and x square plus y square equals to 2. So y equals to x square will be this, y equal to x square will be this, and x square plus y square plus x square plus y square equal to 2 will be this, simply a circle, right? And they are asking me what is the common region above x-axis, that is this region, and y equal to x square curve and this circle curve. What is the common region? This is the common region, right? This is the common region, and they are asking me to find out the area of R. So how do I find out area of R? It will be in integration 1 dx dy, because this is the area of the region R. So I have to choose my limits properly. You have to choose your limits. What will be limits? So how to choose limits? That is what I will tell you here. Okay, so this will be quite interesting. Let me first choose a vertical strip. What do I mean by vertical strip? I will explain. Let us first find out the point of intersection. So what is our step? First of all, our step is to understand what the question is telling, then plot the curves, then find out the common region, then find the point of intersection. So what is this intersection point? What is this intersection point? So these are my two intersection points between the curve, correct? So basically what I can do, my y is x square, so I can replace my y here, or what is the other thing that you can do? I can replace my x square as y here, because this will become a quadratic equation if I replace my y. So let me replace my x square y. So this will be y plus y square equals to 2. Y plus y square equal to 2. So y square plus y minus 2 equal to 0. Okay. So your y will be minus of b plus minus b square minus 4ac divided by 2. So this will be minus 1 plus minus 3 divided by 2. So this will be equals to minus 2 and 1. Okay, minus 2 and 1. So yeah, minus 2 and 1. So x is equals to, like, sorry, my y value is minus 2 and 1. What are my x values? So my x value will be what? So if, when y is minus 2, will I get a y? How is y coming out to minus 2? This is y square minus becomes plus minus b. Okay, square minus 2 there. Okay, so which one shall I choose? Shall I choose y equals to minus 2? Y equals to minus 2 is like not even possible, right? Because at y equals to minus 2, this is never intersecting. So I know y equals to 1 will be a valid solution. Y equal to minus 2 is not a valid solution. So y equals to 1 will be a valid solution. Y equals to minus 2 will not be a valid solution because this is never intersecting in the negative region, right? Because my curve itself never goes to negative. So I will neglect the negative solution. I will take the positive solution. That is y equal to 1. If my y is equals to 1, that means your x square will be equals to 1. That means your x can be plus minus 1. This is correct. This is correct. So when my y is 1 here and here, right? So here, what is the point? My x is equals to minus 1, y is equals to 1. Here, what is my point? X equals to 1, y equals to plus 1. Okay, that is my point basically. X equals to minus 1, y equals to 1, x equal to 1, y equal to 1. Okay, so if I now like find out the area of this common region, right? How do I find out the area? So I got my limits. I have to choose my strip. So how to choose your strip? So either you can choose a vertical strip or a horizontal strip. So first of all, I am choosing a vertical strip, and that strip will go through the whole region. So if I am choosing a vertical strip, can you tell me what is the variable here? So if I am choosing a vertical strip, right, that means its width is very small, that is dx. So dx, so this is dx, right? And what about its y? Its y is a variable. So the upper part of the y, the lower part of the y, right, is varying like y equals to along this curve. What is the equation of this curve? Y equal to x square. So it is varying y equal to x square. And the upper side of this strip is varying as y equals to under root of 2 minus x square. How? So what is the equation of the circle? Equation of the circle is x square plus y square equal to 2. So if I write y equals to 2 minus x square, y square equal to 2 minus x square. If I take the under root, this will be plus minus 2 minus x square. So there will be two solutions. In the one solution, y will be positive. In the other solution, y will be negative. But of course, I will only choose the positive solution because my y is always greater than 0. So equation of this side is y equal to 2 minus x square. Okay. So these are my y value. And how is my x varying? So x is simply going from x equal to minus 1 to x equal to 1. So that's how, like, this is the summary basically. So as soon as you will choose a vertical strip, what do you understand? You understand that your dx is very small. So that is simply equals to dx. That is simply equals to dx. And you have two limits. Like you don't have two limits for x, right? Because x is going from this point to this point. Because your dx, the vertical strip, is not touching the curve on the left hand side or on the right hand side. Your dx curve is touching two curves on the top and the bottom. So you will get the limits of y. So that's how you remember. Like those who have actually studied this, they will understand how difficult it is to remember what limit I need to write. So no need to remember. Just draw the strip and then check which at what point I am touching. I am touching at top and bottom. So that means if I am touching along the y axis, so that means I have to write the limits of y. So the integration will be 1 dy dx, okay, because I am taking a vertical strip, so it will be dy dx, where my y is varying, y equals to x square, and what is the upper limit? Y equals to under root of 2 minus x square. So this will be y equal to x square to y equals to 2 minus under root of x square. So I got my limits of y. And what is the limit of x? Simple, right? X is varying from 1, so minus 1 to 1. So limits of x will be constant, minus 1 to 1. So you will always go from left to right hand side or from the bottom to top. Either you will go from the left to right or from the bottom to top. Basically your x, right, like x value when it is lower, I go from lower to higher, right? We always go from lower to higher. Same reason for y, we go from low to high. Okay, so now can you solve this integration? Of course we can. So this will be equals to x minus 1 to 1. This will be integration of dy. This is just a constant, right? So I can solve it. This will be 2 minus x square. Now remember here your like limits are not constant, so you cannot use it in variable separable format. Okay, you cannot solve it in variable separable format, and this will be minus x square, okay, dy dx. So here I am stuck, right? Solving this is not easy. So this is where the concept of change of order will come. So I will choose horizontal strip, because solving this will be a bit difficult for me. There will be some substitution that will be difficult. So I will choose a horizontal strip. So I will not choose a vertical strip, I will choose a horizontal strip. So if I choose a horizontal strip, let me copy this, right, and let me put it at the top. Let me put it here. Let me put it here. So if I choose a, just give me 1 second. If I choose a horizontal strip, right? If I choose a horizontal strip, then how will I like find out the limit? So one thing is there, right? When I'm choosing a horizontal strip, what is constant? Like which is a very small length, this length, right? And what is this? This is dy. Here this was along the x-axis, that's why this was dx, but this is along the y-axis, so this will be dy. So this strip is actually called as dy strip. Okay, so dy, y value will be constant now. So y is going from what? Y equals to 0, right? Because this is the point, till y equals to, what is this point? Y equals to so where do I cross here, right? Because I have to cover this whole region. So y equal to 0 till this point. What is this point? Where my circle crosses the y axis. So where my x is 0. So when my x is 0, what is the value of y? When my x is 0 in the circle, what is the value of y? Under root 2. So this will be under root 2. So basically you can get from here, right? So y is equals to under root of 2 x square. So when x is 0, this will be under root 2. So this point will be x equal to 0, y equal to under root 2. Now there is a bit of twist over here. What is the twist? The twist is, if you see here, my y is varying like this. What is the x curve? So your x curve seems the same, right? This is what? X square, correct? This is simply y equals to x square. This curve is y equal to x square. So what is my x value? X equals to, so y is equals to x square. So what is x? X will be plus minus under root y. Don't make this mistake that you are only writing plus under root y. So you are making a total blunder. Okay, x is plus minus under root y because y is always positive, but x is also negative, right? Negative positive. So this curve is what? This curve is x equals to plus under root y because x is positive. This curve will be x equals to minus under root y because here x is negative. But there is a bit of problem. This strip, this horizontal strip, if I move top right, what happens? There is change of my curve. So I am touching the yellow curve initially, but as soon as I move towards my blue curve, the curve has changed now. What is the curve? Curve has now become x square plus y square equals to 2. So what is my x equals to? X will be equals to plus minus under root 2 minus x square. So again this side will be what? This side will be x will be equals to plus under root of 2 minus x square, and this side will be x will be equals to minus of 2 minus x square. So there is change of curve. Basically I will break down my curve into two regions. This will be region 1 and this will be region 2. Okay, so I will break down. What do I have to find out? I have to find out area of the R. So I will break it down into two regions. So I have to perform this integration, right? I have to perform this integration. What is the integration? Integration is integration of 1 dy dx. This time here I am putting the limits of x. So this will be dx dy. This will be dx dy. Okay, and x is going from minus under root of y to plus under root of y, and your y is going from 0 to under root of 2. But there is a problem, right? Because your y for this region 1, right, it is not going from 0 to under root of 2. No. It is going till 0 to y equals to 1, right? It is going from 0 to y equals to 1 for the region 1. So this will not be correct. This will be this, right? When x is this, then my y is going from 0 to 1. And for the rest of the region here, right? So the region 2, this is the second region. So y goes from 1 to under root of 2. Y goes from 1 to under root of 2, where the definition of x does not change. So y will go from 1 to under root of 2, and this will be my integration x. Now what is the x? In this case, what is the x? X is going from like left to right. Always choose left to right. So x is going from minus 2 under root of 2 minus x square to plus 2 minus x square. So minus 2 minus x square to plus 2 minus x square. 1 dx dy. Why dx? Because remember, these are the limits of x. These are the limits of x. So here there will be dx. There has to be dx because the limits are of x. Okay. So the constant will always lie in the outside. That's how you remember. Constant always will lie outside. The variable will lie inside. Okay. So you don't need to remember that if I have a vertical strip, then this will be the limit. If I have a horizontal strip, then x will be the limit. No. You draw the strip. So you have brain, right? You'll understand. Okay. This is touching the curve. So this is variable. So here dy is fixed, right? Dy is a small length that is fixed, but x is variable. So you have brain, you'll understand. Okay. I have to write in terms of x here. If you have to write vertical strip, then here I see that this width is fixed, dx is fixed, right? So I have to write in terms of y. So you will do that. So if I am solving this, right, I saw that I am getting a very complex integration. So I will stop here. What will I do? I will directly move on to horizontal strip. So if I am feeling that vertical strip is difficult, so I will directly move on to horizontal strip, and you will see that horizontal strip will be much simpler. You will be able to solve it. Okay. So here if I solve this, right, how do I solve this now? So this will be equals to 0 to 1. This will be 2 under root of y into dy, where y is going from 0 to 1. So this I can solve. So individually I will, let me first solve this, right? Let me first solve this. This will be 1 by 3 by 2 into y of 3 by 2. Okay, and my y is going from 0 to 1. Y is going from 0 to 1. Okay, so this is the integration of the first part, which will be equals to, basically this will be 4 by 3. Okay, this part is 4 by 3. What about the other part? So if I solve this part, this will be interesting. So this will be 2 times 2 minus x square. Okay, and my x, yeah, sorry, why is it, this should not be, sorry, this will not be x square, right? Sorry, this will be y square, 2 minus y square, sorry, 2 minus y square. So this will be 2 minus y square. Okay, 2 minus y square, and yeah, if I integrate this, right, this will be 1 to under root 2 dy. Okay, so what will be the value of this integration? So 2 can come outside. Now what kind of substitution I can do? So what I can do is I can make a simple substitution that my y is equals to under root 2 sine theta. Okay, so what will be dy? Dy will be equals to root 2 cos theta d theta. Okay, so if I solve this further, so don't worry about the limits right now, we will worry about the limits later. So 2 will be outside, this will be converted to 2 minus 2 sine square theta into, what is my dy? Dy is root 2 cos theta d theta. So this will be 2, so what is, if I take the 2 common, right, this will be under root 2 into under root 2 will be 2, so this will be 4. And what is 1 minus sine square theta? Cos square theta. So this will be cos theta. So simply this will be cos square theta d theta. This will be cos square theta d theta. Okay, so what will be the solution of this integration? So I can replace my cos square theta d theta in terms of sine theta. So if you remember, this was the equation, cos square theta, like I write cos theta like this, c square theta for my shortcut, sine square theta was equals to cos of 2 theta. So this was a formula, right, trigonometric identity. So from here I can get that this will be 1 minus, so 2 cos square theta is equals to this will be 1 plus cos 2 theta. So your cos square theta will be equals to 1 plus cos 2 theta by 2. So I just write in shortcut, I don't write cos and sine, that will be very hectic for me, right? So I write in shortcut like this. So this will be cos square theta equals to 1 plus cos 2 theta by 2. So yeah, I can replace my cos square theta like this. This will be, if I replace my cos square theta, this will be equals to 4 by 2 1 plus cos 2 theta by 2 into d theta. So this will be, okay, 2 is already gone, right? So is already gone. So this will be 2 into theta plus sine 2 theta by 2, where theta is going from lower limit to upper limit. So what is the lower limit of theta? So how is my y varying? Y is varying, y is starting from 1 to 2. So when y is equals to 1, what is sine theta? Sine theta is equals to 1 by root 2, right? Sine theta is equals to 1 by root 2. So theta will be pi by 4. So theta is going from pi by 4, that is the lower limit. And what is the upper limit? So when y is equals to under root of 2, so this will be sine theta will be equals to 1, that is pi by 2. So I am going from pi by 4 to pi by 2. So this will be equals to 2 into pi by 2 minus pi by 4, that is simply pi by 4 plus, now what is this? Sine of pi is 0, so that is gone. sine of pi by 2 is 1. So it will be minus of 1 by 2. It will be minus of 1 by 2. So what will I get? This will be simply pi by 2 minus of 1. Pi by 2 minus of 1. And what was the previous solution? This was 4 by 3, right? This region 1, this was my region 1, this was my region 2. So what is the overall answer? Addition of those two. So 4 by 3 plus pi by 2 minus 1 equals to 1 by 3 plus pi by 2. So this will be your answer basically, unit square. Okay. So that is the whole concept of vertical, horizontal strip and area under region. So I have tried to cover with a single question every single concept. I know this is a huge doubt to all the students. There is a huge pain, like what shall I choose my vertical strip, what shall I choose my horizontal strip, what shall be my limits. So with this single question I have covered every single doubt of yours. Okay, and if you are enjoying it, so please make sure you hit the like button and comment down below how are you feeling regarding this R-PYQ series. Okay, so we are done with the answer is done, right? But I want to say, like, what shall be the methods to choosing my strip? What shall be the methods? So I see whenever there is sharp change, you see there is like the curve is changing, right? So we will avoid that actually. Here, although we had no other option, we had to choose this strip because this integration was coming out to be very difficult. Here I saw that there was no change in the, like, there was no sharp like cut like this, right? There was no cut. Whenever there is cut, that means you have to break your integration. How many cuts were there? Only a single cut, right? At this point I had a cut, so I had to break my integration into two parts. If similarly, if I would have had 3 cuts, then I would have had to break my integration into 3 parts. So that will be more and more hectic. That will become more and more hectic. So we generally avoid this thing. We generally try to take that strip which has very less number of cuts. So here I see, do I have any definition change anywhere? No. Always the upper side of the strip, vertical strip, is touching the blue curve. Always the lower side of the vertical strip is touching the yellow curve. So there is no definition change. So there is no problem here, right? But what was the problem? As I have chosen vertical strip, I was solving it. I saw this is the integration. I don't know how to solve it. It is difficult. So I have no other option but to take the horizontal. Okay. So that is how you decide which kind of strip you have to solve. So now let us solve the like the next part, that is this one, y dx dy. We have found the area in the region. What is y dx dy? So y dx dy, let us solve. So let us solve using both vertical and the horizontal strip. So I have to solve y dx dy. So this time, right, you will not, if I am using vertical strip, what is the order? Order is this, dy dx, right? So you will not change it. These things will be same. Just instead of 1, I will have y. So if I have y dy dx, right? So I will copy this. Everything will be same. Every step will be same. What will change? Only. Okay, let me keep it on a single side. What will change? Only your this inside function will change, right? So this will be changed to y, and this will be much easier for us to solve. You will see how. So if this becomes y, right? So if I am doing dy, this will be y square by 2 x equal to minus 1 to 1, and I have to put the limits obviously from x square to under root of 2 minus x square dx equals to, so this will be minus 1 to 1 2 minus x square by 2 is outside and minus x raised to power 4. Okay, so this is much easier, right? Dx much easier. this is a even function, this is a even function, right? So I can multiply by 2, 0 to 1, this will be 2 minus x square minus x raised to power 4, which will be equals to, I can solve this, this will be 2x minus x cube divided by 3 minus x raised to power 5 divided by 5, 0 to 1. This will be equals to simply 2 minus 2 cube, that is 8 by 3 minus 32 by 5, that's it. That is the answer basically. You can like find out the exact values. Sorry, this is not 2, right? X is not 2, x is 1, right? Oh, this is even simpler. 1 by 3 minus 1 by 5. So this will be basically 2 minus 8 divided by 15. So that will be 22 by 15. So 22 by 15 will be the answer. Now let us solve using what do you call? Using the horizontal strip. Horizontal strip. So I will take the horizontal strip now. Now this will be a bit complex. This will become a bit complex. Although you can solve it, but still this might become a bit complex. So the homework, I want to give you the homework. Solve using the horizontal strip. If you are solving using the horizontal strip, the method will be same. Region 1, region 2. Region 1, region 2. But instead of 1 dx dy, there will be y dx dy. Individually you will solve this, and the homework for you is verify whether I am getting the same answer, whether I am getting 22 by 15 or not, okay, by using the horizontal strip. So this will be a good practice for you. Okay, so that's how you basically solve. So all this I will give you homework. So here, right, like you can, like, integrating this function with respect to y is very difficult for me, right? Integrating this function with respect to y seems very difficult. So I will integrate this function with respect to x. What do I mean? So here it is given dy dx x. So if x is given, right, this means that is the limit of y. So here dy is here. So dy means this, correct? So dy means my y is varying, right? Y is varying. Dy means my y is varying. So like if you ever tend to forget, right, you can always plot the functions. So this is a function y equals to x. So these are my limits. What are my limits? Y equals to x, y equal to pi by 2, and what is the outside limit? X equal to 0 and x equal to pi by 2. So let me plot that here. Y equal to x. Y equal to x will be this function, right? Y equal to x will be this. What is y equal to pi by 2? Y equal to pi by 2 will be this. Y equal to x equal to pi by 2, x equal to pi by 2 will be this, and x equal to 0 will be simply this function. Okay, now what do I have to, so my y is going from y equal to x to y equal to pi by 2. So y is, the lower limit of y is y equal to x, so, and the upper limit of y is y equal to pi by 2. So what is the strip? The strip is simply vertical. So that's how we can understand like whether it is a vertical strip or not. So the lower limit of y is y equal to x, so we'll touch my x equal like y equal to x here, this curve, and the upper limit is y equal to pi by 2. So this is this curve, right? So basically it is nothing but a vertical strip. So even if you forget what is vertical, horizontal, no need to remember. Plot the graph and just plot the strip. That's it. No need to remember anything. Okay. So I got my vertical strip, right? But doing this integration is kind of difficult for me, right? Doing this integration is kind of difficult for me. Cos y upon y. So I will change the order. So I will make it a horizontal strip. So if I change the order, what will change? So here, what is the lower limit? X equal to what is the lower limit? X equal to 0. What is the upper limit? This curve, right? This curve is the upper limit, that is x equal to y. What is the lower limit of y? So I always go from lower to higher. Lower limit of y is y equal to 0. What is the upper limit of y? Y equal to pi by 2. So I will simply change my order. So this I can write my function here. This dy dx can be changed to dx dy. As I am changing the order, the limits also will be changed. So x will go from x equal to 0 to x equal to y, 0 to y, and your y will grow from y equal to 0 to y equal to pi by 2, 0 to pi by 2. And this will be simply whatever is the function, this will not change, this will be cos y upon y. Now the beautiful thing is here my y will be treated as constant, so I can take this function outside. So now I can solve this. This will be 0 to pi by 2 cos y upon y, and this will be 0 to y dx dy. So this will be equals to simply y, right? Integration of dx is y, sorry, integration of this will be simply y minus 0 will be y. So y and y will be cancelled, this will be cos y, 0 to pi by 2. Now this is much simpler for me to solve, which is simply equals to sin y, right, 0 to pi by 2, that is simply equals to 1. So I hope now you're understanding why choosing the strips are very important. Okay. So there are many like questions, you can take this one as homework. So I will not be able to solve every single question, right? Otherwise this this video will go on, right? I will not be able to solve this one. I am giving you as homework. Okay, try it out by yourself. So make sure you're understanding what is my region. So I have written my region here. Make sure you understand the region. Okay, so I can tell you the answer. So the answer of the the area will come out to be 11 units. First part will come out to be 11. Okay, and the second part I have written it, it comes out to be something like 34.625. okay, so these are my values, basically 11 and 34.625. so you can solve it and you can verify whether your answers are matching or not. Okay, so yeah, now here we have another question, like this is, I think this was a gate question. Okay, so consider the f x y is a continuous function defined over x comma y from 0 to 1. The volume under f of x y, if two constraints are given, x is greater than y square and y is less than x square, what will be the volume? So they are asking me to find out the volume. Okay, when my x is between 0 to 1 and x is greater than y square and y is greater than x square. So this is my curve y equal to x square and this is my curve for x equal to y square, right? So they are telling me x is greater than y square, x is greater than y square. So this curve is this one. So x value has to be greater than y square. That means I have to lie on the right hand side of the curve, right? Right hand side, because x has to be greater. So x actually is this one and x has to be greater than this, so it has to be more. So I have to lie in the right hand side, and y is greater than x square. That is, this is my curve y equal to x square, so I have to lie more than this. So y must be more than y actual, that is above this, right? So this is the region that they're talking about, and they're asking me what will be the volume. So volume, so there can be two options, right? Either I can choose horizontal strip or vertical strip. If I am choosing a horizontal strip, so what is this? What is fixed? My dy is fixed. What is varying? X. So what is this curve? This curve is x equal to y square, and this is what x equal to plus under root y. So what will be the integration? So I will have z. So how to find out the volume? It will be z dx dy or dy dz. Now z dy is fixed, my x is varying, right? So if my x is varying, so here I will have first x then dy. Okay, and what is the limit of x? Y square to under root of y, left to right. And outside, what is the outside limit? So what are the intersection points? So the limit of y, so y is going from 0 to 1, so you can see the intersection, y will go from 0 to 1, so this will go from 0 to 1. So this is one of the valid answers. So here they have represented z as function of x and y. So if I have dx dy, so everywhere I have dx dy, and if dx dy, if the lower limit is y square and the upper limit is under root y, that will be my correct answer. So I see lower limit to be y square and under root y only on this option present. Okay, in all the other options everything is wrong. So here if they are providing you limits as constant, that is totally not valid. not possible. You will never be able to do it. Okay, and here also both limits are variable, that is also again wrong. Here also both limits are variable, that is also wrong, right? Only, obviously only this option will be correct. That is what we have solved here. So if I would have had to write in terms of dy dx, how I would have solved it? So this will be simply z, now dy dx, right? So dx is constant, so this I will choose the vertical step. So here what are my functions? So what is this curve? Y equals to x square. So in the bottom I will have x square, because this curve is y equal to x square, y equal to x square. And what is this curve? This curve is y equal to under root of x. So this curve will be y equal to under root of x, that's it. So it is similar only, it is similar, okay. And outside will be again x will go from 0 to 1. So that will be the solution basically for this particular question. So that's how you use change of variables, okay. I hope you have understood how to use change of variables. So this you don't need to understand, like Jacobian we will skip, we will not use Jacobian, that is okay, that is not of our concern, we'll skip that. Okay, let me skip the Jacobian part, give me 1 second. Yeah, so we're done. So triple integration is nothing, mostly they will give you some constant values to solve the triple integration. It will be much easier for you. So we can solve a triple integration, you'll understand, okay. So if I want to solve this, right, x plus y plus z. So if x is given here, dy dz. So if you see that only x and z are there, right? So this means y is not there. So this means this is the limit of y. If let's say I had here y plus x, that would have meant that this was limit of z, okay. I hope you get the point, right? So, and as soon as you got that I have taken the limit of y, so y is not a possible answer here, and I have z, so z also cannot be the possible answer, so only x. So these are the limits of x, and you have taken the limits of x, y, ultimately this is constant, so this will be the limit of z. So that's how you can understand what, like, which are my variables, what are my limits basically, okay. So I can solve this now. So first I have y, right? So if I have y, so first I should write here dy. So although dx, dy, dz is written, but if this is the limit of y, right? So you will write dy first, okay? Because they don't actually take care of the this arrangement, right? So this will be here, if I want to solve this, minus 1, 1, 0, z, this will be yeah, x minus z, x plus z, to x plus y plus z dy, then I will have dx, then I will have dz. So first of all, when I am integrating with respect to dy, all the other variables will be constant. So this will be x into y plus y square divided by 2 plus z into y, and I will go from x minus z to x plus z. Sorry for the background noise. Pressure cooker is there, right? So it's home, we cannot do anything, okay. So yeah, this will be like you can put the values over here, right? X plus z, x minus z, I can put the value of y. So if I put the value of y, right, this will be basically x into y is there, so this will be 2z plus y square. Okay, this is interesting. So this will be x plus z whole square minus x minus z whole square, like I'm just doing this in rough, divided by 2, then you will have plus z into, this is z, into 2z, okay. So this is the inside solution. Now I will integrate this function again with respect to x, okay. With respect to x you can integrate, so you will get some value, and then ultimately you will put the x value equal to z. Like I can solve this, let me solve this, otherwise you will cry in the comments. So then I will integrate with respect to x, right? So if I integrate with respect to x, this will be okay. So I will treat, okay, this will be this. So here, right, if I solve this thing, right, this will be basically x plus z minus of x minus z, or x plus z into 2x, right? So here what will happen, this will be what, this will be 2z. Yeah, so this will be basically this thing, right? This will be 4 into, or this will be total, this total will be 2zx. This will be 2zx, and this will be plus 2z square. This also is 2zx, so this will become 4zx. Okay, I'm just solving this in a fast manner. Plus 2z square, right? So this will be 4zx. So if I integrate this, right, and with respect to x, so this will become zx square, 2zx square plus 2xz square, and the x values are 0 to z. Okay, minus 1 to 1 dz. So this will be okay, this will be, if I put here 0, 0 will be anyways gone. This will be 2z cube plus 2z cube, that is 4z cube, and I have to integrate from minus 1 to 1. This is anyways an odd function, so this will be 0, right? Dz, this will be 0, right? This will come out to be 0. So 0 will be answer. So that's how you solve the triple integration. So now finally we will solve few PYQs on multiple integrals. So let's solve questions on multiple integrals. So this is the first question that came in EC 2022. Okay, this is a question of double integration. So we have been given this function and we have to integrate, we have to perform the double integration around the region D, that is this triangle. So what options do I have? So I have two options, right? Either I will choose a vertical strip or a horizontal strip. Now tell me which one is better for me to choose. Like for now, just by seeing these two diagrams, if I choose horizontal, right, I see the definition of the function is changing here. There is a turn here, right? There is a turn, sharp change. So whenever there are corners, that is a red flag for me, right? I hope you guys know what is red flag, green flag. So this is a red flag. So first I will try to solve using vertical strip. If it does not work out, then I will move on to horizontal, because if I am in the vertical strip, I am not facing any corners. I am facing the corners at the end, at the starting, right? Not in the middle. Okay, so I will choose a vertical strip. So if I am choosing a vertical strip, what is fixed? My obviously dx will be fixed, right? Dx is fixed. So that is basically x is going from x equal to 0 to x equal to 4. You see this point is x equal to 4. And what about y? So what is this line? This line is nothing but y equals to minus of x. And what is this line? This line is nothing but y equals to x. So basically the integration will be it will be, first of all, it will be y, because that is my variable, y equals to minus of x, lower side to the upper limit, y equals to x, from x equal to 0 to x equal to 4, into 3 into x square plus y square dx. Okay, this is y, right? These are the limits of y. So I will have dy dx. So this will be equals to so if I solve this, right, this will be now 3 can come outside. This will be y x square plus y cube divided by 3 minus x to x. So this will be 3. If I put, right, this is nothing but a even function, right? So this will be multiplied by 2, or I can directly solve it. This will be 0 to 4. This will be 2 into x. So this will be 2x cube plus 2x cube divided by 3 basically, which will be 4. Yeah. So if I multiply by 3, right, inside, this will be 4 6x cube plus 2x cube. So this will be 8x cube dx. So this will be 2 into x raised to power 4 going from 0 to 4, which is 4 raised to power 4. So what is 4 raised to power 4? 4 raised to power 4, 4 raised to power 4, 4 raised to power 4 is 256 into 2, 512, and they have asked me to round off to the nearest integer. So 512 will be the answer. So like you are seeing, right, how simple the questions are. Okay, the questions, the level of the question that will be asked will be very simple. Okay, so again the homework would be to consider the horizontal strip and break it down into two parts and confirming whether I am matching my answer. So please do it, please do this, okay, so that this will be a good practice. Someday what will happen, you have to choose a horizontal strip, you will not have the option, like just like the question that you did, right? So be careful. So yeah, let us now move on to the next question. Let me delete these pages as well, right? Keep this, delete these pages. Yeah, so where is, this is the next question. Again, this is a EC 2023, so every year they are kind of asking questions. So now this is kind of bit difficult, right? So if I choose a vertical strip, if I'm moving along, right, again I'm facing a corner point here, right? That is a problem. If I choose a horizontal strip, again I'm facing a corner point. So in both cases I'm facing corner point. It does not matter what I choose, but I will choose a vertical strip. Why? Because already the y values are given, so that is easier for me to write. Or otherwise, like you can choose a horizontal as well, you have to write x in terms of y. That is the only difference. I will choose a vertical strip because in both orientation I will always receive a corner, so I have to break it down into two regions. So they are asking me, let us read the question, I forgot to read the question. We have to find out the integral around the region R, xy dx dy over the region. Okay, so basically I will break it down into two regions. This will be region 1, this will be region 2. Okay, so here this will be y equals to minus x, y equal to x plus 2, and in region 2 the upper limit will be y minus x plus 2 and lower limit will be y equals to x. So and how is my x moving? So what is the value of x here? So I see that my y value is 1. So when my y is 1, what is the value of x? So if I put here 1, right, in any of these places, the x comes out to be minus 1. So you put y equal to 1, x will be minus 1. Here also you put y equal to 1, x will be minus 1, because this is the point of intersection. So this point is the x equal to minus 1 comma 0. Okay, or this point is basically minus 1 comma 1 point, correct? And what is this point? This point will be simply 1 comma 1. Again, if you put x equal to 1, you will, sorry, you put y equal to 1, you will see x is equals to 1, or here also x is equals to 1. So basically I will break it down into two regions. So in the first region my x will go from 0 to, sorry, minus 1 to 0, and in the second region I will go from 0 to 1. And what is the inside integral? Inside integral for the first region, y is from minus x to x plus 2, minus x to x plus 2, and the function is xy so this will not be dx anymore, this will be dy dx plus yeah, here this will be what will be the lower limit? Y equals to x to y equals to minus x plus 2. So xy dy dx. Okay, so this will be equals to, if I solve it now, right, this will be minus 1 to 0, x can be outside, this will be y square by 2, y square by 2, right, by 2 can be outside, minus x to x plus 2, here also this will be y square by 2, 0 to 1, this will be x2 minus x plus 2, correct? Yes, so this will be 1 by 2 can be outside, right, this will be minus 1 to 0, this will be x, so x square plus 2x plus 4 minus x square, so this will be basically 2x plus 4. 2x plus 4, and x is also there, right? So this will be 2x square plus 4x dx plus and what will be this one? This will be x square minus 2x plus 4 minus of x square, right? So this will be minus 2x plus 4 or 4 minus 2x, and okay, I forgot to write the x here, right? Here also I have a x. So this will be 4x minus 2x square dx. X is varying from 0 to 1. Okay, so this will be equals to 1 by 2. The integration would be 2 by 3 x cube plus 2x square, where my x is varying from minus 1 to 0, and for the second one this will be 2x square minus 2 by 3 x cube, x is varying from 0 to 1. So if I solve this, what will be this? So if I put here x equal to minus 1, this is minus 2 by 3 and plus 2. So minus 2 by 3, so 2 minus 2 by 3, which is 4 by 3, and it is the lower limit. So here I will have minus 4 by 3. Okay, minus 4 by 3, and this will be what? This will be if I put here 1, this will be 2 minus 2 by 3, that is again 4 by 3. So 4 by 3 minus 4 by 3, right, will come out to be 0. So 0 will be your answer for the question. Okay, so this will be the answer for the question. 0 will be the answer. Like, this was bit lengthy because I had to break it down into 2 regions, that's why. And this is a recent question. It's not like I'm solving like very old question. They are asking from double integration. So let's solve the next question. So this is the next one where we have to find out the value of the double integral. Now I have not told you what is, like, how to solve in different coordinates. I will explain about different coordinates in vector calculus. For now you can assume this just like x and y. R and theta are just like x and y. Okay, but without even knowledge of multiple coordinate, you will be able to solve it. So theta is radians and r is simply the radius. Okay, but you don't need you don't need the knowledge of that. So I have to solve this question, right? So remember, this is written cos theta. So what is the limit? It will be r equals to cos theta, right? Because this is already a function of theta. This cannot be theta equals to cos theta, right? This will be r equal to cos theta. So finally the outside limit will be theta equals to pi by 2. So I got my order of my integration. So let me see, like, is this in variable separable format? Yes, it is in variable separable format. So I can individually find out the okay, no, I cannot do the variable separable because my limits are not constant. So let me first solve for r. Okay, so if I solve for r, sin theta is just a constant. This will be r square by 2, right? R square by 2. So 1 by 2 can be outside. Integration of 0 to pi by 2. Okay, into d theta. Okay, so this will be 1 by 2. Okay, what r square is going from 0 to cos theta, right? So this will be basically integration will be 0 to pi by 2 sin theta cos square theta d theta. So again, this we will use the Wallis formula. So this time my sin theta is odd. Whenever sin theta is odd, then what will happen? What was the answer? Answer was simply k. If you remember, answer was simply k by 2. Sorry, answer was simply k, right? Answer was k if any one of them is odd. So, and what is k? K will be equals to power of sin theta is 1, so it will be 1 I will start with cos theta. Cos theta is 2 minus 1. So I will stop there. Divided by m plus n. M plus n is 1 plus 2, that is 3. And m plus n minus 2, that is 1. This will be equals to simply 1 by 3. And I think it was k by 2. K by 2, right? It was k by 2. If I remember, I also tend to forget. I think it was k by 2 if I remember it correctly. Let me go back and check. I also tend to forget this, right? We had solved this much earlier, like in the starting of this marathon, right? I think there I told you it was k by 2. Where is it? Where is it? Where is it? Where is the Wallis theorem? Where has it gone? Yeah, here. Sorry, it was k. It was, I was do right only. It was k. Okay. So put, if it was k, m plus n minus 2. So if it was k, okay, sorry, there was already half, right? Because the answer is 1 by 6. I was thinking, what am I doing wrong? Okay, yeah, there was already half, right? So this was like into half will be there outside. So this will be 1 by 6. So I remember it correctly, but I forgot that there is a half sign. So these kind of silly mistakes will be there in your exam. So this will be 1 by 6. So your answer, right? So sorry, this will be k will be equals to this, and your answer I will be equals to k by 2, that is 1 by 6. So 1 by 6 will be the answer that is present in option B. So 1 by 3 was anyways not in the option, so you would have been able to like fix it. Okay, let's solve the next one. Here the value of the double integral, okay, is this. What is the value of a? So you see that these are all constant, so it is very simple for you to solve. So I can solve with respect to, like, already the limits of y are given, right? So let me solve with respect to y. So if I assume a variable t equals to x plus y, so what is my dy? That will be equals to dt, because x is constant. So this integration will be, I will not write the limits now. This will be dt upon t square into dx. Okay, so this will be equals to integration of minus of 1 by t. And what is minus of 1 by t? It is simply x plus y. Now I will put the limits of y. So y varies from y equals to 1 to y equals to 2 into dx, where my x varies from x equal to 3 to x equal to 4. So this will be equals to 3 to 4. This will be basically 1 by x plus 1 minus 1 by x plus 2. So if I integrate this, this will be ln of mod of x plus 1 minus ln of mod of x minus 2. So I can write it directly, x plus 2. Then I will put the limits, x equal to 3 to x equal to 4. So this will be, if I put 4, this will be ln 5 divided by 6, ln of 5 divided by 6 minus ln of, this will be 4 divided by 5. So this will be basically ln of 25 divided by 24. So it is already given me that, like, this is 24, right, by 24. So what will be the a value will be simply 25, because it is ln of 25 divided by 24. Remember, log base e means natural logarithm. So a is 25. A will be equals to 25. Let's solve this question. So the volume determined from this equation, right? What will be the volume from this equation? So simply they are giving you, okay, volume determined from this for v equals to this. Okay, so basically your they have given me your x range, this is my y range, okay, and this is my z range. Although they should have actually properly written it, but like I hope you get the point. Like generally you write volume is x y z, right? X into y into z. So this is my x range. So x is going from 2 to 3, y is going from 1 to 2, and z is going from 0 to 1. Like although nothing is mentioned, but by default you assume this sequence x y z. So my limits are constant, and this is a variable separable format, right? So I can simply integrate them separately. So my z is going from 0 to 1, I will integrate my z dz, and my x is going from 2 to 3, and my y is going from 1 to 2. Okay. So this will be equals to 8 into z square by 2, that is simply like 1 by 2 can be outside because all of them, okay, into z square by 2 into x square by 2 into y square by 2. So I can take that like all the constant outside, 1 by 2, 1 by 2, 1 by 2. So this will be 1 square into 3 square minus 2 square into 2 square minus 1 square. Okay, so this will be 8 will be cancelled. This will be 1 into 9 minus 4, that is 5 into 3, so 15. So 15 will be your answer for this question, and with this we are done with multiple integrals. Now we will do few miscellaneous topics on integration. So let's start with the miscellaneous concepts. So the first one is length of arc. Now I want to say this at the starting itself, this will be a bit formula based, and I have not seen much question getting asked from these topics for electrical EC guys, but few things are there that are not formula based. Those things have been asked for EC guys. Okay, that I will discuss. Basically the series form, right? So the length of arc and the formula things mostly I have seen it getting asked in mechanical civil branches. We will see them one by one. So this one is the first, length of an arc. So if I have a curve, right, what will be the length of this curve? Okay, so how can I find out the length of this curve? So I can choose a very small length dx. Okay, if I zoom in this curve, right, so a very small distance dx and very small distance dy I can choose. So this will be dy and dx. So I can find out the very small length ds. What will be the small length? It will be dx whole square plus dy whole square whole under root. That is my small length basically. So that is what my small length ds is equals to. So that is my small length. Now if I want to overall find out the length, what do I have to do? I have to simply integrate this ds, right? From either from x equal to a to x equal to b, like if x equal to a to x equal to b. So what I can do, I can find out the small ds and I can add them up, right? So I can integrate this from x equal to a to x equal to b, or if you want to integrate, you can integrate in terms of y as well, from y equal to c to y equal to d. So either way will work. So this will, if I take this dx common right here, this will be dy by dx whole square. So if I integrate this with respect to x, I will get my ds, or what you can do, you can take dy common. So this will become dx by dy whole square whole under root plus 1, and dy will be outside. So then you can integrate with respect to dy, whichever one is your convenience. So like it's not like you have to remember anything, right? So this one I have proven it to you, and simply you take dx common here. So this will be 1 plus dy upon dx. So your length will become like, this is the formula that they say, but they never derive this formula, but here I am simply deriving the formula. So the length of arc will be simply 1 plus dy upon dx whole square, x equal to a to x equal to b, or you can write this in terms of dy if I take dy common. So here what will be the length of arc? Very simple. You will find out dy upon dx, dy upon dx, that will be x raised to power half. So this, right, this power is 3, this power is 3 by 2. So if I differentiate this function, this will be x raised to power half. Okay, so my answer will be 1 plus dy upon dx whole square. So x raised to power half whole square will be x whole under root, and x is going from 0 to 1, y, because they have told me x is going from 0 to 1, right? So I can easily solve this. What will be the solution? So 1 plus x under root, right? So I can again assume t is equals to 1 plus x. and then you can solve, right? Then you can put the limits and this will be solvable. So I hope you can solve this. It will come out to be 1.22. Now if they have given you in r and theta, then this will be the formula in terms of r and theta, but you don't need to remember it, don't worry. Mostly they will ask you in two-dimensional x and y. Okay, now also if let's say my x is a function of time, y is a function of time, and time is from t1 to t2, how can I find out the distance? So you will differentiate your function with respect to time, you will differentiate your y with respect to time and multiply by dt. So basically this, right, this is nothing but dx square plus dy square. So if I take this dt inside, so if both your x and y are function of time, so you can solve it like this. Okay, simply like this is the main formula, right? I have to integrate. So what I can do, I can multiply and divide by dt. So ultimately this will be dx by dt, this will be dy by dt. Okay, if your x and y both are function of time or something else. Now there is another thing known as volume of solid revolution. So if I have this curve, right, if I have this curve and if I revolve around the y-axis, so let's say I have a, how can I represent this straight line? This is a straight line and I am revolving. So what volume is it enclosing? It is enclosing like a cylinder, right? It is enclosing like a cylinder. So that's why I have to calculate the volume covered by this curve from x equal to a to x equal to b. So what will be the volume? So this is like small circles, small circles. And what is the radius of the circle? Radius of the circle is y. If I have to find out the revolution around x axis, then the radius is simply the y value. This at this point at x equal to some value, the radius is this y, and here the radius will be again y coordinate. So what am I doing? Simply now what am I doing? If I find out the radius and if I calculate the area, so I got a disk. Again, if I move in front, I will get another disk. Again, if I move in front, I will get another disk. So what I will do, I will just keep on adding up this disk. I will just keep on add this disk to get the volume. To get the volume, I will just keep on adding this disk. Okay. So what is the area of the disk? It is pi into y square. The radius is y square, and I am moving from x equal to a to x equal to b. So I will simply integrate from x equal to a to x equal to b, and my y is obviously a function of x. Okay, I can show you an example. Where is there is no example. Yeah, here. So what will be the volume generated by revolving the area bounded by the parabola? Let me first do it about the x axis. So what will be the volume generated if I revolve this parabola around the x axis, right? So if I am revolving, no need to remember any formula. If I am revolving any curve, right, around x axis, that means I have to add the small circles. And what is the radius of the small circle? Y, right, the y coordinate basically. So the formula would be simply pi y square, and I have to integrate from x equal to 0 to x equal to whatever point they have told me. So for now, let's assume an example. I am integrating from from x equal to 0 to x equal to 1 dx, right? And so what is my y square? Y square is given in the question, parabola is given, that is 8x. So I can replace my y square with 8x. So I will integrate from 0 to 1 dx. So now I hope you can solve it. This will be something x square by 2 something, right? So like I was just taking an example how to find out the volume of revolution around the x axis. Now if you have to find the volume of revolution around the y axis, so if you have to find the volume of revolution around the y axis, then what is the radius this time of the circle? It is the x coordinate, right? It is the x coordinate. So now the area is x coordinate, so your volume will be pi x square, and x will be written as a function of y dy, because I am moving from y equals to c to y equal to d, right? So now y is constant and x is the variable. I hope it is clear. What about the surface area? So it will also, like this rings, right, it will cover a surface basically. There will be a surface, right? So the surface will be decided by the circumference, right? If I keep on adding the circumference, so this is like a circle, again another circle, again another circle. So this is covering a surface area, right? So if I just keep on adding up these perimeters, right, this will give me the overall surface area, correct? If I keep on adding up the perimeters, that will give me the surface area. If I keep on adding the areas of the disk, that will give me the volume enclosed, right? So the the surface area will be simply, what is the formula for surface area of a circle? It is 2 pi times the radius, 2 pi r. Here what is the radius? 2 pi y. So it will be 2 pi into y and dx. In our case, this will be dx, and here it will be dy. If I am revolving around the y axis, it will be dy. Okay, and sometimes your ds, right, like your x and y both are functions of time, then your like this becomes this one, whichever one I had derived previously. Okay, but mostly it will be this formula, and how it comes I have derived it, and this formula, right, 2 pi x into dx if I am revolving around the y axis. Do you need to remember the formula? No, just draw the curve and understand conceptually what will be the formula. Okay, how can you remember all these things? This will be very difficult for you to remember, right? So draw the curve and understand what am I doing, what is my radius. Okay, so let's solve this particular question. So here we have to solve the volume generated by revolving the area bounded by y square equals to 8x and y axis, and the line y equals to -4 to y equals to 4 about y axis is. Okay, lot of information. So the volume y square equal to 8x, y square equals to 8x. So y square equals to 8x would be, so yeah, y can be both negative and positive. This will be the y square equals to 8x. This will be the graph, right? Y square equal to 8x, and you have to find out the and the line y equals to -4, y equals to -4 would be this line, right? No, not this line. Y equals to -4 would be this line. When y is -4, this will be, x will be 2, okay, and y equals to +4. So in both the cases x is 2. So this is the line y equals to -4, and this is the line y equals to 4. Okay, y equals to -4 and y equals to 4. Now I have to find out the volume. Yeah, so basically I'm revolving around the, so they are asking me, I'm revolving around the y axis. I'm revolving around the y axis. So if I'm revolving this curve around the y axis, right? So what is my radius? Radius will be x. Radius will be x, right? Because I'm revolving about the y axis. This is my y axis. So radius is x. So what is my x? X is equals to y square divided by 8. Correct? So what will be the volume? The volume will be simply pi x square integration dy, where my y is going from, because they gave me y equals to -4 to 4, because I am covering from here to here. So the volume will be something like this, will be the shape basically. The shape will be like this. If I draw the mirror image, right, the shape would be somewhat like this, like a, I don't know what is this shape, but whatever this shape is, that is the volume basically. That is what we are calculating. So this will be pi x square dy, and y is going from -4 to +4. Y is going from -4 to +4, and what is my x? X is y square by 8. So this will be x. So this will be, pi can go outside, and if I do the square, right, this will be 64 -4 to 4, and this will be x raised to power 4, right? Yes, x raised to power 4 dy. So not x raised to power 4, y raised to power 4, and this is a even function, so I can multiply by 2. So this will be pi by 32 0 to 4 y raised to power 4 dy. This will be 1 by 5 into pi 32 into 4 raised to power 5. Okay, so this will come out to be 4 raised to power 5, 4 raised to power 5. So this is 4 into 4, 16 into 2. So 4 cube and another 2. So 2 into 4 square, 2 into 4 square is 16, 32 by 5 pi. Okay, so this will be your answer for the question. So that's how you solve like this volume revolution. Did I tell you to remember any formulas? No, simple concepts, use simple concepts. Okay, so yeah, let's now solve the the next topic, that is improper integrals. Improper integrals means basically either if one of the limits or two limits or some limit is not proper, like infinity. Okay, So for solving improper integrals, what do? You assume this, right, upper limit to be t, and you write limit as t tends to infinity, limit as t tends to infinity, and then you integrate. Okay. Now there can be two cases. This integration can either converge. When will this converge? If the limit of as t tends to infinity is some finite value. If it is infinite, then the series is divergent. If it is infinite, the series will be divergent. Okay. So what you'll do, whenever you have infinity or minus infinity or something like that, right, you replace your t with infinity, and then you will solve the limit as t tends to infinity. So one more thing is there, that if in the both sides I have infinite limits, right, so maybe at some point in between the function is not continuous. So make sure you are taking a break, right? I've already told you when to take a break. So for let's solve this question. So I have to solve 1 upon x cube, 1, like x is going from 1 to infinity, right? So is my function discontinuous in the given domain x is equals to 1 to infinity? Is it discontinuous? No, it is discontinuous at x equal to 0. So it is totally continuous, no problem. So what I will do is I will replace my t, I will replace my infinity to t. So I will go from 1 to t, and I will write t is tending to infinity. This will be 1 by x cube dx. The solution would be n plus 1, right? So minus 1 by 2 can come outside. Limit as t tends to infinity, this will be 1 by t square minus 1 by x square. This is 1 only, minus 1. Okay. So now if I put limit, if I put my t tending to infinity, will it break? No, it will not break. I will get a finite value, that is half. So series is convergent. So if it diverges, I will get some undefined value. If it converges, I will get a defined value. Okay. So yeah, this thing, same thing I think we have already discussed. If there will be some discontinuity, right, we have to break the function just before it and after it. We have to solve just before it and after it, just like here, right? If I am solving from x equal to 0 to 1, I know at x equal to 0 this function will simply break. So I will not solve it at x equal to 0. Okay, I will solve it at x equal to 0 plus, and this will be 1 by under root of x, okay, dx. So I is equals to 1 by under root of x of dx. So if I solve this, this will come out to be, I will not solve at x equal to 0, but because at x equal to 0 function will break. So what I will do, I will assume a number h, I will assume a number h, okay, and I will write limit as h tends to 0 plus, limit as h tends to 0 plus. I will solve this integration now. So if I solve this integration, this will be basically 2, sorry, this will be 1 by 3 by, sorry, 1 by, yeah, 1 by 1 by 2 into under root of x h1. So this will be where my limit h is tending to 0. So this will be equals to limit as h tends to 0. So this will be 2 into limit as h tends to 0. This will be under root of h, like I'm sorry for the background noise, it is bit raining right now. So under root of h, sorry, 1 minus, just give me 1 second now. Okay, 1 second. 1 minus under root of h. So if I put my h equal to 0, is it diverging or converging? It is converging. I am getting some finite value, right? So this will be 2. 2 will be my answer. There is no problem. So don't directly replace here 0, right? Don't directly replace here 0. You assume h, and then at the end you put the value of h equal to 0, because you have to check whether the limit exists or not. So yeah, like there is an example of this one, right? Because we know my tan does not exist at pi by 2. So what we can do, we can solve for pi by 2 minus h. I am getting really close to pi by 2, but exactly not equals to pi by 2. I am getting really close to pi by 2, but exactly not equals to pi by 2, because my function does not exist at pi by 2, right? So I am getting somewhere on the left hand side of pi by 2. So if you solve this, right, it will come out to be like integration of tan x is log of mod of sec x. So if I put the values, right, so you will see you are getting an undefined value. So the series does not diverge. Series does not diverge, it converges. Integration does not diverge, it converges. So integration basically is not possible for this. Similarly, if I solve another question like this one, right? So if I solve this, I will break this integration into two parts, because I know at x equal to 0, my integration is definitely, like, this value is definitely discontinuous, right? So I'll break it down into two parts. So I go from -1 to 0 minus, right? Because I cannot go exactly to 0. So I'll go -1 to 0 minus 1 by x square dx, and plus I will go from 0 minus 0 plus to 1. I will not touch 0. I will not touch 0. Okay, to 1 by x square dx. Now, what does 0 minus means? It means a very small number that is close to 0. So this can be replaced with minus of h, and this can be replaced with h, where h is a very small positive number. Okay, so I can replace this, right, integration with minus h, where, like, this is nothing but the left hand limit, right? So minus h 1 to 1 by x square dx plus h 1 by x square dx. Okay, this will be h, and limit as h tends to 0. Now the interesting thing that will happen here, if I solve this integration, this will be, negative sign will be there outside always, limit as h tends to 0, this will become minus of 1 by h, minus of 1, right, and this will be plus 1 minus of 1 by h. So this is coming out to be, if I take the negative sign inside, limit as h tends to 0, this will be 2 by h. Hold on a second, this should be also, negative sign is there, right? Something, hold on a second, I'm doing something weird. Oh sorry, this will be -1, right? What I'm doing, this is -1. Sorry. So if this is -1, right, this will be +1. Sorry about that. So this will be yeah, 2 by h, 2 by h and minus of 2. Okay, 2 by h and minus of 2. Now can I put my h equal to 0 here? This will go to infinity, right? So of course this integral does not converge, it diverges. And you will see in many textbooks everywhere else, right, they will solve it as if it is converging. In other institute as well, how will they solve? In other institute, how will they solve? What they will do, they will simply integrate 1 by x square, and they will not break my limit, they will directly solve. So what is the integration of 1 by x square? Minus of 1 by x, going from -1 to 1. So they will say this is minus sign is outside, so this will be 1 minus of -1, so they will say this will be -2. Okay, they will say this will be -2, but they will be totally wrong. So be careful, like, what you are solving, be very careful here, right? So it will not be equals to -2, it will not be equals to -2, because your series will diverge meaning the sum will not be some finite value, it will be infinite value. Why? Because if I plot the graph is somewhat like this. This is the graph of 1 by x square. Okay, around 0 the function is going to infinity, right? So please be careful, put your limits properly. Okay, put your limits properly. So how to solve the improper integral, that also I am teaching. Okay, so trust me, in other institute they don't even go into this question, and they don't even tease this, that is my guarantee. Now let's discuss the important topic, that is limit of sum. From this topic in EC questions have come. So if I have this integral, right, so we can actually, like, if I have some series, we can write this series in continuous domain. We can write this series in continuous domain. So how, like this is the formula basically. How can I convert a discrete function to a continuous function? So what is, like, let me take an example. So this is a sum. Okay, I see that n is tending to infinity. That is there, n is tending to infinity. This is 1 2 3 4 5 6, like this it will increase. So first term will be 1 into n plus 1, second term will be 1 divided by n plus 2, third term would be 1 divided by n plus 3, fourth term will be 1 divided by n plus 4. So I can write this will go on forever. So I can write it like this, right? So this can be, I can choose a variable r that will start from 1 and that will go on till n, because n is tending to infinity, so r is also tending to infinity, and r is a discrete number, 1 2 3 4, like that. So this will be 1 upon n plus r, 1 upon n plus r. So now what I will do is I will try to make this as a function of r by n. How to make this function of r by n? I can take my n common here. If I take the n common, this will be, n can come outside, this will be 1 upon 1 plus r by n. Okay, so basically now we can replace our r by n with x. Why? Because x is a continuous variable, so x can take any value. X can take 0 0.1, 0 0.01, 0 0.0001, 0 0.0000000001. It can take 1, 10, 10,000, anything, right? And this variable also can take any value. That is the beauty, because if I, let's say r is 1, so n is tending towards infinity. So if n is tending towards infinity, so I can choose n to be very high value, 1000. So this will be very small value. Again I can choose n to be any value, like 10 raised to power 5, 10 raised to power 6, 10 raised to power 7. So basically, and your r also is changing, right? So r can be 2, r can be 3. So basically this variable is converted into a continuous variable, that is x. So wherever I will have r by n, I can replace that with x. So that is sorted. Now how to replace my summation sign, r equals to 1 to r equals to n, and this actually you have to remember, there is no other way. So how to replace my summation sign? So when r is 1, right, what is my x? So when, if r is 1, what will be my x? So x is r by n, and n is a very large value, so 1 by infinity is what? 0. So when r is 1, so x will be 0. When r is going towards n, right? So when r is n, what is my x? X is equals to r by n, so it is n by n, that is 1. So basically your, okay, sorry. So when r is 1, your x is 0, so your integration will be, this can be converted, x equal to 0 to x equal to 1. Okay, and what else will I convert? So one, don't forget you have 1 by n as well. Now what is 1 by n? So this will be 1 divided by, so what is 1 by n, by the way? So your x equals to r by n. Okay, so if I do dx, this will be simply, and like if I take a small change, small delta in x, that is dx. What is a small change in r? So r is a discrete variable, right? So it will go in steps of 1. So it will be r2 minus r1, and it always goes in steps of 1. So this will be like, because the difference will be, delta will be 1, so this will be converted. So your dx will be simply equals to 1 by n. Okay, so you will convert your dx in 1 by n, because 1 by n is a very small number, just like dx is a very small value. So that's how you can relate. So these things you have to remember basically. So you will find out the series, so you will replace your 1 by n with dx, because your dx is a very small number. You will replace your r by n with x. Okay, you will replace your discrete summation with integration, and of course your n must be tending to infinity, then only all this is possible. Okay, so first of all, your target, always your target should be to get a function that is r by n. So these are your two targets, a function that is r by n and getting the 1 by n term in multiplication. so that I can replace my 1 by n term with dx. So this will be replaced with dx and my r by n term will be replaced with x. So this one unfortunately you have to remember, there is no other way than to remember, right? So yeah, so this will be basically the answer will be ln of 1 plus x mod of 1 plus x, where my x goes from 0 to 1. So this will be ln of 1, that is 0, ln of 2. So ln of 2 will be your answer for this particular series. So the answer for this series will be ln of 2. Now of course I hope you remember few basic summations. So summation of 1 from r equals to 1 to n is n, right? So it is simply 1 plus 1 plus 1, so it will be 3, right? So because I have written it 3 times, so it is 3. Summation of r from 1 to n, so it is the summation of first n natural numbers, that is n into n plus 1 divided by 2. Summation of square is n into n plus 1 into 2n plus 1 divided by 6. This also I hope you remember, summation of a geometric series. Summation of a geometric series is this, okay? If my mod of r is greater than 0, greater than 1, if it is less than 1, so this 1 will be there at the starting, okay? And here we assume that if my n is going towards infinity, if I put here infinity, right, what will happen is that this term will be 0, this term will tend to 0, so automatically this will be a upon 1 minus r. So this is the sum of infinite sum of a geometric series. This is the infinite sum of a geometric series. So these few results I hope you need to remember. Anyways, for aptitude you will remember these results, okay? These are anyways important. Now one more function is there, gamma function. Again I am not expecting these to be asked from ECEEIN. I am expecting this can be asked in mechanical civil, okay? So gamma function is nothing, the integration of this, right? Integration of this function is gamma of n. Now what is your gamma of n? So your gamma of n plus 1 is simply n factorial. So this result is basically equals to n minus 1 factorial. So basically whatever I have here in the power, that will come with a factorial, okay? So that's how you simply remember it. So that is the property, basically property of this integration, e raised to power minus x, x raised to power n minus 1 is simply n minus 1 factorial. This is also called as gamma of n, also called as gamma of n. Now this n can be, this n can be an, cannot be an integer as well, okay? So if n is a rational number, that is not an integer, then your gamma of half, these things you have to remember, is equals to under root of pi, that is written over here. Gamma of half will be under root of pi, gamma of minus half will be minus 2 under root of pi. One property is there, gamma of n plus 1 equals to n into gamma of n if n is a rational number. If n is a rational number, what do I mean by it? Simply, if your n is not an integer, if your n is integer, then your gamma of n plus 1 is simply n factorial. If your n is integer, your gamma of n plus 1 will be n factorial, that is gamma of n will be n minus 1 factorial, okay? If your n is integer, that is n equals to 1, n equals to 2, n equals to 3, then gamma of n will be n minus 1 factorial. If your n is not integer, like half, like 3 by 2, so what will be gamma of 3 by 2? So gamma of 3 by 2 can be found out from this property. So gamma of n plus 1 is n into gamma of n, okay? This property will always be always hold. So what is gamma of n? Gamma of n is n factorial for integer. So there will be n into n minus 1 factorial. So what is n into n minus 1 factorial? That is n factorial, right? So gamma of n plus 1 is simply equals to n factorial. So this relation will always be valid. What you have to take care for half? So you have to remember what is gamma of half. Gamma of half is under root pi. This thing you have to remember. So how do I calculate gamma of 3 by 2? So gamma of 3 by 2 will be simply n into, gamma of n plus 1 will be n into gamma of n. So what is n plus 1? N plus 1. So from there I can get my value of n. N will be half. So this will be equals to half n into gamma of half. Now I know what is gamma of half, that is under root pi. So gamma of 3 by 2 will be under root pi by 2. So that's how you can simply find out the gamma function. This thing you have to remember. So what do you need to remember? This particular thing, that if my x is varying from 0 to infinity and I have a function e raised to power minus x, x raised to power n minus 1, this will be equals to n minus 1 factorial. This is also called as gamma function, that is gamma of n. So gamma of n is equals to n minus 1 factorial. And one more property you have to remember, that gamma of n is also equals to gamma of n plus 1 is also equals to n into gamma of n. These two properties you have to remember. Also you have to remember gamma of half is equals to under root of pi. So from this you can easily derive what is gamma of half. So what will be gamma of half? So gamma of minus half, let me derive gamma of minus half. Gamma of minus half, so my n plus 1 is equals to this will be okay, minus 3 by 2. I will not be able to find out for minus 3 by 2. Okay, so we can we can prove from this. So I know what is my gamma of half. So can I get my gamma of minus half? So what is gamma of half? Gamma of half will be here, if I choose my n, right, n will be equals to n plus 1 will be equals to half. So this will be n will be equals to minus half. So gamma of half will be equals to, like, gamma of n plus 1 is equals to gamma of n. So this will be n into gamma of n, and my n I have got is minus half. So this will be minus half into gamma of minus half, that is equals to under root of pi. So from here I can get the value of gamma of minus half, that is minus 2 under root pi, that is written over here. So that's how you can basically derive the gamma value. So three things you need to remember: gamma of half, gamma of n plus 1 equals to n gamma n, and your integration function. Okay, these are the three things that you need to remember for a simple gamma function, because in mechanical civil they have asked this question. So here this is the question. So here I have e raised to power, I have to find out this integration. This integration you just simply remember that this is the proper format. This will be simply whatever is the power factorial. So 4 factorial, that will be 24. Simply your answer will be 24. That's it. You can also solve this actually. Even if you forget this, right, there is a method to solving this. There is a method to deriving this particular equation, whatever equation there is, right, n minus 1 factorial. There is a method. I can use my DI rule. So let me use my DI rule for a small variable. Let me find out for a small variable, right, e raised to power x and x cube. So which one shall I choose as my integration? ILAT, right, exponential. So I should choose my exponential as my integration and x cube as my differentiation. So DI, or let me keep it 4 only. Okay, so DI. So let me solve this one only. Okay, the complex one. So this will be x cube, 4x cube, 12x square, 24x, and 24. Okay, and this will be minus e raised to power x, and this will be plus e raised to power minus x. This will be minus of e raised to power x. This will be again e raised to power minus of x. Okay, so I will solve using DI method, because after this will be 0, right? So again this will be minus of e raised to power minus x. So this will become 4. So I will multiply these two, plus minus plus, sorry, hold on a second, plus minus plus minus plus. So x raised to power 4 into e raised to power minus x. Okay, and minus this there, right? So minus, then minus 4x cube e raised to power minus x. Then, so what will happen? All these, right, will be 0 actually. All this will be 0 because I have two limits, x equal to 0 or x equal to infinity. When x is equal to 0, this term will be 0. When x is infinity, this term will be 0. So ultimately, right, whichever ones has x or e raised to power minus x, that will be 0. Only in a single case it will not be 0, only in this case. What will happen in this case, right? This will be minus of 24 e raised to power minus x, correct? And I will put my upper and lower limits. So lower limit is 0, upper limit is infinity. So if I put my upper limit, of course e raised to power minus x will go to 0, but at x equal to 0 this is non-zero, which will be minus of minus 24 So 24 is your answer. So even if you forget this, right, still I can do it. So इतना तो बनता है. If you are enjoying this, then do hit the like button. Even if you tend to forget the like this formula, right, still I can easily solve using DI method, because I know all these terms will be 0, because if x is 0, this will be going to 0, and if x is infinity, anyways everywhere I have exponential, so all the infinity terms will be 0, because e raised to power minus infinity is 0. So only the last term will be the important term, and from this I can get 24, and I hope if you get 24, right, you can relate, okay, I have 24, maybe this is 4, so this will be 4 factorial. So from this you can remember. So how to remember the gamma function? So first of all you write this, so this is equals to my gamma of n, which is equals to n minus 1 factorial. So gamma of n I can get, which is equals to n minus 1 factorial, and gamma of what do you call, gamma of sorry, what is it, gamma of your gamma of half will be under root pi, and n into gamma n will be equals, gamma of n plus 1 will be equals to n into gamma n. So these three things anyways you remember, right? But to solve this integral, it's not like if you forget this, right, you will not be able to solve it. Still you will be able to solve it, but these three things you anyways remember. Now there is a function like the same formula that I derived using gamma function, but you don't need to remember it. Okay, like this will actually work for m and m when your m and n are both fraction, but we don't need to remember the fraction part, that will not be asked. So ultimately whatever I have derived for when m and m are integer or stuff, that is more than enough. So let's solve this question. Let's solve this question. Actually I had already taken the space here, so let me solve the question. Let me take a page. Okay, we cannot take a page. So yeah, if I take this page, right, so if I solve this, how to solve this? So this is kind of again, at one of the limits the function is discontinuous, but I will try to put like 0 plus, right, I will not go at 0. So I'll solve for h to 1. At 1 this is definitely not discontinuous, and limit as h tends to 0 plus, right, 0. Okay, ln of 1 by x raised to the power of 4 dx. Now this at first glance is pretty difficult for me to solve, right, because I don't know how to solve this. So I can think of something. Let me think that if I choose my 1 by x to be t, if I choose my 1 by x to be t, what will happen? Then I can say my dt will be equals to minus 1 by x square into dx. Okay, that is what my dt is equals to, right? Sorry, okay, let me not choose let me not choose this. Let me choose ln of 1 by x to be equals to t. Let me choose it. Okay, so if I choose ln of 1 by x equal to t, then what will be your x equals to? Your x will be equals to, if I take the exponential on both sides, this will be 1 by x, that will be equals to e raised to power t. So your x is equals to e raised to power minus t. Okay, x is equals to e raised to power minus t, right? So x is equals to e raised to power minus t. So what will be your dx equals to? Dx will be equals to minus of e raised to power minus t into dt. Correct? That will be your dx equals to. So I can replace all these things. So this will be t raised to power 4 into minus e raised to power minus t into dt integration. Now, if your h is tending to 0, right? If your h is tending to 0, what is your t tending to? T is tending to infinity. T is tending to infinity, right? So I can replace my like 0 to h to infinity here, and if x is 1, right, then t is tending to 0. This is 0. So I can remove my limit. Because I have put infinity over here, and I know the solution of this because I can swap the limits. So the sign will also be changed. So this will be sign also will be changed. So this will be 0 to infinity e raised to power minus of t raised to power t dt. So this is, I know the solution of this, right? This is nothing but n factorial, that is 4 factorial, n minus 1 4 factorial, right, which is 24. So 24 is the answer. Okay, so that's how simple the answer is. But you can again solve this using DI method. But yeah, here what I have done, I just simply use the method of substitution. Okay, but don't worry, these kind of questions will not be asked. I'm expecting like this much difficulty level they will not be asking. So that is the solution. So one more small topic is left regarding the convergence test, and mostly this has been asked in GATE. This thing has been asked. They have not even asked you the sum and all those things, right? They have asked you this convergence test. What does it mean? So if I have a series, okay, then will the series converge or not? What does converge means? Converge means that I will get a finite value of the sum, then we say the series converges. If I get an infinite value, then we say the series diverges. And sometimes what happens, using our, like we have mainly two tests, ratio test and p test. With these two tests we check whether my series will converge or diverge. So ratio test is simply taking the ratio of two consecutive terms. What do I mean? So let's take a very simple example, 1 by n square. So how can I check, will this series converge or diverge? Summation of 1 by n square, where n is going from 1 to infinity, right? So what I will do, I will write the two consecutive terms, n plus 1th term and the nth term. So this is my nth term, right? So I will take the ratio of n plus 1th term and the nth term. If the ratio comes out to be less than 1, that basically means after each consecutive test the magnitude is reducing, then definitely the series will converge. Obviously I am taking the ratio of n plus 1th term by nth term. So definitely if this magnitude is coming out to be less than 1, that basically means the next term is smaller than the previous term. So if the terms are reducing in magnitude, definitely I can say that the series will definitely converge. Otherwise, if it is coming out to be greater than 1, then I can definitely say the series will diverge. But if it comes out to be equal to 1, right, then you have to think something out of the box. Write the terms, do some partial fraction or something, right? Also, if this fails, you go to the p test. What does my p test tells me? That simply if I have a term like 1 by n raised to the power p, so this series will converge if my p is greater than 1. That is self understood, right? If it is greater than 1, like n square, n cube, so after every term the value only will reduce. If it is less than 1, let's say 0.5, so this, right, it does not reduces actually. If n increases, this actually does not properly reduces. Sometimes it increases. So I cannot comment whether my series will definitely not diverge if this is less than 1. Okay, so that is what we do here. That is what my p series test tells me. So for this series I can take the ratio of n plus 1th term and nth term. So what is the n plus 1th term? That is n plus 1 whole square. And what is the nth term? That is 1 by n. Correct? So it is 1 by n whole square. So this will be n square upon n plus 1 whole square. Correct? So now, like, don't forget, always there will be a limit as n tends to infinity. Like I want to check for the highest term, right? Last term. So limit as n tends to infinity. This will be basically, if n is very high value, what will happen? Then this will be dominating than this. So I can ignore the 1. So this will approximately become n square upon n square, which is 1. So the ratio test tells me it is 1. So I cannot say from the ratio test whether the series will converge or diverge. But definitely from the p series test, I can definitely say as my p, that is n raised to power p, this is greater than 1, then definitely the series will converge. Okay, so don't worry, there will be a question in the PYQ. From that, this thing will be cleared. So let's solve the PYQs now. This is the first question. They have already given me that this from minus infinity to infinity e raised to power minus x square is equals to under root of pi. Now what they are asking, if x and if a and b are positive integers, then what will be the integration of this function, right? So they have actually done the easier task. They have already given me what is the value of this integration. They have done the easier task for me, right? But can I, without even them giving me the value of the integration, can I find the value of the integration? No, because what was our standard form? Our standard form was, if you remember, here there was e raised to power minus x, there was not x square. So don't get confused by that standard form. But still I can use substitution, correct? I can use my substitution because already they have given me this integration, right? So what I can do, I can assume what I can do. So I can assume my t to be equals to under root of a into x plus b. Why? Because then I will get this in the form of e raised to power minus t square, right? That will be same as this one, right? X is just a dummy variable. Whether I have t, x, y, w, z, if this is e raised to power minus z square dz, answer will be same. It will not change. X is just a dummy variable. So I will do the same thing here. So I will replace my t with this. So what will be my dt? dt will be equals to under root of a into dx. Okay, so what will happen here? This will be replaced with minus. So now if my x is going from minus, if x is minus infinity, what is my t? T is also minus of infinity, right? X is minus infinity, t is also minus of infinity. These are just constants. Okay, basically under root of a into minus infinity minus infinity. So minus infinity, again plus infinity will be also plus infinity, right? So this will be e raised to power minus t square. Okay, now dx is what? Dt upon under root of a. So I will replace my dx with dt upon under root of a. Now this will be equals to 1 by under root of a integration minus infinity to infinity, and this will be basically e raised to power minus t square dt. Now I already know this value, that is under root of pi. So I can replace this value with under root of pi upon under root of a. So this value will be under root of pi upon a. So under root of pi upon a will be your answer for the question, that is option B. Okay, simple conceptual question, nothing like too serious. So let me solve the next question. This one. So which one of the, yeah, this actually came in civil paper. Which one of the statement is correct? So we have already done this question, right? This integral will not converge. So if you write, like they have also given the option I equals to minus 2, right? If you write I equals to minus 2, you will be wrong, because if you plot the graph, right, at x equal to 0, like the area is infinity. So I will never be able to get my area, right? So that's why this series, like this integral will never converge. This because my function is not defined at x equal to 0. So be very careful. Okay, so option D will be correct answer, and this also has been asked. I think this can be asked in W or EC paper as well. Let's solve the next question. So yeah, let's solve this next question. So we have been given this series, and for the following combinations, will my series converge or not? That is what they are asking. So what is, like, how do I know does my series converge or not? There are two kinds of series. There are two kinds of tests. One is basically using the ratio test. Okay, ratio test already have taught you. Another one is P series test. So both of them we will check. So first we will consider the ratio test. If the ratio test fails, then we will go to the P series test, right? So what is the ratio test? Ratio test is basically the, I have a term en, so that n plus 1th term and the ratio of nth term, this mod must be less than 1, then my series will definitely converge. If this is greater than 1, then basically your series will diverge definitely. Now if it is equals to 1, right, then we have to check the P series test, right? And what is the P series test? This is the P series test that I have already told you, that if I have a term that is like 1 by n raised to power p, right, if p is less than or great, sorry, if p is less than or equals to 1, series will diverge. If p is greater than 1, that is like there is some n raised to power 1.1 or something, right, series will definitely converge. Okay, so yeah, let's solve this. Let's solve for different combinations. So for the first combination, c is equals to 1, d is equals to minus 1. So c is 1, so 1 raised to power n will be 1 only, and d is minus 1, so this will be 1 by n. So that is the first option, 1 by n. Now will this converge? Never, right? This will never converge. This will be diverging, because if my p is less than or equals to 1, this will diverge. So this will diverge, so this series will not converge, gone. Now when my c is equals to 2, raised to power n, and d is equals to 1, so n raised to power 1, so that is basically n, right? So now I cannot certainly comment, right? I have to use the ratio test. So if I use the ratio test, this will be and okay, don't forget also that your n is tending to infinity, limit as n tends to infinity. Okay, so your n will tend to infinity, so this will be basically next term. What is the next term? It will be n plus 1 upon 2 raised to power n plus 1 divided by n upon 2 raised to power n, and limit as n tends to infinity. So what will happen here is that this will become 2 raised to power n will be cancelled, half will be at the start, and if n is tending to infinity, I will only consider the higher order terms. So this will be 1, so this will be half basically, which is coming out to be less than 1, so definitely the series will converge. So this is absolutely correct. What about the other ones? For the option C, for option C, I see that D is minus 10 and C is 0.5, right? So if C is 0.5, so 0.5 is like, okay, D is minus 10, so this will be 0.5 into raised to the power of n raised to the power of 10. Yeah, n raised to the power of 10. Now will this series converge or diverge? For that again I have to do this ratio test, right? So this will be just give me 1 second. So this will be what? This will be n raised to the power 10, right? Yes, n raised to the power 10. So n plus 1th term, that will be equals to, like, this will be basically, if I rewrite this, will be 2 raised to power n upon n raised to power 10. Okay, that is my term. So how can I solve this? So this will be 2 raised to power n plus 1 upon n plus 1 raised to the power 10, right? And the ratio would be, this will be 2 raised to power n upon n raised to power 10, limit as n tends to infinity. So this will be left out with 2. 2 can come outside, right? 2 can come outside, and if my n is very large, right, I can ignore 1. If n is very large, I can ignore my 1, so which will be basically n raised to power 10 upon n raised to power 10, which is 1. So ultimately this value comes out to be 2, which is greater than 1, so definitely my series will diverge. So series will diverge for this. And for the last one, let's check. Okay, where my c is 1, if c is 1, this will be simply 1, and d is minus 2. If d is minus 2, this will be simply 1 divided by n square, and of course this power is more than 1, so series will definitely diverge. So this will diverge, this combination will diverge. So b, for b and d, the series will definitely diverge. That will be my answer for this question. Let's solve the next one. Again, they have asked from this, and it's not like they're asking you to find out the limit of sum. They're simply asking you when the sum of the series will be, like, when the series will converge or diverge. That's it. They're asking you very simple things. Okay, so here for the first one, again, this is n raised to power 1 by 2, right? where p is less than or equals to 1. So definitely this will definitely diverge. So 1 will diverge. Okay, so 1 will diverge. So again 1 will diverge. What about this one? So this one is not that simple. So we can use that our ratio test. We can take the ratio test. So if I use the ratio test, right, this will be 1 upon n plus 1 into n plus 2, right, divided by n into n plus 1. Sorry, 1 upon n into n plus 1, where limit as n tends to infinity. If I rearrange my terms, this will be n into n plus 1 upon n plus 1 into n plus 2. So what is happening actually here, that if I rewrite these terms, right, this will be n square plus n upon n square plus 3n plus 2. So actually this comes out to be 1. So if this comes out to be 1, this becomes inconclusive. So can I think of anything? So what I can do, I can actually do bit of partial fraction. I can do bit of partial fraction here. So if I do bit of partial fraction, right, this will come out to be when n is 0, this will be 1 upon n, and when n is minus 1, this will be minus 1 upon n plus 1. Yes, if I do partial fraction. So what is happening, this 1 upon n, right, is not converging. I know this 1 upon if n sorry, this 1 upon n also, okay, and this, okay, this will anyways converge, right, this will always converge. Yeah, when n is going from 1 to infinity, this will converge. Yeah, this will converge, no problem. So basically this is always reducing, right? Basically this will be 1 minus 1 by 2, then plus plus what is happening, this is n equals to 2. So n equals to 2 will be 1 by 2 minus 1 by 3, then plus 1 by 3 plus minus 1 by 4. So this is always reducing. So definitely my series will converge. Okay, why? Because all the other terms will be simply cancelled, right? All the other terms will be cancelled, only the sum 1 will be left out. So yeah, this series will converge, this will converge. So 2 will converge. But about 3 also will converge. It is just factorial, right? If you take the ratio test, what will be the ratio test? It will be n plus 1 factorial upon n factorial, correct? What is it equals to? It is equals to n. Am I correct? N plus 1. Yeah, next, sorry, writing it opposite, right? So this will be 1 upon n plus 1 fact. Basically I am writing a n plus 1 divided by a n, right? So 1 upon n plus 1 factorial upon 1 upon n factorial. So this will be equals to simply 1 upon n plus 1. And if my n is tending to infinity, this will tend to 0, right? I forgot to write the limit. So I hope that is understood by you, that everywhere there is n tending to infinity. So if n is tending to infinity, this will tend to 0. Okay, so which is less than 1 according to our ratio test. So definitely this series will converge. So option 2 and 3 will converge. So B, only 2 and 3 converge. So definitely I can definitely say that 1 will not converge, right? Definitely by the P test. But this one I was having bit of confusion. So then I got the partial fraction, because here it was coming out to be inconclusive. Whenever it comes out to be inconclusive, you have to think of something out of the box. Okay, so with that we are done completely with the integral calculus. If you have enjoyed this portion, make sure to hit the like button. Now we will start with the next chapter, that is differential equations. Let's begin with differential equation. So what is a differential equation? Any equation that involves dependent and independent variable with a different derivative, right? That is actually called as differential equation. At least one derivative should be present, like this: dy dx equals plus y equals to x. So I have both. This is the dependent variable, I have the independent variable, and the derivative of the dependent variable with respect to the independent variable. Then this will be called as a differential equation. This also will be called as a differential equation. This will be a higher order differential equation, because I see that the order of the differentiation derivative is more than 2. This is called as a linear differential equation. So we will solve these different kind of differential equation. This is again a higher order differential equation. I have everything, right? I have a single differential, like single order differential, like differentiation, and a higher order, third order. Okay, so these are called as differential equations. Now like the first topic would be to find out the degree and the order of differential equation. So this term, right, dy upon dx, d square y upon dx square, dx upon dt, all these are called as differential coefficient, and only dy or d square y dx, these are called as differential, like differential length, differential time, like that, right? And this is called as differential coefficient. Okay, now there are few things, like there are mainly two kinds of differential equation. One is ordinary differential equation, then there is partial. I hope you can understand from the name why I have more than two independent variable. Like if I have z equals to x plus y, then I can also write dz upon dx equals to 1, dz upon dy equals to 1. Okay, so I can somehow integrate these two equations together. So I can write this equation that dz upon dx plus dy upon dy, so dz upon dy will be equals to 2. So this will be a partial differential equation. Okay, where I have two or more independent variables. If I have only one independent variable like y as a function of x, then all these will be called as ordinary differential equation. So these are all called as ordinary differential equation because x is my independent variable and y is my dependent variable. Now the first thing that we will discuss is order and degree of differential equation. So order is the highest differential appearing in the different equator. What do I mean? An order of a differential equation will always exist. What do I mean by these things? I will explain. So here, what is the highest order differential? This one, right? This, what is the order of this? 1. Here, what is the highest order differential? Again 2. Here, what is the highest order differential? I have two differential coefficients. Out of this, only this one has the highest order differential, that is 3. So order will be 3 over here. Okay. Now, what is degree? Degree is the power of the highest order differential. So here, what is the highest order differential? Which term is the highest order differential? This one. And what is the power of this? 1. So what will be its degree? 1. So the order of this differential equation will be 2 and degree will be 1. So we will take few examples. We will see. Now order will always exist. If I have a proper differential equation, order has to exist, but sometimes the degree may not exist. Okay, when will degree not exist? If I have power raised to the power half of a differential, right, my degree will not be half. Degree will always be in integer. Basically our expression should always be in polynomial format. So if wherever I will have radical meaning like 1 by 2, 1 by 3, those are actually called as radical. Or if I have negative powers, I will always write them in positive powers, positive polynomials. Like I can do one thing. So to convert this, right, what I will do, I will square both sides. I will square both sides. So this will be converted into dy upon dx. So I will properly convert my term. Again, if I have something like this, dy upon dx minus 2, again this is wrong. So what I will do, I will multiply dy upon dx whole square with this, right? So ultimately this will be becoming 0 and the other terms will be there. So I will discuss my degree from that. Now degree for these kind of equations will not exist if inside the sine function I have dy upon dx, if inside the ln function I have dy upon dx, or over the e function I have dy upon dx. So degree for these will not exist. Why? Because you remember, right, what is the expansion of a sine function? It is x minus x cube by 3 factorial plus x raised to power 5 divided by factorial minus and so on. So this will be like, this will have infinite degree. This will be dy upon dx minus, if I expand sine of dy upon dx, this will be dy upon dx minus dy upon dx whole cube into 1 by 3 factorial plus dy upon dx raised to the power 5 into 1 by factorial and so on. Okay, so can I comment about the degree? No, the highest order is 1, but like it is changing, right? It is constantly like increasing. So I cannot comment about a degree. Similarly, if I expand ln of x, it will be also expanded in terms of a series. Similarly, e raised to power dy upon dx also will be expanded like a series. So with that, let's do few examples and let's try to understand degree and order even better. So I have this differential equation here, dy upon dx whole cube minus 2, that is equals to d square y upon dx square. What did I tell you? I will always try to eliminate my radical signs. Here I have a under root, square root, which I will never say. What is the order? Order is definitely done. Order is 2 because the highest order differential coefficient is 2. So order is done 2. But is the degree 1? Can I say the power of this is 1? Is the degree 1? No, degree is not 1. First of all, I have to convert this into my polynomial format. So if I square on both sides, this will be dy upon dx cube minus 2 will be equals to d square y upon dx square whole square. Now I can comment about the degree. Now this is properly converted into my polynomial format. So what is the order? Order is 2, degree is also 2. This is the power. Similarly, here again I will square both sides. So this will be converted. So here also the order, will the order be 2 or do I need to square? So here whatever I have told you, it expression should be in polynomial format for the differential coefficient. Okay, for the differential coefficient, not for the like y upon x. So this can be anything, I don't care, but the differential coefficient should never be inside a radical, right? So here is my differential coefficient inside a radical. No, differential coefficient is simply at the outside, so I don't need to square it, right? So be attentive, be very attentive here, right? Only the differential terms must be in the polynomial format, but y upon x do not need to be in polynomial format. So here the order will be 2, degree will be 1. Okay, just give me 1 second. Yeah, similarly here again this is in a normal polynomial format, but be careful, this is not dy upon dx, this is dx upon dy. So I have to properly rewrite it. So if I write this, right, this will be what? If I assume my any variable s to be dy upon dx, so the other term will be 1 by s. So this will be s minus 3 by s equals to 7. Okay, so now I will properly convert it into polynomial in terms of polynomial in terms of s. So I will multiply by s, this will be s square minus 1 equals to 7s. So s square is what? Dy upon dx whole square minus 3 equals to 7 into dy upon dx. So from here I easily understood that okay, s, like the order of s is 1, obviously highest order differential is 1 and the degree will be 2. So order will be 1, degree will be 2. That will be the answer. Similarly, let's solve this one. Here again I have a exponential term. I have a exponential term. So for this, will the degree exist? Although this is also inside log, right? This is also inside log, this is also inside exponential term. So here what is the order? What I can do is I can take exponential on both sides. So this will be e raised to power whatever I have inside here. This will become d5 upon dx5 plus 1. So with order I don't have any problem. Order will always exist. What is the highest order differential? This one, 5 order. But degree, no, I cannot comment about the degree because this is not in polynomial format in terms of dy upon dx. Okay, similarly here, now what is y2 and y1? y2 is actually called as the second order derivative and y1 is actually called as the first order. So y2 will be simply, I can write here, y2 will be d, like this is a notation, don't worry, and in the exam they will actually tell you this, don't worry, d square y upon dx square and y1 will be dy upon dx. So your y2 and y1 are these. Now if I want to, the powers are not in proper format, right? They are in radical, 5 by 2, 1 by 2, they are not in polynomial format. So what needs to be done? So what I can do is I can okay, what can I do? So can I ever convert this into my proper format? So if I take this 3 on the right hand side and if I square both sides, so if I square both sides, again there will be some if I square, okay, let me solve this. So this will be y2 5 by 2 plus y1 1 by 2 equals to 3. So if I square this, right, this will be y raised to power 5 plus y2 raised to power 5 plus y1 y1 raised to power 1 equals to 9. Okay, so yeah, y1 plus y2 plus 1. So and obviously there is the 2ab term, right? So 2ab term will be there. So plus 2 into y2 5 by 2 into y1 1 by 2. Now is this in proper format? Again, this is still not in my proper format. So how can I convert this into proper format? So what I can do is I can take this on the right hand side, I can take this on the left hand side. So this will become y2 raised to power 5 plus y1 minus 9 equals to 9, sorry, equals to 2 y2 5 by 2 y1 1 by 2. Now if I square both sides, what will happen? If I square both sides, this will be squared and this will be squared, right? So what will happen? This power will be multiplied with all of this. So ultimately 2 will be gone and this will be a integer power. So if I square this, right, what is the, I don't need to solve this, don't solve. Just see what is the power of my highest order term. This is my highest order term. What will be the power? This will become y2 raised to power 5 whole square. So this will be y2 raised to power 10. So this will be my answer basically. This will be my answer. So what is the order? Order is 2, of course. Order will not change. Highest order is 2. Degree is 10. Degree is 10. So this will be the answer for this particular question. So you have to actually solve sometimes. Don't worry, I don't feel they will give you this much amount of highest level, but I am teaching you the maximum level that they can actually ask in GATE examination. So next we have this term dx upon dt d cube x upon dt cube 8, right? How to solve this? Again, this is properly, there is no problem with this, right? This is totally fine. So now one more thing I forgot to tell you is this in minimized format? So there is one more thing, that it should be in minimized format. Okay, here it is not there. Your expression should be in minimized format. This is not in the minimized format. Okay, because you will assume that your order is 3 and your degree is 8, but that is actually not correct. Can I minimize it further? If I raise both sides to the power of 1 by 4, so this will be dx dt to the power of 1 equals to d cube x dt cube to the power of 8 by 4, that will be 2. So I have raised both sides to the power of 1 by 4. So basically your expression must be in minimized format. Okay, like it is similar to saying something like this, that I have x raised to power 8 minus equals to x raised to power 4, right? But actually your equation was this, x raised to power 4 equals to 1. This was your equation, correct? But what I did, I multiplied by x raised to power 4 on both sides. So this become x raised to power 8 equals to x raised to power 4. So I am unnecessarily including more solutions. I only have actually 4 solutions, right? So you have to minimize your differential equation. These things you have to keep in mind. So I am taking all the edge cases where you might feel you are wrong. Again, what about this one? So what will be the order and degree? Order will be 1. Okay, order will be 1 and degree will be 1, but the next term will be counted wrong. Here your order and degree will not be 1. So here, one more thing I forgot to add, that including the differential terms, your y term also should not be present with a radical, your y. So whichever one is the dependent term, y as a function of x, that also should not be present with a radical. I forgot to tell you at the starting. Okay, this also should be with polynomial format. So here if I see that I have under root of y, so if I take this under root of y on that side, on the other side, this will be dy upon dx equals to minus under root of y. I will square it, so this will be dy upon dx equals to y whole square, right? This will be whole square. So this is my y. So finally this will, what is the order is 1, degree is 2. So what will happen, like you will never be confused with order, you will always solve the order correctly. Okay, the problem will lie in degree. So I have taken all the possible cases where you might go wrong. So two things you need to keep in mind. First of all, your differential terms and your y, I forgot to tell you about the y also should be in proper polynomial format. Okay, first point. Next point is basically you should not have radical signs, you should not have excess power. This excess power was here, right? You have seen excess power was here. They should not be in excess power. There should not be negative powers like it was here, dx upon dy. So it was the negative of this, right? Negative power. So they should not be in negative power. Okay. Expression should be in polynomial, both the differential terms and the y value. Okay, y term, whichever one is the dependent term. So also degree may or may not exist. When does it not exist? I have already discussed when it does not exist. Okay, now how to form a DE. So generally they will not ask you, but okay, this can be also asked. Like basically you have to form a DE. How can I form a DE? Forming a DE basically means if I have this equation, right, dy upon dx equal to 2x. So what kind of graphs does this equation represent? So if I solve this, I will integrate, this will become y equals to x square plus c. Don't forget the constant, right? Don't forget the constant, because whenever you are doing indefinite integration, there has to be c. So basically when c is 0, I will get directly a curve, that will be y equals to x square. When c is 1, it will be shifted upwards. C is 2, more upwards. If c is minus 1, downwards. C is minus 2, more downwards. So what will happen? I will get a family of curves. What kind of family? This is a family of quadratic curves. This is a family of y equals to x square parabola curves. So differential equation, the solution of a differential equation gives me a family of equations because I have a constant. Now if it's a first order differential equation, I will only have a single constant. If it's a second order differential equation, I will have two constants. Why? Let's take this example, d square y upon dx square equals to 1. So if I integrate this, what will I get with respect to x? If I integrate this once, I will get dy upon dx equals to x plus c. If I integrate it again, this will be d square y upon dx square equals to x square by 2 plus, now this is just a constant. If I integrate a constant, what do I get? C into x. So this will be c into x plus another constant will be there due to this integration. Sorry, this will not, sorry, I'm integrating, right? So this will be y. Another constant, let me write that constant, let me write this as c1, other constant will be c2. So depending on the order of the differential equation, that will give me how many independent constants I will get. So these are independent constants, they will not depend on each other. Now these constants can be found out with the help of initial conditions. Okay, so let's take a very basic example. I have been given, I have to find the differential equation of straight line passing through origin with slope m. So if I have a straight line, right, and slope is m. For a straight line, the slope is always constant. And what is slope? Slope is dy upon dx. So my slope is dy upon dx, which is equals to m, which is always constant, right, for a straight line. So now if I integrate this, right, what will I get? So they are asking me which DE of the family of straight line, which one represents DE of a family of straight lines. So I see, yes, this one is matching definitely, that this will be one of the differential equation whose slope will be m, and this will match. Is there any other possibility? So as you can see, option C is also correct. How am I getting option C? So if I integrate this equation, right, this will be y equals to mx plus c, constant of integration, and they are telling me that it passes through the origin. If it passes through the origin, that means it has to pass through the 0 comma 0 point. So y will be equals to 0, x will be equals to 0, so your c will be equals to also 0. Okay, c also will be equals to 0. Okay, so yeah, that's how you can solve this basically. That's how you can solve this, that your c is 0. So you get equation that my y upon x equals to m. So I can replace my m, right, in terms of y and x. That is also another advantage. So this is also a valid differential equation for this particular condition. If my straight line passes through the origin, this will be a valid differential equation. dy upon dx will be equals to y upon x. Okay, so this is a valid solution. So there are many ways to solve differential equation, right? So we will see each of them one by one, and don't worry, I will try to summarize every single thing, right? Because there will be multiple methods, but no need to memorize the method. Just do question practice. You will understand when to use what kind of method. First one is linear differential equation, then higher order differential equation, and both higher order and higher degree. This one we will not solve. Okay, we will only learn these two. So let's take an example like this one, right? This one we have already know how to solve. Like if I have dy upon dx, y upon x, we can simply integrate on both sides. We'll be able to find out the solution. There will be a constant c1 into x. Okay, and that constant value we can find it out. Okay, this differential equation we know it already passes through the origin, so there will not be another constant, only this will be there. Okay, now let's solve this equation. We have been given this differential equation determines the family of circle with fixed radius, variable radius, fixed center. So how do I solve this? So this is in the variable separable format. This is much easier for us to solve. We can individually solve dy and dx. So what I can do, I can take this y on one side and x on one side. So this will be my y dy upon under root of 1 minus y square equals to dx. So now if I integrate on both sides, this will become, now how do I integrate the left hand side? So I can assume, like as I have assumed here, some t variable that is equals to 1 minus y square, dt will be minus dt by 2. So you will replace your dy, you will replace your y dy with minus dt by 2, and this will be your under root 1 by 2, sorry, under root t. So you will solve this, you will get the solution to be this one. Okay, so here I get the solution to be this, whose center is minus c comma 0 and radius is fixed. Radius is 1, but center can be anything. So center is variable depending on the constant, and constant can be any value. So the radius is fixed and the center varies. Now where does it vary? I see the center of the circle, y coordinate is fixed. Y coordinate is always equals to 0. So I hope you know how to write the equation of a circle, right? So y coordinate is fixed, y minus 0 whole square. Y coordinate is fixed, only the x coordinate varies. So that's why you see the x coordinate is varying. Center, like center fixed radius with variable center along x coordinate, because the center is varying along the x coordinate, y equals to 0. Center, for center y is 0, y coordinate is 0. Okay, so this is how I represent a family of straight lines. Now the next method would be to use basic substitution, because here I cannot separate out my x and y to integrate them differently. So what I will do, I will do x plus y equals to t, and then I will do dt upon dx and then solve. Okay, you can solve it. So like these are easy things, so I know you will be able to solve it. Okay, like this is not that difficult, right? So you will assume your t is equals to x plus y, then you will do the differentiation and you will write your dt in terms of dx upon dt. So I can do this for you. So we will assume t equals to x plus y. So what will be my dt upon dx? So dt upon dx will be equals to 1 plus dy upon dx, because remember y is a function of x, so I cannot simply make this equal to 0. So from here I get the value that dy upon dx will be equals to dt upon dx minus 1. From here I can replace my dy upon dx with dt upon dx, right? So this dy upon dx will be replaced with dt upon dx minus 1. Why am I doing it? To make it variable separable. The purpose of it is to make simply it variable separable. So the right hand side will be cos of x plus y, and cos of x plus y is simply t. So now I can make it easily variable separable. So this will come out to be dt upon cos t plus 1 integration, and on the right hand side I will have dx, right? So the integration of 1 plus cos t, it will come out to be like tan of x plus t by 2. If you don't remember this, don't worry, still you can solve it. What you will do, you will simply multiply by what you can do is you can multiply by cos t on both sides. Let me multiply by cos t on both sides, dt upon cos square t plus 1. Okay, so if it is dt upon cos square t upon plus 1, so then what I can do, I know that cos square t plus sin square t is 1. So what is cos square t? Cos square t is 1 minus sin square t, but that will not be helpful to me, right? Okay, cos square t plus sin square t equals to 1. Yeah, let me change this into sin square t, that will be helpful. So cos square t plus sin square t equals to 1. So this will be converted into cos t into dt upon so 1 minus sin square t. So this will be 2 minus sin square t. Now I can replace my sin t as some another variable, let's say m or any like v. Okay, so what will be my dv upon dt? So dv will be equals to cos of t dt, right? So this will be dv upon 2 minus v square, correct, because sin t is v. Now what I can do, I can use the partial can I use the partial differentiation here? Yes, I can use the partial fractions, right? So this will be dv upon under root of 2 plus v into under root of 2 minus v. So when v is equals to minus under root of 2, so this will be minus, so this will be 1 by 2 root 2, right, into 1 by root 2 plus v. Okay, and minus, this will be just the negative sign, right? Yeah, this will be negative, minus 1 by root 2 plus v. So now I hope you can solve it. So like I'm just solving it in rough, you guys can do it quickly, much quickly, right? So what will be the solution here? The solution, this will be this one, 1 by 2 root 2 will be at the outside. This will be ln of v plus mod of v plus root 2, then minus of this, right? So this will be divided by, so this will be minus, right? This can be kept like this. Okay, this is anyways mod, so it will not matter. V minus root 2, and from there you can further derive like what will be your v. V will be your sin t, and what is your sin t? Sin t is x plus y. From that you can get to this equation. But I hope you get the idea how can you solve these equations. Okay, how to use the substitution. So there are two ways. If your differential equation is variable separable, then that is the most easiest way to solve. So you don't need to think. If your equation is variable separable, simply solve the differential equation. No need to think anything. If it is not variable separable, your second way to solve it will be to think of a substitution. So here I am saying I can assume x plus y equals to t or any substitution, right? So that will be my second line of defense. If your second line of defense also fails, now your third line of defense will come. If your equation is homogeneous. Homogeneous, I hope you remember what does homogeneous means. All the terms should have same power. Here what is the power? Degree 3. What is the degree? 3. What is the degree? 3. What is the degree? 3. That has been taught to you in partial fractions. If it is homogeneous, then also your work is almost done, right? Then also your work is done. So first of all, I will rewrite this equation properly. So if I rewrite my equation properly, this will be dy upon dx this will be equals to y cube minus 2 x square y, sorry, yeah, y cube minus 2x square y. This will be with a negative sign I can take inside, x cube minus 2x y square. Okay, if it is homogeneous, right, of degree 3, so I can take that power common. You take that power common, okay, or you don't even need to take that power common. What you can think, okay, you take that power common. If I take that power common, right, that degree 3, so from the top, what can I take common? I will take power as common as x cube. Always try to take the power x cube common. Whatever you feel like, you can take that common, no problem with that. Here I will take it common as x cube. If I take x cube common, right, from the top, this will be y by x whole cube minus 2 into y by x. Again, if I take x cube common from the bottom, this will be 2 into y by x whole square. So x cube will be cancelled. So this will be left out with y by x upon, so this automatically gets converted into a function of y by x. So now I will use my substitution. So I will use my substitution to make it variable separable. So ultimately our aim is to go to variable separable, right? So what I will do, I will take a substitution. So y upon x equals to t, right? So from here I can replace my, I can write my dy upon dx. So I can take my x on the other side. So this will be dy upon dx. I can take the t on the other side. This will be t plus dt upon dx. Okay, so I can make this substitution. So what I will do, I will replace my dy upon dx to t plus dt upon dx, and this will be t cube minus 2t upon 1 minus 2t square. So now I hope you will be able to solve it. So this will be like, if I take this t on the other side, this will be dt upon dx will be equals to t cube minus 2t minus t plus 2t square divided by 1 minus 2t. Okay, so now if I solve this, this will be gone, right, and this will be t cube minus t cube minus t upon 1 minus 2t, and here I have dt upon dx. So this is simply in the variable separable format. So I can simply solve this. So if I solve this, this 1 minus 2t upon t cube minus, so what I can do, I can take the t common. This will be t square minus 1. I can write it as t plus 1 t minus 1, okay, dt integration is equals to dx. Now this, right, you can use partial fractions to further break it down, then you will be able to solve it. I'm not solving it completely. Here the solution is there already. Here instead of t I have v, instead of t I have v. Okay, that's it. So you can solve it. Ultimately your equation will come out to be this. Only you will have single constant, because up until now whatever we are solving, these are all first order equations. Okay, now sometimes what happens, they give you dx upon dy. Okay, like these things you can do, right? Here like both will work. Actually this is just a separate format, but both will work, both will totally work. Here they are telling that if dx upon dy is there, right, then you make this substitution. You don't have to remember anything, no. Okay, it is homogeneous, so I can do anything. So what I will do, just write your y by x, like, because it is a homogeneous equation of order degree 2, so I can take my x common from both sides and I can write y by x equals to t, and then you can simply solve this equation. Okay, so let me solve using our normal format. So this will be what? If my y by x equals to t, y by x equals to t, your dy by dx will be, so yeah, t plus dx. Like how am I doing this? Y is equals to t into x. So I will use the chain rule and differentiate with respect to x on both sides. So this will be dy upon dx, t plus dx, sorry, uh, t plus dt upon dx. So I will change my equation. Now here, right, they have given me some initial conditions. Like this initial condition is given. If initial condition is given, that means you will be able to find out the value of that independent constant. So we will see. So this will be x into y, x into y. So x into y will be, here if I solve, so dy upon dx, t plus dt upon dx. Okay, so this will be t plus dt upon dx equals to x into y, x into y. So if I take x square common, this will be simply y by x, that is t. This will be 1 plus t square. So I have just taken my x by y common. So if I take this t on the other side, this will be dt upon dx equals to t minus t cube upon 1 plus t square. So this will be like I have to integrate 1 plus, so minus sign can be there, 1 by, so 1 plus t square upon t cube dt equals to minus of dx, correct? So this will be basically 1 by t cube plus 1 by t integration of dt. This I hope you can solve it, and on the other side it will be minus x plus c. So if I solve it, right, if I solve this, this will be minus of 1 by 2t square and ln plus ln of t equals to minus of x plus c. Okay, now what you will do is you will put your value of t, you will put back your value of t. So what was my t? T was equals to y by x. So if I rewrite my equation, this will be x by y whole square minus 1 by 2 plus ln of y by x equals to minus of x plus c. Okay, this is my equation basically. Now I will put the values. I will put y equals to, like when x is 1, y is 1, correct? That is what it means. Like this basically means that y at x equal to 1. So when x is 1, y is 1, so this will be 1 by 1, that is minus 1 by 2, right? And this will be also ln of 1, that is 0 plus 0 equals to minus 1 plus c. So your c comes out to be half. So my equation is, how, I don't have space. Okay, so let me take few stuff. Let me take, so my equation will be, finally my equation will be so this will be minus of 1 by x by y whole square plus ln of y by x equals to minus x plus 1 by 2. Now what they're telling me, that at some value of x equal to a, the y value is e. So y value is e at some value a, right? So okay, how will I solve this? So this will come out to be minus 1 by 2 a by e whole square plus ln of e by a equals to minus of a plus half. Okay. Now how will I solve this equation? So yeah, one small mistake I had made here. Actually previously also did I, okay. Sorry about that. That's why you should not do in a hurry. I made a very small mistake, right? So my y equals to x into t, correct? So if I do dy upon dx, that's why you should never be in a hurry. So if I apply the chain rule, this will be t plus x into dt upon dx. That was a very big mistake. I know you guys were screaming at me in the comments. So here this will be x. There will be a x term over here. So this will be x. So here in the bottom, right, this will be with x. So this will be dx upon x. So yeah, I was wrong. I'm extremely sorry. So here ln of x will be there. Okay, just one mistake. Here also this will be with x. So if I have x over here, this will be x, right? This will be x. So this will be x. So this will be dx upon x. So this will not be minus of x. This will be minus of ln of x plus c. I'm extremely sorry for the mistake. So this will be minus of ln of x. Now what will be the value of c? So if I put my y equals to like x equal to y and x, this will be ln of x minus of ln of x plus c. Now if I put my x and y equals to 1, so this will be 0, this will be 0. So ultimately your c will be equal to simply minus of half. So your c will be minus of half. C will come out to be minus of half. I'm extremely sorry about that. Minus of half. Now if your c is minus of half, now you put your x value. So x equals to a. Now if I put my x value, so this will be ln of a. So this, not this one, this will be ln of a. Wait a second, let me check whether I'm doing this correctly or not. So yeah, this is 1, right? This will be 0, this will be gone. This will be, yeah, this will be minus of half. This also will be gone. Yes, that is correct. C is equals to half. Yes, c equals to half. So c is equals to minus of half. Now if I put my x equal to a, so I get this equation. So if this one will go on the right hand side, this will be simply ln of e by a plus ln of a. So ln of a into ln of b. So ln of a into b, right? If I have two logs in addition, I can multiply the two logs. I can multiply the inside elements. So this will be ln of e, and ln of e is nothing but 1. So this will be converted into 1. So this will be minus half upon a upon e square equals to 1 will go on that side, right? 1 will go on that side. That will become minus of 1. So this will be minus of 3 by 2. Okay, I hope you can solve. Like this is what? This is nothing but ln of e minus ln of a, and ln of a is both on the left hand side and on the right hand side. I can cancel it. So this will be only ln of e, and ln of e is simply 1. Natural logarithm of e is 1. So this 1 can go on the right hand side. So this will become minus 3 by 2. So negative sign will be cancelled. So from here 2 also will be cancelled. From here my a will be simply root 3 into e. That will be the value of a. A will be root 3 into e, and you can obviously find out root 3 times e. So that's how you solve these equations. That's why you should never be in a hurry. Okay, never be in a hurry. Be very careful. Okay, like I'm just teaching you. That's why I'm in a hurry, because I have to teach multiple concepts. But in exam, obviously, don't do this. Write everything properly. Okay, but I also should actually write everything properly. That is my mistake. So whenever you try to do something in a fast manner, you see that you will make some mistake. So that's how you solve. Now there is like another thing, when I have constants here. If I have constants here, right, then how can I solve it? How can I make it variable separable? So if you have constants, what you can do is you can convert it back into variable separable. How? I don't want my constants. These constants are a pain to me. These constants, although you will say that now this was homogeneous equation, that is done. Now if I have equation like ax plus by plus c1, ax2 plus by plus c2, right, and these are different. So I would have been easily able to solve it. This would have been an homogeneous equation of degree 1 if the C1 and C2 were not present. So I don't like my C1 and C2. So I have to anyhow eliminate my C1 and C2. So how can I eliminate? So let us take an example. So here I have dy upon dx, that is equals to minus of, hold on a second, 2y plus x minus 3 upon 2x plus y minus 3. Now what you do is, I don't like these constants, so I have to anyhow remove this constant. So let me do some substitutions. So I can substitute my equation. I can write capital X, that will be some x plus h, and capital Y, that will be some y plus k, and k and h are all constants. So my differential coefficients are all same. Okay, so my what will be my dx? Dx will be same as small dx, because remember your h is just a constant, and your dy is also same as small dy. Okay, so your differential coefficients are same. I will find out some substitution so that I can make it 0. So I will replace my, so what I will replace my x. What will be my x? My x will be capital X minus h. My y will be my small y will be capital Y minus k. So if I replace it right here, so this will be 2 into capital Y minus k plus capital X minus h minus 3 divided by 2 into capital X minus h plus capital Y minus k minus, sorry, this will be plus, right, I guess. Hold on a second. This will be minus 3. Oh, this will be also minus 3. That is interesting. Oh, okay. This will be also minus 3. Okay. So both are minus 3 now. So if I solve this, right, if I rewrite this, this will be 2 capital Y minus 2k. I can write the constant separately, capital X minus 2k minus h minus 3 divided by 2 capital X plus y, capital Y minus 2h minus 2h minus 3. Okay, so yeah, this will be now what do I need to do? Just make the constant 0, that's it. Then this will be converted into a simple homogeneous format. So that is my purpose. Don't remember anything. Your purpose is to simply convert this into homogeneous format. That is your target. So don't forget your target. So basically what equation I get? So I have to somehow make the combination 2k plus h equals to 3, also 2h minus k equals to 3. So what kind of solutions I am getting? What is the, if I properly format my equations, right, this will be 2k plus h and this will be k plus 2h equals to 3. So what is the rank of this matrix? I see rank of my coefficient matrix, right, is 2. The determinant is non-zero, correct? So of course I will get a unique solution. So if I subtract these two equations, right, I will get the solution, that is k equals to h equals to 1. So I will simply put the k equals to h equals to 1. So what will happen? The equation will be converted into 2 capital Y plus x upon 2x plus y. And then this, the left hand side will be, remember your dy upon dx will be converted into capital dy upon dx, because your small dy upon small dx is capital dy upon dx. At the end of the substitution, I will finally revert to my small x and small y. So now I will solve this equation, right? Now it will be a homogeneous equation. Now again you have to use the property of homogeneous equation. What? I will take my x common, right? So this will be 2 into capital Y upon x upon 2 into 2 plus capital Y upon x, and then again you will assume your y upon x to be some variable t and then solve. Don't worry, I'm not expecting they will ask this much, right? So but you have to go through steps. First you have to eliminate the constant, then you will solve, and this method is applicable only for linear equations where you are getting solutions. If you are not getting any solution, when there is no solution, you will not be able to solve it. But mostly if they are asking you, you will get some solution, and I am not expecting that they will ask you from this particular type 3. They will mostly ask from this homogeneous equation. Okay, so I hope you have understood. You don't need to remember it. Just what do you need to remember? Simplify. How can I simplify my differential equation? That's it. Now there is another way to simplify. If your differential equation is exact, then you can very easily use some special method to solve it. There is a special formula to solve an exact differential equation. What do I mean by exact? If I can break my differential equation into a format m dx plus n dy. Okay, so here I have dx dy, here also I have dx dy. So let me first put all the dx terms together and dy terms together. So this will be x square plus y square, and y is also there, so y cube, this is dx plus this will be x square plus y square x into dy. Okay, that is y dx minus x dy. Now this is a special format actually. If I multiply and divide by y square, right, if I multiply and divide by y square, this will come out to be a very special format. So this is simply d of x upon y. How? So it is just the quotient rule. If I am differentiating x upon y, what will it come? It will be basically chain rule. The denominator will be squared, then I will differentiate the numerator and keep the denominator constant, and then I will subtract I will differentiate the I will keep the numerator constant and differentiate the denominator. So this will be x dy. Okay, so y dx minus x dy upon y square. So that will be the like solution. Now yeah, that is what I will do. So we will convert. So here the same thing I am doing. I am converting this part to d of x upon y, and this I am keeping 1 by x plus y, I am keeping here. Okay, and this, right, this part is simply d into x into y. How? So it is nothing but the chain rule. So it will be again keeping x as constant, differentiating y, plus keeping y as constant, differentiating x. So now I can simply integrate the small differentials, right? This is simply dt. If I assume t to be x by y, dt upon 1 plus t square, which is nothing but tan inverse of x. So that's how simple the solution becomes. So this becomes simply, this side becomes simply xy, this one becomes tan inverse of x upon y. So that's how easy you can solve using this method. So there are many ways. Either you check for exactness or you understand these differentials and convert your equation into these formats. Okay, these are few standard formats, important exact differentials that you can remember. These are not that difficult for you to remember because you can always prove them. It will not take you much time to prove because simply what you are doing, you are just simply differentiating. Okay, so let's solve here. We have this equation. So we can solve this equation with my differential constant. So either you have to find out this format or you will use this method. I will tell you what method you have to use. So here first of all I see my equation is homogeneous. If it is homogeneous, right, I can solve it using normal method as well. The equation is homogeneous, I can solve it using my normal method, right, whatever I have taught you. So no problem, you will be able to solve it. So you don't need to stress that whether I have to remember another thing. No, this equation is homogeneous, I can solve it. Already I have told you how to solve homogeneous equations, but I am telling you another method. So let me first write this separately, right? Let me write x cube dx, that is simply solvable, right? Xy square dx. Now here I have y, that is difficult. this will be x square y dy plus y cube dy. So these terms are easily solvable. Only this one and this one are these terms are easily these terms are easily solvable. Only this one and this one are my problem making terms. So what I can do, this is equals to 0, right? So this will be I can solve this one and this one, that is very easily solvable. But here what can I do? Can I do something here? So I can, like this, right? I feel this is something related, like this is x square y into dy. When does y into dy comes? If I have y square, if I differentiate this, right, this will be 2 into y into dy. So somehow if I can make here so if I can multiply and divide by 2, right, this term will be coming, right? I need 2y. In this term I need 2y, then this will be proper, like 2y into dy will be proper. And I know here I have x square, here I have y square. So this, right, I can easily write like this. This will be d of x square y square multiply and divide by 2, dy of x square upon y square, the 2 is already inside, this will be divided by 2. How? So this will be equals to, if I differentiate this, right, this will be chain rule, this will be 2x into 2x into dx into y square divided by 2 is there, plus I can apply the chain rule, 2y into dy into x square upon 2. So this will come out to be x y square dx plus y x square dy, the same equation, right, that I have derived here. So yeah, you will say, sir, how will I know this? How will I do this? No, don't worry. I will tell you the method too. You don't need to understand whether you don't need to find a format. Don't worry. I will tell you the other method as well. I'm just showing you how can you solve using multiple methods. So this, right, this can be converted as d of x square y square divided by 2. And now I can simply integrate the whole equation, because it has been converted in terms of a single variables, which I can simply integrate. Okay, so this will be x raised to power 4 upon 4 plus x square y square plus y raised to power 4 upon 4, and of course I will have the constant of integration there. So this will be the solution of my differential equation. Okay, now if you want to solve it using method 2, method 2 would be, first you check whether my equation is exact or not. How can you check? So you will differentiate. So here I have dx, so I will partially differentiate with respect to y. So if I partially differentiate with respect to y, this will be 2xy, and here also I have dy. If I partially differentiate this with respect to x, right, this will be 2xy again. So which is equal? If it is equal, you can simply integrate. How? So there are two ways to integrate. Trust me, you don't need to remember anything. Just what you need to do, first of all, write your differential equation in this format. Then if I have dx here, I will partially differentiate with respect to y, so that you don't need to remember. Here if I have dy, you will partially differentiate with respect to x. You will check those terms. If those are coming out to be equal, now next step will come. Next step is, I will rewrite my equation. What is my equation? I have x cube plus xy square into dx plus this will be x square y plus y cube into dy. Okay, this is equals to 0. So there are two ways. First one is, you can integrate directly this equation assuming my y to be constant. you can integrate this equation assuming my y to be constant. Okay, y is constant, you can assume y to be constant, and directly I can integrate this equation. So what I will do, I'll copy this, right? I'll copy this and paste this. So this is sorted. Now how will I integrate this one? I will integrate this one because again there are x terms. I will simply exclude my x terms. So terms excluding x, right? X will be excluded wherever x is present. So this will be gone. Only this term I will integrate. So that will be my solution. And on the right hand side, if I integrate 0, I will get a constant. That's it. So this will be x cube x raised to power 4 upon 4 plus x square y square upon 2 plus I will exclude the terms wherever I have my x term, right? I will only include y terms. So this will be y raised to power 4 upon 4 equals to constant of integration, which is same as this equation. Now you will say, sir, how will I remember this thing? What if I forget that I have to keep y constant? No worries. The beauty of this method is you don't need to remember a thing. So you can use other step. What is the other step? You can keep x as constant and exclude y terms. So if I integrate this equation, right? Again, if I integrate this equation, what will I do is this time, if I have dx, let's say I have forgotten what do I need to keep constant, x or y. So you will say, sir, I will keep my x constant. I don't remember. So if you are keeping x constant, that means you are differentiating with respect to y. That's why you are keeping x constant, because if you are keeping your x constant, that means you are integrating with respect to y. That's why you want to keep your x constant, because integrating this one will be difficult for you. If it was only y, it was simpler for me. So if I am keeping my x constant, right? So definitely on this integration, I will keep my x constant. Like that is understood, right? That is understood. So okay, I have to keep either one of them constant, x or y constant. Next, as soon as I will keep this one constant, again I have a problem here, right? I cannot simply integrate here because I have y. So I remember that I have to keep one of the terms constant and I have to ignore the other term. So if I am keeping x constant, I will ignore the y term. So now again if I integrate, right, this will be x raised to power 4 by 4 plus this will be x square y square by 2 plus y raised to power 4 by 4 equals to c. So that's the beauty. You don't need to remember anything. Just you need to keep in mind that okay, I have to keep one of the terms constant and ignore the other one. If your differential equation is exact, this method will simply work. Okay, so you don't need to remember a single thing. Okay, you don't need to remember a single thing, right? So that's the beauty of this method. I hope you have understood the basic thing. So if you are enjoying this method, right, because I know you have studied this from somewhere else, and there you remember that I have to remember what is my m, what is my n. Okay, all these things you have to remember, because we used to convert this in some m and n format, and then we used to check the exact method, right? But I have told you a method in which you don't have to remember a single thing. So if you are enjoying, please hit the comment, like tell me in the comment below how are you enjoying, and obviously hit the like button. Okay, so yeah, now until now we have solved how to solve using how to solve my differential equations, right? First order differential equation. Now there is some other method as well to solve linear order differential equation. There are some other methods as well. Like what do I mean by linear? So linear basically means the differential coefficient and the dependent term all must be linear, that is their power must be 1. Okay, then only that will be a linear differential equation. And if I have a linear differential equation, then there is a certain method with which we can simply solve it. So here I see y is my independent variable, y, the power of y is 1 and the power of dy upon dx is also 1. Here again I see now my x is a dependent variable on t because I am differentiating with respect to t. So my x is a dependent variable and t is a independent variable, correct? So again this is a linear differential equation because the power of this differential coefficient is 1. Here also the power of the dependent variable, that is x, again it is 1. Okay, so these things you have to keep in mind. Like we can also check which ones are linear or which ones are not linear. Is this a linear differential equation? This, right, I can divide by y on both sides, then this will be converted into a linear differential equation. So make sure you are simplifying the terms. So in the second equation, I also forgot to tell one more thing, that first of all you have to, like, how to find out the whether it is a linear differential equation. You have to find out the dependent variable. Okay, that is the first thing. Your differential coefficient must have a single degree, though the order might be anything. So I can have second order differential equation, first order, third order, anything. Product term of dependent variable and the differential coefficients are not allowed. Like this is not allowed, right? Y into that dependent variable and the differential coefficient are not allowed. But here, as I can divide by y on both sides, so that is minimized. So that then it becomes linear. Here it seems like it is non-linear, but here it becomes linear. Here again, what is the degree of all the differential coefficients? 1. What is the degree of my dependent variable? 1. So this will be a linear differential equation. Here, what is my dependent variable? So I am differentiating my x with respect to y. So my y is a independent variable, x is a dependent variable. But here I see the power of x, right, is not 1. X is a dependent variable and the power of x is not 1. So definitely it will not be a linear differential equation. Similarly here, again, x is a dependent variable, power is 2 here. Again, my x will not be a linear differential equation. Here my y is a dependent variable and I see that power of y is 1 and differential coefficients are also power of 1, no problem. Here my x is a differential dependent variable. I see there is a product of my dependent variable and the differential coefficient. Again, not a linear differential equation. So if you have a linear differential equation of first order, right, then there is a simple method to solve it. So this, I think you have already studied it. So we convert this, right? There is a proof. I'm not going into the proof. The simple method is, you will find out the integrating factor of this differential equation and the then you will solve it. How to solve it? So your solution will be this. So let's check this differential equation. Is this linear? First you will check what is my dependent variable, y. Is this differential equation linear? Yes, because this is some term, right, that is independent. This is linear, this is linear. So first of all, the standard format for your differential equation for a first order is your coefficient of dy upon dx always should be 1. So I will make the coefficient of dy upon dx to be 1. That is the main task. So this will be, I will divide by cos square x on both sides. This will be dy upon dx plus sec square x y equals to sec square x tan x. Okay, now I will find out my integrating factor. What is the integrating factor? I know you have studied this, so like this will not be like nothing new. That will be e raised to power p dx. What is p? P is the coefficient of y. P is the coefficient of y. So it will be e raised to power sec square x dx. Now what is the integration of sec square x? It is tan x. So it will be e raised to power tan x. That will be my integrating factor. Now what will be the solution? Your solution will be y into integrating factor equals to integration of the q of s, whatever is on the right hand side, this term into the integrating, this term in a standard format, this term into the integrating factor. So this will be, yes, integration of sec square x is, yeah, tan x. Yes, am I correct? Yes. So what I can do is, I can multiply by the integrating factor. So this will be sec square x tan x into e raised to power tan x. Now this seems a bit difficult to solve, right? And this will be e raised to power tan x. Okay, I will write the constant at the end. So what I can do is, I know I can assume a substitution. So what I can do is, I can assume tan x to be equals to my t. So what will be dt? Dt will be sec square x, okay, dx. So I can totally replace this part with t, with dt, and this part can be replaced your e. So this will be simply e raised to power t. This will be t into e raised to power t dt. Okay, Now I hope you can solve it using your DI method. So if I assume a DI method, right? So D is t and I is exponential e raised to power t. So this will be 1, this will be e raised to power t, this will be 0, this will be e raised to power t. So this will be t into e raised to power t, this will be 1 into e raised to power t plus minus t into e raised to power t minus e raised to power t. Okay, and yeah, that is the answer basically for this one. So it will be y, t is tan x, right? So y into e raised to power tan x equals to tan x. So e raised to power t I can take common, right? E raised to power tan x into t minus 1, and at the end I will put the c at the end. So after I cancel these things, right, this will be t minus 1 plus c, but t is simply tan x. So I can replace my t as tan x. So your solution will be y equals to tan x minus 1 plus c. That is your solution. Okay. So yeah, that's how simple your solution becomes. That's how simple your solution becomes. So that is the key factor here, that yes, we can solve it. We can, again, this is not a simple homogeneous equation, right? But is this in variable separable format? This is, can I do it? No, this is not even in variable separable format. So you don't have variable separable format and you don't have this homogeneous. So then you have to go by this linear solving of linear differential equation. Okay, that will be the solution here. This is the answer. Okay, so write the constant at the end because that will be easier for you, because we know we are integrating, we will get some constant, but I am putting the constant at the end. That's it, after doing all this simplification. Okay, so that's how you do. Now there is another format. If you had dx upon dy, if you have dx upon dy, then obviously your integrating factor will not be a function of x, it will be function of y, because y will be your independent variable. Okay, so here we have this equation. Like I will solve this using my dy upon dx upon dy and not dy upon dx. So with both you will get the same answer, right? Let me solve this. So first of all, let me write this in proper format. I see this is not homogeneous, right? This is not homogeneous. And is it variable separable? It is not variable separable, right? Because yeah, here I will have, with the dy I will have these things. This is definitely not variable separable. Is this exact, right? Exact differential equation. So if I partially differentiate this, right, with respect to x, this will be 2. If I partially differentiate this with respect to y, this will be 1. So 2 is not equal to 1. So this is definitely not my exact differential equation. So I cannot use my that formula for exact differential equation. So I have to use linear method of linear differential equation. So I will first of all convert this into my standard format. So your standard format is this: dy upon dx plus p into x plus q of x, right? But let me solve using bit of variation. So let me solve dx upon dy. So if I do dx upon dy, first of all I will divide by dy on both sides. So this will be dx upon dy, and of course the coefficient of the differential coefficient must be 1. So I will divide by y as well. So this will be, if I divide by y, this will be 2 x upon y minus 10 y square equals to plus, sorry, yeah, y square plus, this will be dx upon dy equals to 0. Okay, so yeah, now this, is this still in proper linear differential equation format? No. Okay, one more thing is there. Actually we will not be able to solve this using dy upon dx. Why? Because if I use dy upon dx, right, I see y is not linear. So this equation, actually this differential equation is not linear in terms of y. This differential equation is linear in terms of x. So yeah, one more thing was there. You will never be able to solve this using dy upon dx. So you have to solve it using dx upon dy. Everything will be same, nothing will be different here. So your dx upon dy will be dx upon dy plus 2 into x upon y equals to 10 y square. So this is in my standard format where my p, what is the p? P is this 2 upon y, right? Where x is my, now I will assume my x to be my independent, x to be my dependent variable, okay, because this is a linear differential equation in terms of x. So your dx upon dy is, so I can solve it. So what is my integrating factor? Integrating factor will be e raised to power p, this time this will not be x, this will be dy, right, because y is my independent variable. So this will be ln of y, ln of y square, so this will be y square basically. So y square will be your integrating factor. I will multiply, so x into my integrating factor, that is y square, equals to, on the right hand side I will have the q term, that is this function 10 y square into the integrating factor, that is y square dy. So this will be converted into x y square equals to 10 . Okay, one more thing, I forgot to tell you that if you are here, right, actually don't put the constant at the end. Once you are doing this integration, right, here only you put the constant. I forgot to tell you, here only you put the constant, don't put the constant at the end. So yeah, because the constant is coming here only, right, otherwise you will make a mistake. So if I am putting the constant here, then if I divide by e raised to power tan x, so your function will be e raised to power minus tan x, c into e raised to power minus tan x. So yeah, that was one point I forgot to tell you, that don't put the constant at the end, put the constant after you solve this integration, right, because after this I will get a constant, otherwise there will be a mistake. So I was wrong there, put the constant here, okay. So here as well, if I am solving this, right, this will be 10 by 5 y raised to power 5 plus some c constant value. So now if I divide by y square, this will be 10 2 y cube plus c by y square, okay, plus c by y square. That will be your simply solution for this equation. Now they have told me that it will pass through the points 0 comma 1. If it passes through the points 0 comma 1, so I will put 0 and 1, so x equal to 0 and y equals to 1, so that will be equals to, c will come out to be minus 2. So your actual equation comes out to be 2y cube plus minus 2 upon y square. This is your actual equation. Now they are also telling me that okay, passes through the point this and 2 comma beta and 2 comma beta, then beta is the root of the equation. So it also, they are telling me that it also passes through 2 comma beta. So if it passes through 2 comma beta, so 2 comma beta should satisfy this equation, and they are telling me then beta is the root of which of the equation. So basically they are asking me for which of the equation beta will satisfy as a root. So let me first put 2 comma beta. Let me first put 2 comma beta. So x equal to 2, x will be equals to 2, so that this will be equals to 2 beta cube minus 2 upon beta square, okay. So if I solve this, right, so this will be beta raised to power 5. If I divide by 2 on both sides, this will be beta raised to power 5 minus 1 minus 2 beta square. I get an equation. So they are asking me which equation will satisfy, like which equation will be root. So if I put beta here in the equation, it should satisfy. So what is the equation? Beta raised to power 5 minus 2 beta square minus 1. So only this equation is satisfying. If I put here beta, y equals to beta, right, this will be beta raised to power 5 minus beta square minus 1. That is exactly satisfying with this equation. So what does root mean? Root basically means it has to satisfy the equation, right? So that's how you will simply convert, solve it. So this was not a linear equation in terms of y, this was a linear equation in terms of x. So that's how you will solve a linear equation in terms of x. Now sometimes what happens, your function, right, is not in the proper format, okay. You will never be able, like sometimes what will happen, you will not be able to divide, like you will not be able to make it linear, like there will be multiplication of your independent variable with the differential coefficient. Then in those kind of cases, how will you solve? So I can take an example here. So is this equation linear? So your answer would be no, this equation is not, is definitely not linear. But let me try to let me try to reduce this to a linear format. So I see, first of all, never there is a function of x multiplied with dy by dx. So first what I will do, I will remove my x. So to remove my x, I will divide by x on both sides. So this will be dy upon dx plus ln of y upon x equals to e raised to power x. Now next thing that I will notice is that I see that okay, 1 by y is also there. So you have to be bit smart here. So although this equation is not linear, but what do I notice? The differentiation of ln of y is 1 by y. The differentiation of ln of y is 1 by y. So I will actually again use the substitution. So I will assume t equals to ln of y. I will differentiate with respect to y. So dt upon dy will come out to be 1 by y, or dt will be equals to what I can do is I can differentiate with respect to x on both sides. So dt upon dx will be equals to, I will apply the chain rule because y is a function of x, right? So first I will differentiate the outside function, then the inside function, that is dy upon dx. So I see this term, right, 1 by y into dy upon dx is present over here. So I will replace this term with dt upon dx plus ln of y, that is t upon x, equals to e raised to power x. Now you have converted it into a linear format. Now you will solve using linear differential equation, and at the end you will put the value of t to be equals to ln of y. So although this equation is not linear, but still you will be able to solve it using you can reduce it to linear differential equation in terms of other variable, and then you can solve it. So what do you need to remember in differential equation? Simplify my differential equation. If this is not linear, how can I simplify it to linear? So you have to be a bit smart. You have to observe that okay, ln y is here, 1 by y is here, right? So the differentiation of ln y is 1 by y. So what if I choose my t to be ln y? What if I do it, right? So then I will differentiate, I will see okay, something like this is coming. So now I can reduce it to linear differential equation, and then you can solve it. I am not solving it, like I hope you can solve the next part. So simply it will be just the same as linear differential equation. Now there is another topic left, that is orthogonal trajectory. What do I mean by orthogonal trajectory? So sometimes they will ask you that when two curves are orthogonal to each other, so find the orthogonal trajectory of all circles with center at origin. So what does it mean? So what is the equation of all circles with center at origin? All circles meaning center is at origin, so it will be x minus 0 whole square plus y minus 0 whole square. Center is at origin. All circles, so radius will be infinite, so I will have infinite radius. So r is a variable, okay, equals to r square. So I get the equation, that is x square plus y square equals to r square. So now they are asking me the orthogonal trajectory. What does orthogonal trajectory mean? To find an orthogonal trajectory, basically we know when two curves are orthogonal, when their slopes are negative of each other, negative inverse of each other. So if I have a curve here, right, y equals to x, when which curve will be orthogonal? Y equals to minus x. Okay, y equals to minus x. If I have a curve here, y equals to 2x, the curve that will be orthogonal to it, right, will be y equals to minus 1 by 2 minus x by 2. Okay, not minus 2x. Minus 2x would be somewhat like this. The slope of minus 2x would be somewhat like this. Okay, minus x by 2, like how can I show you, will it be orthogonal or not? So how can I find out the angle? So this, right, will be proved to you in vector calculus. In vector calculus I will tell you how to find out the angle between two curves. Okay, that I will tell you, but for now you just remember that to find out the orthogonal trajectory, you have to find out dy dx. First you find the differential equation of the family of curves, then you replace your dy dx by minus dx dy, just the inverse, negative inverse of the slope, and then what you do, you solve the differential equation. So they are asking me find the orthogonal trajectory of all circles with center at origin. So first I write down my equation, then from this I will find my differential equation. What will be my differential equation? I will simply differentiate both sides with respect to x. So this will be 2x plus 2y dy by dx equals to 0. Okay, Then what I will do is I will simply solve. I will replace my dy dx with minus dx dy because I have to find out the orthogonal trajectory. So basically what they're asking me the equation of all the orthogonal curves to the circle. So this will be like dy upon dx will be equals to minus of x upon y. So I have to replace my dy upon dx with minus of dx upon dy, minus of dx upon dy, that will be equals to minus of x upon y. So your dy upon dx equals to y upon x. So from here I can simply solve it. This will be y will be equals to x plus c, like it will come out to be ln y plus ln x equals to some constant. It will come out to be y equals to x plus c. Now what is my c? What will be my c? So I know, okay, hold on a second. So if I solve this, right, this will be ln y equals to ln x plus c, or I can write this as ln of c, right? For my own convenience, I can write this as ln of c. So this will be, if I take the exponential on both sides, this will be y equals to cx. Okay, so basically this will be like, what is the orthogonal trajectory of all the circles? It will be a straight line passing through the origin, all the straight lines that is passing through the origin. So you see the curve will always come out to be orthogonal. This, right, whatever I have solved, this is coming out to be always orthogonal, correct, to the family of circles. So that's how you will solve for orthogonal trajectory. So let's take an example. Find the orthogonal trajectory of the family of curve this. So what do you need to do? First you have to find out the differential equation. So I will differentiate with respect to x on both sides. So this will come out to be k. Then I will replace my k with minus dy upon dx. So if I replace my k with minus dy upon dx, what will come out? This will be minus, I will replace my dy upon dx with minus dx upon dy. Okay, this will be equals to k. Now if I solve it, this will come out to be minus of x. Now first of all, already like there will be a constant that will come after integrating. I don't want another constant, right? And I know what is the value of k. What is the value of k? Value of k is y upon x minus 1. Value of k is y upon x minus 1. So this will be replaced minus of dx upon dy will be replaced with y upon x minus 1. Now you will solve this, because you will write your differential equation eliminating all the constants. Constants should not be present because this k value already I know. Okay, this k value already I know. So now if I solve it, right, this will be minus of x square divided by 2 plus plus x plus c equals to y square divided by 2. So basically your y square, this can be c by 2. Your y square will be equals to x square plus 2x plus c. So this is my family of curves. Now yeah, this is my family of curves. You can further simplify this thing, like this can be x plus 1 whole square or something like that. You can further simplify this. Okay, minus x square is there, right? Minus would be there. Yeah. So yeah, that's how you can okay, this is also minus, right? This is x minus 1 minus plus x. Okay, so yeah, that's how you will basically solve this. So this will be your like equation family of curves that are orthogonal to this particular curve. That's it. So now let's start with the solution of higher order differential equation. If I have higher order differential equation, then how can I find out the solutions? So this will be the general form for a higher order differential equation. Let's like take few examples, and remember we are only concerned for those differential equation whose order is higher but degree is 1. So we can only solve for 1 degree higher order differential equation, as I have told you, right? So we cannot solve for like higher order, higher degree differential equation, more than one. So we will see how, like, these are all my higher order differential equation, but here this, remember, this is the independent variable. So independent variable can be anything, but check the degrees of my dependent variable and the differential coefficient. So all these are 1, so no problem. Here also all these are 1. This can be anything, right? This is a independent variable. Okay. So actually there are two kinds of equations, homogeneous and non-homogeneous. Homogeneous meaning if the right hand side is 0, if it is non-homogeneous, right hand side will not be 0, but we don't need to consider all this, right? We can simply solve using a simple method. So I will show you using simple method. So there are many things here. First of all, let's come to this question. So we have to write the general solution if the roots of certain equation is this. What is the general solution if the roots are 3 and 5? How can I write a general solution? So let's say the variable is m. So if roots are 3 and 5, so 3 and 5 are factor. So m minus 3 into m minus 5 will always give me 0, right? So from this I can form a equation. What will be the equation? Equation will be m square minus 8m plus 15 equals to 0. Okay, m square minus 8m plus 15 equals to 0, right? So this is the quadratic equation, and here also you can simply find out what is the quadratic equation. It will be m plus 2 into m minus m plus 3, sorry, m minus 3, and from there you can form the quadratic equation. Now the interesting fact is, we in our higher order differential equation, right? Where is my higher order differential equation? This is actually called as the solution of only this, right? If I take this and if I solve, this equals to 0. If I make this equal to 0, so the solution of this particular differential equation, if I make this equal to 0, right? This is actually called as the complementary function, complementary solution. And the solution of only this part is called as the particular integral. So first we will discuss when the right hand side is always 0. When the right hand side is always 0, how can I find out the solution? So here I think we have few equations here. So I see all of them has right hand side 0. So what I will do is, what is y dash? Y dash is d square y upon dx square plus 5 of dy upon dx plus 6 into y. So what we do is I can write my dy upon dx as some capital D into y. Why capital D is nothing but the d upon dx. Why am I writing it? I will explain. So I will replace my dy upon dx with capital D into y. So this will be capital D into y. So this is d square y upon dx square. So this will be like my d square will be dx square upon dx square, right? So this will be d square into y plus 5 into dy plus 6y equal to 0. Okay. Now I will take my y common. So if I take my y common, this will be d square plus 5d plus 6 equals to 0. So now I will find out the roots of this equation in terms of d, and the roots will tell me what will be my complementary function or complementary solution. So here I see the roots are very simple, d minus 2 into d minus 3. These are my roots of my equation, which are real and distinct. So d equal to 2, right? This is the root. D equal to 2 and d equal to 3. These are my roots. So if my roots are real and distinct, then my solution will be c1 into e raised to power alpha x plus c2 into e raised to power beta x. Basically whatever are your roots, that will be in the solution if they are real and distinct. Okay, in terms of exponential. So this will be the solution of y for this particular equation. That's it. That is how you will solve. So what is your alpha and beta? Alpha is in our case 2 and beta is 3. Alpha is 2 and beta is simply 3, right? Am I correct here? minus of, sorry, this will be plus, right? Sorry, what am I doing? This will be plus. This will not be minus, this will be plus. So your roots will be minus 2, minus 3. So your alpha, so what will be your solution for this equation? C1 into e raised to power minus of 2x plus C2 into e raised to power minus of 3x. That's it. How can you cross verify? You differentiate this once, you differentiate this twice, and then you put this in the equation. You will see this will be equated to 0. So that's how you simply solve a homogeneous higher order differential equation. Now if my roots are not real and distinct, right, they are, let's say in this case, if they are, here are they real and distinct, here again they are actually real and distinct, 4 comma 2, my roots are 4 comma 2. So again they are real and distinct. So what will be the solution? The solution will be C1, like because it is a second order differential equation, so I will have two constants. If it was third order differential equation, I would have had three constants. So this will be C1 e raised to power 4x, okay, and okay, just hold on, this sorry, yeah, okay, my roots are, yeah, my roots are minus 2 and 3. Here also, what are my roots? My roots are minus 2 and minus 6, right? Yeah, minus 4 and minus 6, yes. So this will be minus 4 plus C2 into e raised to power minus 2x. That will be your solution. That's it. In one line you are able to solve. You don't need to think of anything. Whenever your roots are like simply real and distinct, simply it will be in terms of exponential. Okay. Now if your roots are repeated, here I see my roots are repeated. So this is basically d plus 2 whole square. So 2 comma 2 roots are repeated. So if my roots are repeated, then your solution will be similar to when they were distinct, but with a twist. So it will be C1 plus C2 into e raised to power, sorry, this is minus 2 minus 2, right? E raised to power minus 2 x. Okay, this will be your equation. When your roots are repeated, one of the exponential term will be simply 1. This will be gone, other term will be there, that's it. Also one more thing, okay, I forgot to sorry, I made a mistake. If your roots are repeated, you will write C1 plus C2x into e raised to power minus 2x. Now as the roots are repeated, right, as the roots are repeated, that's why there was like e raised to power minus 2x is with all the terms. As the roots are repeated, so your e raised to power minus 2x is with all the terms, C2 e raised to power minus 2x. So this will be there. But as my roots are repeated, I have to put an extra x over here. That's it. That is the only difference. If the roots are repeated, I had to put an extra x. Now, if your roots are repeated thrice, then what I will do? This will be, let's say I have three roots at x equal to d equals to minus 2, d equals to minus 2, d equal to minus 2. Then this will be C1 into x into C2 plus x square into C3 into e raised to power minus of 2x. So with all the constants, of course, e raised to power minus 2x will be there. Just this extra x and x square will be there. That thing you have to remember for repeated, real repeated roots. If my roots are real and repeated, that's what you have to remember. Okay, let's solve the next one. So here I see that I am getting a complex solution. Okay, complex solution. So here minus b plus minus b square, that is 1 minus 4ac, that is 4 divided by 2, right, equal to that is equals to my x. So this is equals to x is equals to minus 1 by 2 plus minus I root 3 by 2. Now here I see my roots are not real and distinct, they are imaginary. If your roots are imaginary, then the real portion will come with exponential and the imaginary part will come with cos and sine. What do I mean? Then your answer will be, your solution will be y will be equals to, you write first the exponential. What is the exponential root? Real part minus 1 by 2. So this will be with minus 1 by 2 x by 2. And what is the imaginary part? Root 3 by 2. So I will have a C1 cos of root 3 by 2x plus C2 a sine of root 3 by 2x. If this was 2, then here I would have had cos 2x plus sine 2x. That is it, right? So that's how you can simply solve if my roots are complex conjugates. Okay, that's how you can solve if your roots are complex conjugates. Now if we have a more than like higher order differential equation whose order is more than 2, then how can you solve? So in those kind of cases, mostly in GATE exam, the roots, one of the roots always will be either plus 1, plus minus 1 or plus 1 is 2. So you will put here 1 and check whether 1 is a root or minus 1 is a root or 2 is a root or minus 2 is a root. So they are not expecting you to find out the root of a cubic equation. There is a method to solving for the root of a cubic equation. You can use long division. I will not explain long division. Just you see the method, you can understand what is a long division. Or you can use some simple tricks. If I know the cubic equation, then the sum of the roots will be minus b upon a. The product of the roots will be minus d upon a. So these two equations you can use to find out the other two roots if you know one of the roots. Okay, but of course I am not into that right now. We will use heat and trial method. So if I put here my d equals to 1, this will be 1 minus 4, that is minus 3. This will be 5 minus 2, that is plus 3. So 3 minus 3 equal to 0, that is satisfying. So definitely 1 will be a root. So if 1 is a root, right, then you can perform your long division. So if 1 is a root, m equals to 1 is a root, then m minus 1 will be a factor. So I will divide my equation with m minus 1. So if I divide my equation with m minus 1, you can use long division. I will not explain. So first you have to remove the cubic coefficient. So what do I need to multiply with m minus 1 so that this cubic coefficient is removed? So if I multiply m square, right, this will be m cube minus m square. So again this will be subtracted. So I will be left with minus cm square and this will be coming here, right? So I will not explain long division. Search how to do long division. This again I have to eliminate this term. Always try to eliminate the higher order term. So I will eliminate minus 3m square. So if I subtract with if I multiply this term with minus 3m, I will get minus 3m. So this will be cancelled. Again I will be left out with this one, and ultimately you will see that everything is cancelling. So this will be your other factor. This is my other factor, and for this it is a second order equation. You can simply find out the roots, but I am expecting they will not give you third order. But if they give you, right, I am teaching you everything. You can find your roots using long division, and then whatever I have told you, use that, right? If my roots are real and distinct, it will be simply in terms of exponential. If they are real and repeated, then you will simply write that in terms of what do you call, in terms of like all the terms will be with same exponential, but there will be x square, something like that. If I have 3 repeated roots, it will be x, like c1 plus x c2 plus x square c3 into e raised to power minus whatever the root is into e raised to power root is, and if it is repeated twice, then this will be c1 plus x c2 into the root term. Now there are few more cases, like okay, you don't have to remember the third case, that is like not important. Yeah, that is it only, I guess. Yeah, these are the cases only. Yeah, these are the cases, that's it. Now if your root is only imaginary, then this term will be what? Your real part is 0, right? Your root is purely imaginary, so this will be e raised to power minus 0, that is 1. So you will only have cos and sine, that's it. You will only have the cos and the imaginary part of the root, that's it. So that is like easily understood. So that's how you will simply solve your higher order differential equation. So let's solve. I think there is a, there's a question here, this one. So let's solve this differential equation. So first of all, this is a homogeneous, so things are very simple. So I will only get the complementary solution. So what will be my YC? If that YCF will be my overall solution, because this is a homogeneous equation. If this was not a homogeneous equation, my overall solution would have been YCF plus YPI. How to calculate YPI, I will explain. So what is YCF? I can convert this into my like quadratic equation. So what are my roots here? My roots are again minus 4 comma minus 2. So what is my equation? My equation will be c1 into e raised to power, just give me 1 second, minus 4x plus c2 into e raised to power minus 2x. Okay, so now finally they have given me two initial conditions, because I have two constants. That's why I need two conditions to solve for c1 and c2. So x of 0 is 1. So if x of 0 is 1, basically, okay, you are making a huge mistake here, right? Remember what is your independent variable and dependent variable. So be very careful, right? So this is wrong because your independent variable is t. So you have to write your x in terms of t. So although we are accustomed y in terms of x, right? But whatever differential equation they have given me, make sure you are solving properly. So they have given me x in terms of t. So x is like y here, right? So my solution will be x equals to in terms of t. That will be c1 into e raised to power minus 40 plus c2 into e raised to power minus 2t. Okay, so now I can easily find out. So when x of 0 meaning when t is 0, x is 1. So x is equals to 1 when t is 0. So basically I get c1 plus c2 equals to 1. That is the one of the equation. Other equation is x dash of 0. So I will differentiate this function. That will be x dash of t equals to minus of c1 e raised to power of minus 40 plus minus of c2 e raised to power minus 2t. Okay, now I will make t equal to 0. So if t is 0, they are giving me that x dash of 0 is 0. So this will be 0 equals to minus of 4c1 minus of 2c2. So from here I get the another equation, that is c2 equals to minus of 2c1. So I will replace my c2 here. So my c1 will be equals to minus of 1. So c1 comes out to be minus of 1 and your c2 will be 2. Okay, so I can write my equation x of t equals to minus of e raised to power minus 40 plus 2 e raised to power minus 2t. So yeah, that is the solution. This is the simply solution. That's it, you're done, right? So that's how you will solve. Now what is the solution for non-homogeneous equation? So non-homogeneous equation meaning if the right hand side is not 0. So your solution will be combination of the complementary function plus the particular integral. How to find out the complementary solution? Very simple, right? What is the complementary solution for this one? Simply find out the roots. I have a repeated root d minus 2 whole square, right? So I have two roots like d is equals to 2 comma 2. So what is the complementary solution? YCF would be c1 into c1 plus c2 into x into e raised to power 2x. That is done. But what is my particular solution? So particular solution, right, is simply I will write here. If I write what is my y equals to, y is equals to this. If I take this on the right hand side, if I take this on the right hand side, divide by right hand side, right, this will be 1 by d square minus 4d plus 4 e raised to power 2x. So this is actually my particular solution. So whenever I will have a exponential as a function, right, this will be what? This will be d minus 2 whole square into e raised to power 2x. Whenever I will have an exponential as a function, I can easily solve it. So I will just take one example. For now, let's just assume this is e raised to power minus 2x. Okay, I want to take a case. For now, let's just assume it is e raised to power minus 2x. If it is e raised to power minus 2x, right, then whatever is the coefficient of x here, right, exponential, that is the value that you will put here. Whatever is the coefficient of x, that is the value that we will put for an exponential function. For an exponential function. Now these things you have to remember. Like I have already told you, like yeah, here these things you have to remember. Unfortunately, these are methods you have to remember. Okay, so whatever is the coefficient of exponential, you will put it here. So what is the coefficient? Minus 2. So the answer will be e raised to power minus 2x. This will come out to be minus 2 whole square. Like in place of d, I will put minus 2. So this will come out to be e raised to power minus 2x upon 16. E raised to power minus 2x upon 16. So that will be the simply particular solution. So this will be YPI. right? So overall solution will be summation of this one plus this one, that's it. You are observing that in YPI I don't have any constant because it is a particular solution. It is not a it is not a family of curves, it is a particular solution. That's why I will not have any constants here. Okay, so that is the thing that we have to take care basically. So now one more thing is there. Now what if this was 2? If this was 2, right, then if I put here d equals to 2, this will be 0 and 1 upon 0 is undefined. So whenever you get 0 after putting the value of a, right, so what you will do, you will simply differentiate the bottom function and multiply by x. This again you have to unfortunately remember. Okay, this again you have to unfortunately remember, right? So in this case I was getting 0 here. So if I am getting 0, so what I will do, I will not put the value, I will differentiate the inside function, that is 2 into d minus x, 2 into d minus 2, and at the top I will put a x. Okay, and this will be e raised to power 2x. Now again if I put 2 here, right, again this goes to 0. Again I will follow the same method. I will multiply by x at the top, so this will now become x square upon, if I differentiate the bottom, this will be simply 2 with respect to d, right? This is e raised to power 2x. Now if I put 2, no problem. So this will be my particular solution. Okay. Yeah. Now what if here instead of e raised to power 2x, you had e raised to power 2x plus 1? Will anything change? Nothing will change. If this is e raised to power 2x plus 1, right? So you can write it as e raised to power 2x into e. So e is just a constant that can come outside, no problem. Whatever is constant that can come outside here, only the function of x will be there, that is the point of concern. So this was the type 1. Now in type 2, right, what if I have here power? If I have here power, can I convert this in terms of my exponential? Yes, I will just calculate the particular integral now. So this will be 1 by d square plus 9 2 raised to power x, and 2 raised to power x can be written as e raised to power ln of 2 raised to power x. Yes, it can be written as e raised to power ln of 2 raised to power x, that can be written as e raised to power x ln of 2. So what is my coefficient? Coefficient is this, ln of 2. So what I will do, I will replace my d with ln of 2 whole square plus 9, and this will be simply e raised to power x ln of 2. This can be again converted back into 2 raised to power x, right? So this will be 2 raised to power x upon ln of 2 whole square plus 9. So that will be the particular solution for this particular case. What about this one? Again, if it is constant, right, it is nothing but 16 into e raised to power 0 into x, correct? So here I have to simply put 0. So this will be 16 upon e raised to power 0x. So if I put 0, is it going to 0? No. So this will be 0 square plus 4, that is 4. So the particular solution for this will be YPI will be 4. That's it. Now let's solve for the type 2. In type 2, if I have sinusoidal functions, sinusoidal or cosinusoidal functions, if I have sinusoidal or cosinusoidal functions, then you will replace your d square with minus of a square. You will replace your d square with minus of a square. What do I mean? So what is the particular solution? Particular solution will be sin 2x upon d square plus 9, right? That is my particular solution. So I will replace, so what is my a? Sin ax. What is my a? A is simply 2, coefficient of x, coefficient of x. So I will replace my d square with minus of a square. So this will be minus of a square, that is minus of 2 square plus 9, and sin 2x can come here. And please keep in mind that it should not go to 0. So this will be sin 2x by 5. Okay, so that is your particular integral over here. Okay, this is the solution simply. Now what if here in this case what is happening is that if I put minus of a square here, minus of a square here, this will be 0, this will be gone to 0, right? Okay, this will be gone to 0. So now again same method, right? I have to differentiate the bottom and multiply by x at the top. So this will be 2d plus cos 4x. Now the problem here is, in the bottom I don't have d square. So what you will do, you will try to convert this into d square. You can either try to convert this into d square, or what you can do, what is d? D is differentiation. So 1 by d will be simply integration. Okay. Either you can understand it like this, that d is differentiation, your 1 by d will be integration, or what you can do, if you are not comfortable, you multiply and divide by d on both sides. So if I multiply and divide by d on both sides, so in the numerator I get 2d square. So now I can replace my, what is the a here? A is 4, right? A is 4. So now I can replace my d square with minus of a square. So this will be 2 into minus of 4 square. At the top I have x into d. Now x will be always outside. X into capital D. Capital D is d dx. And what is the inside function? Cos of 4x. So I will just differentiate cos of 4x, that will come out to be minus of sine 4x into 4. So this will be basically minus will be cancelled. This will be x upon 8 into sine of 4x. That will be your particular solution. So what did I do? I just simply multiplied and divided by d on both numerator and denominator, right? Then d square I will replace with minus of a square x. A in our case is 4. So this will be minus of 4 square, and d is nothing but, capital D is nothing but d dx. So x will always be outside. Remember, x will always be outside. So d is capital D dx. So now I am differentiating my cos 4x. So what is the differentiation of cos 4x? That is 4 into sin 4x, minus 4 into sin 4x. So after simplification, this will be your particular solution. Similarly, let's take another example. Let's take this third example, right? If I take this third example, again, first of all, you will put here d square minus 4d plus 3 equals into cos of x. So these things you have to remember. Unfortunately, with practice, automatically this will be in your head. So you replace your a with minus of 1 square. So this will be 1 by minus 1. You cannot replace your d. Right? So I will keep my d as it is, plus 3. Okay. This will be cos of x. Now this will be equals to 2 minus 4d. So I can take 2 common. This will be 1 minus 2d into cos of x. 1 minus 2d into cos of x. Now again, what I will do, I will convert this, like I need d square. I want d square. How can I get d square? If I cross multiply 1 plus 2d. So this will be 1 plus 2d upon 2 into 1 minus 4d square into cos of x. Okay, so this will be 1 plus 2d. Now I can replace my d square with minus of a square. So this will be 1 plus 1 minus 4 into minus of 1 square. So like minus of 1 square into cos x. So ultimately this will be what? 1 divided by 10, and if I now I will multiply this term, right, with this one. So 1 into cos x is cos x, 2d into cos x plus 2 into d dx of cos x, that is minus of sin x. So this will be minus of sin x, and this will be your particular solution. 1 by 10 into cos x minus of sin x. I'm doing this in rough, that's why like it is a bit crowded, but I hope you get the point. Now there is the last one. This one I don't feel they will ever give you. If you want, like this one, generally we don't remember. Okay, we tend to forget that. If you have this last one, right, if you have a power of x directly, then how to solve it? So you will simply, like this will be a bit lengthy, you will have to simply solve using long division. How? So here, right, what is my particular solution? So complementary function is already there, that is separate. Complementary function is this equal to 0, that you can solve, right? Overall solution will always be combination of the particular integral and complementary solution, remember, right? So that obviously those we will solve. But here, how will I solve this particular solution 2d plus 2x square? So you have to use the long division method. What is the long division method? So I will have my number that I want to divide by, that is here, right? D square minus 3d plus 2. Okay, and then what you will do is you will simply do the division. So what shall I multiply with this term so that I can eliminate my x square? So I will multiply x square by 2 because this is 2, right? So I will multiply by x square by 2 so that I can eliminate my x square. My target will be always to make this 0. So if I multiply by x square by 2, this will be x square, and what is 3d into x square? It is nothing but 3 into d dx of x square. So this will be 2x into 3. So this will be actually 3 into, sorry, minus, because negative sign is there, minus 3x. Sorry, not minus 3x, minus 6x, right? Because 2x is there. Minus 6x. Am I correct? Yes, minus 6x. 3d is there. I am differentiating my x. Sorry, x square by 2 is also there, right? So x square by 2. So this will be actually minus of 3x only. Okay. What about the last one? I am differentiating twice x square by 2. So once it will be x, then it will be 1. So this will be simply equals to plus 1. Now I will do the long division. This will be plus 1, this will be minus 1. So this will be 3x minus 1. This one is automatically gone. Now my next target would be to eliminate this one. So what shall I multiply here so that I can eliminate, like I can make it 3x. So I can multiply this term with 3 by 2x. If I multiply by 3 by 2x, I can eliminate my 3x because this multiplied by 2 will be 3x. So this will be 3x and this will be minus 9 by 2. Okay, minus 9 by 2. And yeah, then if I subtract this, right, this will be plus, so this will come out to be 7 by 2, right? So now what will I multiply? I will simply multiply by 7 by 4 to eliminate this term, right? If I multiply by 7 by 4, all this will be 0, so automatically this will be eliminated. So your particular integral will be this, because what have I done? I have simply divided by x, right, x square. So this is your solution, that's it. This is my particular solution. Okay, similarly you can solve for this one. Okay, you will again find out the values. I can like do it by yourself. This will be x square plus 4. I have it written x square plus 4. Then I have here x by 2 plus 3 by 8. Okay, solve it right now. Pause the video and try to solve it. You will get this solution by long division. Okay, now if I have combination of functions, then how can I solve it? Let me take an example. Here if this is e raised to power 2x into cos x, then what you will do? You will first of all see, you will try to see like you will replace, like if I have e raised to power 2x cos x, right, then whichever one is multiplied with exponential, I will replace my d with d plus a, where a is the coefficient of x. Okay, so here if I have e raised to power 2x into cos x, so I will replace my d with d plus a. So if I replace my d with d plus 2, so this will become d minus 1, and if I replace here my d with d plus 2, this will be d, and I can take my exponential outside this operation, right? So this exponential can be outside, so cos x will be here. And then I hope now you know how to solve this. You can very easily solve this, right? This will become d square minus d, and you can replace your d square with minus of 1 square. This will be 1 minus d, and then again you can do the cross multiplication, and finally you will find out the solution. So if exponential is multiplied, simply you replace your d with d plus a. So this is the only thing that you need to remember for higher order differential equation. Now there is last one more thing that we have to discuss regarding the Cauchy differential equation, and this has been asked. So this is actually again a important one. So if I don't have x square plus d plus 1 like this, right? If my, remember, if the independent variable is multiplied with my dependent variable, so independent variable is multiplied with my coefficient with same power, then how to solve those kind of things? Then what you will do, then you will replace your x with e raised to power z. Why so? Because if I differentiate this x with respect to z, right, this will be e raised to power z dz. So this is e raised to power z dz. Now if I write what is my z, so what is z is ln of x, correct? Z is ln of x, yes. So what will be x into d, that is d dx, right? X into d, that is d dx. So like, what do I mean? So what will I do is x is e raised to power z, right? So dx is e raised to power z dz, and this is nothing but x. So I can say this is x, dx upon dz is x, right? Dx upon dz is x itself, right? So I can say that if I now cross multiply one thing, so what will I do? I will do dx upon, I will cross multiply this. So x upon dx equals to 1 upon dz, and if I multiply by d on both sides, right, I'll just simply multiply d on both sides. This is not the actual method, just for your convenience I'm doing it, okay, just to understand intuitively what is happening. So d dz equals to x into d dx. So ultimately, like, I want to replace my x into d dx, right, with this d dz. So that is my aim basically. Our differential coefficient can be replaced, x into d dx can be replaced with d by dz. So I can replace here x into d whole square, right? I can replace it with some other variable, okay, some other variable, let's say t, or let me write it as dz, where dz is the differential coefficient of z. Dz would be the differential coefficient of z, but you cannot simply replace your, like, this will not be simply x into d whole square, no, not like that. Your x into d can be replaced with dz, okay, these things you have to remember, and your x square d square can be replaced with dz into dz minus 1. Similarly, your x cube d cube will be replaced with dz into dz minus 1 into dz minus 2. It will be like a factorial. So that is why we replace it in terms of exponential, because I want to replace this properly in proper higher order format, okay. So that is what I will do. So whenever I have x into d, so x into d will be replaced with dz into dz minus 1 plus an x, like this was x square into d square. Now your x into d will be replaced with dz into dz plus 1. Now I will find out the roots of this equation and of course the particular solution of this particular equation. Okay, don't forget to find out the roots and particular solution of this equation. So this will be, what will be the roots? This will be dz whole square plus 1. Okay, dz whole square plus 1. So the roots are coming out to be imaginary, right? Purely imaginary. What are the roots? dz equals to, for complementary solution, plus minus iota. So what is my complementary solution? So your complementary solution, right, it will be equals to c1 into e raised to power root, sorry, not c1, so roots are here imaginary, So e raised to power 0 into x, that is anyways gone. C1 into sine or cos, sine of whatever is the root, right, that is 1. Sine of, will I write here x or z? Remember, this is the differential coefficient of z. So you will not write here x, you will write here z. Okay, you will not write here x, you will write here z, because this is the differential coefficient of z, because this is the point where most of the students will make a mistake. This will be c1 sin z plus c2 cos of z. Later on, of course, I will replace my z with x, but for now this is my complementary solution. What about the particular solution? So particular solution, right, will be this divided by x square. Now what is x square? What is x? X is e raised to power z, because this is the differential coefficient of z, so I have to convert everything in z. So this will be e square of z, e square z. Okay, so this will be e square z. Now now can I solve it? Yes, I will just simply put here e square 2z. What is a here? A is 2, so I will put here in terms of dz in 2, right? This will be 2 square plus 1, that is e raised to power 2z upon 5. So what will be finally your solution? Your solution y will be equals to complementary solution plus your particular integral. So what is my complementary solution? C1 into cos or sine of z plus C2 into cos of z plus your particular integral. Your particular integral is simply e raised to power 2z divided by 5. Now I will replace my z in terms of x. What is my z in terms of x? So your z, right, is ln of x. So I am not showing you what is the proof. Proof is given here, like how am I converting my differential equation. We are not interested in that. So now I will replace C1 will be sine of ln of x plus C2 cos of ln of x plus e raised to power. Now e raised to power 2z is nothing but x square by 5. So this is your complete solution. Let us take another example, this one. Okay, so the differential equation is x square d square minus xd. Now the differential equation chapter, like the initial portion you don't have to remember anything, but the second portion where you have to solve for higher order differential equations, you have to remember certain things, and mostly the questions will be very easy. Question for higher order differential equation, the questions will come out to be very easy. They will not give you difficult questions, because they also understand that there are many things that you need to remember here. Minus xd plus 1 into y equals to my ln of x. So whenever you see a format like this is a Cauchy's differential equation format. So what you do, you simply replace your x with e raised to power z. So this will become x into d will become dz into dz minus 1 plus minus dz plus 1, okay, into y. What is ln of x? Z. So this will be dz whole square minus 2 dz plus 1 into y equals to z. So this will be dz minus 1 whole square into y equals to z. So from here I get two equal roots, that is 1 comma 1. So what is the complementary solution? Complementary solution, right, will be like C1 into plus C2 into, it will be x, no, differential coefficient is z, so it will be z. So you will write here C1 C2 z e raised to power whatever is the solution, that is 1, so it will be e raised to power z. That is my complementary solution. What is my particular integral? It will be z upon 1 by dz minus 1 whole square. So again I have to solve this using my long division method. So here I will have z and I will have to divide dz minus 1 whole square. So I will put it properly, dz whole square minus 2 dz plus 1. So if I multiply by z, right, so this will be automatically gone. If I multiply by z, this will be gone. So the solution of this, right, will be simply, will it be z? Give me 1 second. this will be dz minus plus, sorry, this is, yeah, d minus 1 whole square. So if I multiply by z here, if I multiply by z, right, this will be z minus 2. So this will become plus. So I will have here 2, because if I'm multiplying by z, right, that means if I multiply these with z, this will be z and differentiation of ddz of z, that is 1 into minus 2, that's why minus 2, d square dz square of z. So I'm double differentiating, that will be simply 0. So it will be plus 0. So only this one will be left. So z and z will be cancelled. So minus 2 will be left, that is 2. Okay, 2 is left. Now if 2 is left, right, then I have to eliminate 2. So I will multiply by plus 2. So this will be 2 plus 0, because whatever I differentiate 2, right, that will always come out to be 0. So ultimately this will be the particular solution z plus 2. So what will be my overall solution? Overall solution will be ypi plus ycf plus ypi, that is c1 plus c2 into z. Now what is your z? Z is ln of x. Z is ln of x. So this will be ln of x. Your z, you will replace your z with ln of x. What is e raised to power z? E raised to power z is x. This will be x plus, what is the particular solution? Z plus 2. What is z? Z is ln plus x. So this will be ln x plus 2, not ln plus x, sorry, ln x, right? So this will be a solution basically. So that's how you solve for a higher order differential equation. Now, like, it is modified. If your format is something like this, ax plus bx, like this right, 1 plus x whole square, 1 plus x whole square, some constant multiplied, what you will do? You will make your e raised to power z equals to 1 plus x. You will make your e raised to power x equals to 1 plus x. That is what you do, and then you can solve this. So this will be replaced with, again, dz into dz minus 1. This will be replaced with dz and plus 1 into y equal to 0, and then you can simply solve the differential equation. Okay, so here what does my like cf comes out to be? Cf will be dz whole square minus dz. So dz whole square plus 1. Again, your cf comes out to be purely imaginary, so equal to 0. So it will be c1 into sine of z plus c2 into cos of z. This is my cf plus the particular integral. So what is 2 ln of 1 plus x? So if I take the log on both sides, this will be z will be equals to ln of 1 plus x. So what will be 2 ln of 1 plus x? It will be 2z. So I have to divide by dz square plus 1 into 2z. So again I will do the long division, 2z dz square plus 1. So if I multiply by 2z, right, this will be 2z and the other term will be simply 0, because if I double differentiate z, it will be 0. So 2z will be my simply particular solution. Is it correct? No, don't forget there is a sign. Okay, so you cannot just do it because it was sine, right? It was sine of 2z. Okay, sine of 2z. So I will replace my dz whole square with minus of a square. So this will be replaced with minus of 2 square plus 1 sine of 2z. So this will come out to be sine of 2z divided by minus 3. So what will be your solution? Y solution. Your solution will be c1. Now what is your z? Z is ln. Your z is ln of 1 plus x. That is what your z is. So your z is ln of 1 plus x. So this will be sine of ln of 1 plus x plus c2 into cos of ln of 1 plus x plus the overall solution. So this will be minus of sine of 2z. Again, z is ln of 1 plus x. So this will be sine of 2 ln of 1 plus x upon 3. So this will be finally your solution. Okay, bit lengthy, but these are the things. I'm not skipping anything, right? I'm teaching you every single thing, and I'm not expecting they will ask you this much. They will not go into this much of detail, but like I'm going for the worst case. Now there comes partial differential equation. Partial differential equation is nothing but like if you partially differentiate, right? That you know. Now you don't need to like worry about anything. Just you need to worry about two things: how to find out the order and degree of a partial differential equation, and general format of a second order partial differential equation. And this topic will not be asked from EECIN. Mostly this will be for civil and mechanical. Okay, mostly this will be for civil and mechanical, not for EECIN. So how can I find out the order? So here the order and degree will be 1, like because both the equations are 1. So how to find out the order? The order of a partial differential equation is defined as the order of the highest partial derivative occurring in the PD. It is same as the ordinary differential equation. What is the order of the, what is the degree of a partial differential equation? It is the degree of the highest differential coefficient. How to check linear? A partial differential equation is said to be linear if the dependent variable and its partial derivative occur only in first degree and are not multiplied otherwise. So this you don't need to remember because they will anyways not ask you. Just consider how to find out the order and degree. Finding out the order and degree is same as the ordinary differential equation. So I see what is the order here? 1. Both of them has 1. So what is the degree? Also 1. What is the order here? Order is 3. What is the degree? Degree is 1. Okay, you don't worry about linear right now because they will not ask you. I'm expecting they will not ask you. Again here, right? What is the order? First of all, I have to remove the radical. What is the order? 2. Highest order is 2. And what is the degree? 2. Order and degree are 2. That's it. Okay, so that's how you will simply solve your question for order and degree of a partial differential equation. Now one more thing is there, standard general form of second order differential equation. This again you have to remember. Unfortunately there is no other option. Like this is your standard format, and if your b square minus 4ac comes out to be 0, then we say this is an equation of parabolic. If it comes out to be greater than 0, then we say hyperbolic. Greater, hyper, that's why greater meaning hyper, and less will come out to be elliptical. Okay, if it is less than 0, it will come out to be elliptical, because they have asked questions from this, right, in civil. So you have to remember. So what are the coefficients? So it will be a into dz whole square x square. So what is the coefficient of d square f upon x square? That is x. So coefficient a is x, a in our case is x, and what is b? B is the coefficient of d square f upon dy square, that is y. Sorry, b is not the coefficient. Sorry, c is the coefficient of d square z upon dy square, that is y. What is b? B is the coefficient of d square z upon dx dy, that is simply 0. So you will do b square minus 4ac. Once you see b square minus 4ac, it comes out to be minus 4xy. Now if x and y both are positive, then this will be negative. This will be negative, so it will be elliptical. If x and y, one of them is negative, right, and other one is positive, then this will be positive, then this will be hyperbolic. And when this will be parabolic, when any one of them will be 0. But here they are telling me both of them are greater than 0, not possible. So questions like this will come, that's it. Either you will tell the order and degree, or you will tell whether it is a parabolic or elliptic. Okay, what is the like behavior, what is the format of my curve. So now finally we will start with the quotients of differential equation. So let's solve this first question. Consider the differential equation. The integrating factor for the differential equation will be, so they are simply like, is this a linear differential equation? Here I have under root of y. Okay, so this should be all function of x. So I will divide by under root of y on both sides, because what was the standard format of my linear differential equation? It was dy upon dx plus p into x into y equals to q of x. Both should be purely functions of x, right? So I will divide by under root of y. As soon as I will divide by under root of y, you will feel like this is not a linear differential equation, and you will not be wrong. This is not a linear differential equation. But I can do bit of modification over here, right? Again, I see that this, right, if I differentiate this term, I get back this, right, 1 by under root of y. So I can convert this into a linear differential equation. So I can assume my t to be under root of y. So dt will be equals to, dt upon dx will be equals to 1 by 2 y into n minus 1, that is under root of y, into dy upon dx, using the simply the chain rule. So dy upon dx will be equals to 2, hold on a second, sorry, dy upon dx into under root of 1 by y will be equals to 2 into dt upon dx. So I will replace this in this equation, and I will replace my under root of y to be equals to t. So this will be 2 into dt upon dx plus x upon 1 minus x square into t equals to x. So again, because coefficient of the differential term should be totally 1, so this will be 1 minus x square divided by 2 into t equals to x by 2. Now finally I can find out the integrating factor. So they have just asked me what is the integrating factor. So I will find out the integrating factor for this differential equation, which will be same as this one, okay, because I am able to reduce my differential equation. So what will be the integrating factor here? It will be e raised to power integration of x by 1 by 2 can be outside 1 minus x square dx. This is my simply my integrating factor, okay. So I can again do some substitution. So I can assume my s to be 1 minus x square. So my ds will be minus 2x dx, or x dx will be ds by minus ds by 2. So I will replace my x dx with minus ds by 2, and the bottom will be replaced with s 1 by 2 e raised to power. So this will be e raised to power minus 1 by 4 ln of s. So this power can go inside, which will be e raised to power ln of s raised to power minus 1 by 4. So ultimately this will be s raised to power like 1 by s raised to power 1 by 4. What is s? S was equals to 1 minus x square. So my integrating factor will be 1 minus x square raised to power 1 by 4. This will be my integrating factor that is present in option B, like minus 1 by 4. Minus 1 by 4 is same as the inverse, okay. So option B will be your correct answer for this question. 1 minus x square raised to power minus 1 by 4. Like this can be written as 1 minus x square raised to power minus 1 by 4. Okay, this will be my integrating factor. Now this is a like this is a partial differential equation. Like they really asked partial differential equation, but here they have asked. Now what are they asking? Like consider the following partial differential equation. A and B are distinct real numbers. Select the combinations of values of real parameters zeta and eta such that f of xy is a solution of the following equation. So for this, right, you have to simply solve. You simply solve. What do you mean by solve? So let me, okay, this question here is incomplete. I think there was something missing here. I think this was, sorry, here this would be eta into y. Eta into y. This would be eta into y. Okay, this is missing, eta into y. So you simply solve. What do I mean by solve? So my function is f of xy equals to e raised to power zeta into x plus eta into y. So let me solve it. So let me first put the values of, let me differentiate this function twice with respect to x. Let me differentiate this function twice with respect to y, and then equate this equal to f of xy, and then check for the values of zeta and eta. What do I mean? So let me partially differentiate this function with respect to x. So this will be del f upon del x, that will be zeta e raised to power zeta x plus eta y. If I again differentiate it, it will be del square f upon del x square equals to eta square e raised to power eta x plus, sorry, zeta x plus eta y. Okay, so this is my del square f upon del x square. Now what is my, similarly if you find out del square f upon del y square, you will get this will be zeta eta square into e raised to power zeta x. So which is nothing but, this term is what, this is nothing but my f of xy, right? So it is simply equals to zeta square into f of xy, and this will be eta square into f of xy. Now I will multiply this with a and b. So this will come out to be a into zeta square f of xy, right? So basically my del square f upon x whole square into a plus b into del square f upon del y square. What will be this equals to? This will be equals to a into zeta square into f of xy plus b into eta square into f of xy. Now they are telling me this shall be equals to my f of xy. So this will be equals to f of xy. So what I can do, I can take f of xy common, that will be cancelled. So from this I get a equation a into zeta square plus b into eta square shall be equals to 1. So just put the value of zeta and eta here. If I put the value of zeta equals to 1 by root 2 a, this will be 1 by 2, this will be 1 by 2. So this one is definitely satisfying. So option A is one of the correct combination. What about option B? If I put here 1 by under root a and eta 0, again it is satisfying, this will be 1. So option B is also correct. What about C? If both are 0, if both are 0, then definitely this will be 0 equals to 1, which is not correct. So this is incorrect. If this is 1 by under root of a, so this will be 1 plus 1, and 1 by under root of b, this will be 1. So it comes out to be 2. 2 is not equals to 1. So again this is not satisfying. So if they are asking you from partial differentiation, right, or partial differential equation, the question will be very simple. Like there will not be any set method. Simply solve the question. Okay, there is not like, is there anything to remember or any method? No. For normal ordinary differential equation, I had told you to remember a few certain steps. But partial, if they are asking you from partial, the question will be very easy. You just have to apply some trick. Here I just simply differentiated. That is what I have done. I have just simply equated the final equation. That's it. Let's solve this one. This came in 2024. The general form of the complementary function of a differential equation is given like this. This is the general form. If this is the general form, then I certainly know for what kind of differential equation this is the general form when I have repeated roots. What are my roots? Minus 2 comma minus 2. So how can I form my equation? This will be d plus 2 whole square. So my equation will be d square plus 2d plus 4, right? So this shall be my like general equation. Which one is satisfying? The corresponding differential equation will be the corresponding differential equation. So the coefficient of d square should be 1. The coefficient of d should be, sorry, this will be 2 comma 2, right? So this will be 4. This should be 4, and the constant term will be 4. So this is basically my solution. That's it. This is basically my solution. So you have to just remember, like they are asking you the reverse. They are asking you reverse question. This is not possible. Here what are my, like they have just told me that the general form of the complementary function, right? Complementary function is given to me, not the exact solution, because I have to obviously find out the particular solution as well. That will be my overall solution, but they are just asking me the complementary. So if this was my equation, then here what would have been my roots? My roots would have been plus minus 2i, right, which would have been imaginary roots. So I would have got sin x cos x, something like that. But here my complementary function is not in the form of sin x cos x. Again here my roots are d plus 1 into d plus 2. So roots are d equals to minus 1 into minus 2. Okay, d equals to minus 1 into d equals to minus 2. So again roots are real and distinct. So your complementary solution will be a into e raised to power minus x plus b into e raised to power minus 2x. Then that this would have been my complementary solution. Similarly, this also you can solve. Your roots will be 3 minus 3 comma minus 2. Okay, but obviously none of these are matching, so option A will be your correct answer for the question. Like if they are asking, right, they are asking very simple question from differential equation. Like we have solved 3 questions in just like 10 minutes, and that too I was explaining you, right? You will be able to solve these questions in like 1-2 minutes. Let's solve this next question. So here the function y of t, that is t square y double dash of t minus 2t y dash plus 2yt equal to 0. Okay, first order and second order, and the initial conditions are given. The maximum value of yt over the range. So this is a good question. Like they are, first of all you have to find the solution. This is a homogeneous differential equation, and this is a Cauchy, in the Cauchy format, right? Because it is t square into y double dash of t, 2t into y. So this will be what? If I convert this, right, I will assume my t to be equals to e raised to power z. So this will be d of z into dz minus 1 minus 2 dz plus 2 equal to 0. That will be my solution for the complementary function. So this will be 2z square minus z, 2z square minus 3dz plus 2 equal to 0. So dz minus 2 into dz minus 1 equal to 0. So my solution comes out to be like c1 into e raised to power 2z plus c2 into e raised to power z. This is my solution. Now this will be equals to my complementary function, and that is a solution because I only have a homogeneous equation. Now I will replace my z with my substitution. So this will be c1 t square plus c2 t equals to my y. Now I will use the initial conditions. So they have given me that y dash of 0 is 1. So first of all let me calculate y dash of t. So this is y of t. So let me calculate y dash of t. Y dash of t will be 2t c1 plus c2. So y dash of 0 is 1. So when t is 0, y is 1. So 1 equals to c2 simply. So c2 will be equals to 1, and y dash of 1, y dash of 1. So y dash of 1 is equals to 2 into c1 plus c2. So when t is 1, this will be minus 1, correct? This will be minus 1. So and c2 is 1, right? So this will be 2c1 plus 1. So c1 will be equals to minus of 1. So c2 is 1 and c1 is, c1 is minus of 1. So from this I can easily write down my overall y in terms of t. This will be c1 will be minus of 1. So minus t square plus t. So this will be your function, basically minus t square plus t. Now I have to find out the maximum value. So how do I find out maximum? So when the derivative is simply equals to 0. So minus 2t plus 1, I have to equate it equal to 0. So t is half. So at t equal to half, either I will get a maxima or minima. If I double differentiate this function, right, this will come out to be minus of 2. Of course I will get a maxima here. So they are asking me the maximum value of y of t. So y of max, so I have to put the value t equals to half in the equation. If I put t equals to half, this will be 1 by 4 plus half, which is coming out to be 1 by 4. Now as they have given me the range, I also have to check the boundary. Don't forget to check the boundaries. So what is y of 0? Y of 0 is simply 0. Y of 0 is 0. And what is y of 1? Y of 1 will be simply again 0. So yeah, the boundaries are lower value than my calculated maximum value. So my answer will be 0.25. This will be my answer for the question. Okay, that's how you solve this question. 0.25 will be my answer. Let's now solve the next one. This question came in doubly. So here suppose two circles are there and they are intersecting each other orthogonally at point u comma v, then u comma v will be. So if they are intersecting each other orthogonally, then their slopes will be negative inverse. So what is the slope of this circle? So I will differentiate on both sides. This will be 2y dy upon dx equals to 0. So your dy upon dx equals to minus of x upon y. What about the slope of the other one? Slope of the other one is 2x minus 1 plus 2y minus 1 into dy upon dx equal to 0. So slope of the other one is dy upon dx equals to minus of x minus 1 divided by y minus 1. So both of them will be, and both of them are intersecting each other at u comma v, and of course their slope should be negative inverse. So basically this should be equals to negative and the inverse of this, right? So this will be equals to y minus 1 x minus 1, negative and the inverse, and they are intersecting at u comma v. That is basically your x will be equals to u and v will be equals to y. So I will replace my x and y with u and v. So this will be replaced, your x and y will be replaced with u and v. So this will be minus u upon v is equals to v minus 1 upon u minus 1. Okay. So this is the slope basically, right? Now I will find out the values. So this will be minus of u square plus u minus of u square plus u equals to v square minus v. Okay. So this will come out to be u plus v equals to v square plus u square. So I get back this equation. Now how will I solve this? U square plus anything else they have given me, they intersect each other orthogonally. Okay, one more thing is there, if they're intersecting at u comma v, right? If they're intersecting at u comma v, then definitely u and v should satisfy both these equations. U and v should satisfy both these equations, right? Of course they're intersecting at u comma v, so u and v have to satisfy both these equations. So if I put x equals to u and y equals to v square, so u square plus v square shall be equals to 1. So this particular value shall be equals to 1. So I got my value of u and v, that is equals to 1. So u plus v will be equals to 1. So you have to have bit of presence of mind. So in GATE exam, right, they will not just ask you questions from formulae. So this was normal thing, but here you have to have bit of presence of mind to understand what is my u square plus v square, because I was stuck here. So I had to think something. So I thought, okay, they have given me that x square plus y square equals to 1. So u and v should satisfy this particular curve, because if they are intersecting, it must satisfy the following equation. Let's solve the next question. In the following differential equation, numerically obtained value of y of t at t equal to 1 is what? So what is the value of y of t at t equal to 1? So for that we need to solve this equation. So this is in the variable separable format, so I don't have to worry much. So this will be dy upon dt. So I can integrate on both sides. This will be e raised to power minus at upon 2 plus alpha t dt. Okay. So how will I integrate this particular equation? E raised to power minus at 2 plus alpha t. So alpha is given, alpha value is given, but that is just a constant. How can I integrate this particular equation? That is what I am thinking. Alpha t is there. Okay, can I do any substitution over here? This is alpha, right? What can I do? Okay, this is actually sorry. Yeah, okay, this actually, okay, this was out of the syllabus here, right? This you have to solve using Euler. Like this is in the numerical method. This is not in the, sorry, this is not in our, like in differential equation. This comes under the numerical methods topic, where you have to find out the value of the differential equation numerically using numerical methods with Euler's method. So this is not in the syllabus currently. Numerical method is not in the syllabus, so ignore this question. Let's solve the next one, because you will not be able to solve this one that easily. Okay, so yeah, let's solve the next one. Which of the following differential equations are non-linear? So here is this differential equation non-linear. So what is my independent variable t? What is my dependent variable x? So x is always linear, so definitely this is a linear differential equation. Okay, what about the sorry, which are non-linear, but this is a linear, right? This is linear, so this is not a non-linear one. What about this one? Here my x is again a dependent variable and x is multiplied with dx, right? So again I am not able to divide by x of t or something, I am not able to minimize this, so definitely this will be non-linear, so this is one of the correct answer. What about this one? X of t, again x of t is the dependent variable into sine of t. Sine of t I can divide on both sides, yeah, I can divide by sine of t on both sides. This will be negative, this is correct, this will be this will be linear, no problem, this will be linear. What about the, this is linear, right? This is totally linear, no problem, because here like x of t is multiplied by sine of t. X of t is the dependent variable which is, whose power is only 1, and this is not multiplied with the differential coefficient. What about this one? X of t plus e raised to power this. This is definitely a non-linear differential equation. Simply whenever you have some exponential or something, right, you are not able to minimize it because your dx is some non-linear, because if I expand my e raised to power d of x, it will come out to be, this will be x of t upon dt plus dx of t upon dt whole square by 2 factorial and so on, right? That is the that is the expansion of e, right? So this will definitely be non-linear because somewhere the power will be more than 1, which will make it non-linear. That is the expansion of exponential. So both b and d are my non-linear differential equations. So if they are asking you questions, right, they will ask you from simple things only. Okay, now let's solve this next question. So consider the ordinary differential equation with initial conditions. This r of t is given, okay, r of t is given at t equals to 1, x1 of t will be equals to what? So r of t, that when t is greater than 0 it is 1, otherwise it is 0, and we have been given ordinary differential equation. Okay, okay, the value of t when t is equals to 1. So d of x1 upon x1 dot is nothing but d of x1 upon dt. Okay, I have, although maybe I have forgotten to tell you this notation, but this anyways you will learn in state space control. Okay, this is equals to 2x2, that is another variable, and d of x2 upon dt is equals to r of t. R of t is kind of a constant, but it is also dependent on the value. So what is my, like they are asking me x2 at t equals to 1. So let me first find out x1 at t equals to 1. Let me first find out x2, because if I am able to find out x2, I will put it here and I will solve for x1. So x2, if I integrate on both sides, this will be x2 of t will be equals to integration of r of t, which is kind of a constant, right, integration of r of t dt. Now I can go from 0 to t. I can solve from 0 to t. I will not need anyways initial conditions. So if I'm going from 0 to t, I know if I'm starting from 0 plus, right, before t equal to 0, this function is simply 0, right? So the integration will be some constant. So basically if I'm integrating from minus infinity to t, so I can break this integration down into two parts. Minus infinity to 0, that is 0 of dt, plus 1, because r of t greater than t is simply 1. So I am breaking my integration into two parts, to t. Okay, now I know, like if I am integrating any constant, right, if I am integrating 0, I will get some constant value c. Okay, c1 let's say, and this will be simply t, and here I will have x2 of t. I am just breaking my integration. So they have given me the initial condition for x2. So x2 at t equal to 0 is 0. So if I put here t equal to 0, x2 is 0, so c1 is also 0. So simply your x2 of t is simply t, that's it. x2 of t is simply 0. Now I will integrate this equation. So x2 of t for t greater than equal to 0 is 0. For t less than equal to 0 is, sorry, x2 of t for t greater than equal to 0 is t. For less than equal to 0, it is simply 0. x2 of t is simply 0 for t less than equal to 0. This definition is only valid for t greater than equal to 0. Okay, I hope that part is clear. It is 0 at t equal to 0. So again if I integrate this equation, right, this will be integration of d of x1. This will be 2 into integration of x2 of t with dt. Again I will integrate from minus infinity to t. Again I can break it down. So it will be 2 into some minus infinity to 0 into 0 of dt, because before that my x2 of t is 0, and after that my x2 of t is simply t. So this will be integration of t dt from 0 to t. So this will be again a constant. So again I will have a constant c2 plus 2 plus t square. And again they have given me some initial condition, x2 of 0 is 1, sorry, x1 of 0 is 1. So if I put here 0, this function, right, so my basically what is the solution, my x1 of t is simply c2 plus t square. So if my t is 0, this will be x1 of 0 will be equals to c2, right, which is equals to 1. They have given me x1 of 0 is 1, so c2 will be equals to 1. c2 will be equals to 1. Now I got my c2 value. So what will be my x1 of t? x1 of t will be equals to 1 plus t square. Now what they are asking? They are asking me to find out the value of x2 of t at t equals to 1. At t equals to 1, if I put in this equation x1 of t at t equals to 1, this will be 1 plus 1 square, that is simply 2. So 2 will be your answer for this question. Okay, simply 2 will be answer. Now in few places you will see that they are using Laplace, so this can be solved using Laplace as well in a bit quicker manner, but if your basics are good, you will be able to solve it using simple differential equations as well. So here I did not require any knowledge of differential equation as per se, just the knowledge of integration. Okay, let's solve the next question. Consider the differential equation this. If y of 0 is this, then y of 1 will be equals to what? So this is again is this a linear differential equation? No. Is this equation in variable separable format? Yes. So I can do dy upon y of ln of y will be equals to minus of dx, because if I take this on the right hand side, then I can divide, then I can simply integrate, right? So I can assume, I can do another substitution, t is equals to ln of y. So what will be dt? Dt will be equals to 1 by y dy. So dy by y can be replaced with dt, and this will be replaced with 1 by t. So this will be dt upon t equals to integration of minus of dx. So this will be ln of t equals to minus x plus c. I can assume any constant c. Okay, and t is basically ln of y. T is ln of y. So this is ln of y equals to minus of x plus c. Okay, so now they have given me some initial condition that y of 0, that is at, sorry, not at y of 0, that is when x is equal to 0, y is e. So this will be e. If this is e, this will be 1, and ln of 1 is 0, and when x is 0, 0, so c is also 0. So c is equal to 0. When x is 0, y is 1, y is e, so c will be 0. So I got my equation, c is equal to 0. Now what they are asking, the value of y of 1. So what is my equation? ln of y equals to minus of x. So I can take the exponential on both sides. This will be ln of y equals to e raised to power minus x. Again I can take the exponential on both sides. So this will be converted into y equals to e raised to power minus of x. So finally they are asking me to find out the value of y of 1, that is x equal to 1, which will be e raised to power minus 1, which is 1 by e, right? 1 by e raised to power 1 by e, that is present in option C. So option C will be your correct answer, that is e raised to power 1 by e. Okay, so option C will be your correct answer for this particular question. Let's solve the next question, this one. So here they have given you this differential equation. Whenever there is x double dot, that means you are differentiating it twice. Okay, with initial conditions as such, then the solution. Basically they are asking you what is the solution of my differential equation. So your differential equation is this, right? D square x upon dt square, because your independent variable is t. Okay, d square x upon dt square is equals to minus dx upon dt, and your solution is only defined for t greater than or equals to 0. So I will integrate from 0 to t. Okay, so if I integrate both sides, this will become, or you can directly solve it. Actually you can directly solve it without integrating. This is k, right? So this will be basically d square plus k into d into t equal to 0. So Basically what I did, I just taken it on the left hand side, then I converted in my own auxiliary format. So what is the root, what are the roots of my auxiliary equation? D into d plus k equal to 0. So my roots are d equal to 0 and d equals to minus k. So your solution will be a into or c1 into e raised to power 0, e raised to power 0x 0t not x, sorry, and plus c2 into e raised to power minus kt equals to your solution, that is x of t. Initial conditions are given, that is when x is equal, t is equal to 0, x is 1. So this is the initial condition, right? So if I put t equal to 0 here, this will be c1 plus c2 equals to 1. c1 plus c2 equals to 1. Okay, and if I put my t equals, so if I differentiate this equation again, so this equation will be like, actually this equation will be c1 c2 e raised to power minus kt equals to x of t. So if I differentiate this equation again, this will be minus k c2 e raised to power minus kt equals to x dot of t, right? Now if I put my t equals to 0, if I put my t equal to 0 here, right, this will be minus k into c2 equals to, now what is x dot of t when t is 0? It is also 0. So this will come out to be 0, and they have already told me that k is some positive value, so k cannot be equal to 0, so c2 has to be 0. So c2 is 0, so c1 is 1. So I can solve this equation. Your equation will be simply x of t, c1 is 1, so x of t equals to 1 is simply the solution for this particular equation, that is option C. So option C will be your answer for this particular question. Okay, let's solve the next one. You could have simply solved it as well, like simply integrating these things, right? You could have put the initial conditions, those things also you could have done. The time dependent bacterial growth is given, where x is the population size, and at time t the initial population, like initial condition they gave me at t equal to 0, this is the initial population. When my t tends to infinity, the population size of the bacteria will be, basically what is the value of my function x at infinity, that is what they are asking me. So I can simply solve, first of all solve for the function, right? What will be my x of t? So how can I solve for my function? Again it is in the variable separable format. So this will be, okay, dx upon x into 1 minus x by 200 integration equals to integration of dt. So I can use partial fractions here. So I will use partial fractions. So I will put x equals to 0. If I put x equal to 0, this will be simply 1 upon x, and then I will put x equal to 200. If I put x equal to 200, this will be 1 by 200 upon 1 minus x by 200. Is this absolutely correct? I think so. This is correct. This will be gone there. This will go there. This will be 1 minus x by 200. This will be, yeah, this will be x by 200. That will be cancelled. Yeah, 1 by, yeah, correct. So this is my partial fraction basically. Now I will integrate this with respect to dx, and on the right hand side also I have to integrate with respect to t. So this will be ln of x plus 1 by 200 ln of 1 x by 200. Okay, and there will be some t plus constant. Okay, so this will be basically equals to, I can convert this, so x into 1 minus x by, okay, 1 by 200 is also there, right? So divide by raised to the power of 1 by 200, like I'm just directly converting it. This will be equals to e raised to power t plus some c. Okay, what have I done? I have taken this power inside, power is inside, then it is ln of a plus ln of b, that is a into b. Okay, that is a into b, and I have then raise the both the sides with exponential, so this becomes this term. Now they have given me that initially when t is 0, initially the population is said to be 100, so x is 100. So if this is 100, this will be 100 into 1 minus 1 by 2, that is 1 by 2. So it is e raised to power c. So e raised to power c equals to 50. So this can be converted as e raised to power c into e raised to power t, right? So e raised to power c comes out to be 50. So your equation comes out to be x into 1 minus, one second, this will go here, t plus c, okay, okay. This will be 1x plus c, okay, 1 minus x divided by 200 raised to the power 1 by 200 equals to e raised to power t, like 50 into e raised to power t. So how can I write my x in terms of y, right? I have to write, just hold on a second, I have to write in my x in terms of y. How can I write it? So this is actually very, like, this becomes an interesting question here, right? I have to write my x in terms of y, because if I put here t equals to infinity, this will be simply infinity, which is something weird, right? Which is not, like, very weird. This is equals to infinity. I have to write my x in terms of the function, like in terms of the independent variable, simply. So what I will do, I will raise it to the power of 200. So this will be 1 by x by 200 will be equals to 50 raised to the power of 200 into e raised to the power of 200t. So here I am kind of doing a thing wrong, because this will, like, I will not be able to solve it. So better would be this 1 by 200, right? Let me multiply inside. If I multiply the 1 by 200 inside, this will become 200 minus x. So this will be simply, this 200 will be gone, 200 ln of 200 minus x, that will be actually coming out to be negative mod of this, right? And negative, this will be negative. I was doing that wrong, right? This will be negative. So here the solution would be mod of x upon 200 minus x. I was actually solving it wrong, because this was in the denominator. I was solving it wrong, right? So this was coming out to be mod of x upon 200 of minus x. This is my e raised to power. So I can assume, yeah, this is okay, this right hand side is okay. So then what I can do, I can, this is my t plus c, right? So I can simply raise it to the power of e. So this will be coming out, because my x is always positive, x will, population cannot be negative, this will be positive, upon mod of 200 minus x equals to e raised to power t plus c. Now I will put my initial value, t is 0. When t is 0, this will come out to be, when t is 0, t is 0, x naught is 100. So this will be 100 upon 100, that is t is 0 e raised to power c, right? 100 upon 100 e raised to power c. So e raised to power c is 1, right? E raised to power c is simply 1. So this can be broken down, e raised to power t into e raised to power c, which is 1. So x upon mod of 200 minus x is coming out to be simply 1. So it is e raised to power t. So for a second, let us assume that the limit of x, right, is greater than 0 and it is less than 200. Then I will be able to break my mod. Okay. So if I break my mod, this will be 200 minus x will be equals to e raised to power t. So now what I will do, x equals to, or I can put my e raised to power minus t here, this will be equals to 200 minus x by x, right? So this will come out to be e raised to power minus t is equals to 200 by x minus 1. So from here I can easily get the value of x in terms of t, because that is my main concern here, that to get my value x in terms of t. So this actually becomes a pretty good question. So this will come out to be, x will come out to be here, like 200 by x will come out to be e raised to power minus t plus 1, or x will come out to be 200 upon 1 plus e raised to power minus t. Now you put your limit as t approaches infinity. So if I do limit as t approaches infinity x, so this will be 200 upon 1 plus 0 approximately this will be 200 approximately, correct? And if your this is not infinity, this is very high value, right? This will be some 1 plus a very small value 0.001 upon 200, right? So this will be always less than 200, correct? So our assumption was x has to lie between 200 and 0, which is correct. X can never be equal to 200 because if it is equal to 200, this will be 0 and that will be undefined. So it will, that's why they have mentioned asymptotically approach. It will asymptotically approach. It will not be exactly equals to 200. So it will approach 200, not exactly equals to 200. So this was a pretty good question actually. So you have to solve this very carefully. You have to write x in terms of t. Otherwise, you will get something weird like e raised to power t will be infinity, right? You will not be able to solve it. So let's solve the last question. This is the last question. So you have been given a differential equation and you have to say what does this differential equation represent? Which family of curves does my differential equation represent? So one thing you remember, if the signs like a plus b y square equals to c square, if the signs of both a and b are same, that is a into b is greater than 0, right, then you will always get a ellipse. If your signs of a and b are not same, if one is positive other one is negative, then you will get a hyperbola. This I forgot to mention hyperbola, but I hope you already know this. And if I have basically, if I have y square equals to ax or x square equals to ay, right, then this is the equation of a parabola. This is the equation of a parabola. And if both your a is equals to b, then you get a circle, right? It will be x square plus y square equal to c square. That is the equation of a circle. So these are the few things that you must keep in mind while solving these questions. So let me first rewrite my differential equation. It is in simple variable separable format. So this will be y dy equals to 9 x dx. Okay, x dx. I have to integrate on both sides. So this will be y square by 2 plus equals to 9 by 2 x square plus c. So this will be y square equals to 9x square plus 2c. And okay, what kind of family does it represent? So if I take my x square on the left hand side, this is y square minus 9x square equals to c. So definitely the signs, the coefficients of x square and y square both are opposite of each other. So if they are opposite, that means I will get a hyperbola. So this represents a family of hyperbola. So option A will be your correct answer. So with that, we are finished with our integral calculus portion. So every single thing has been covered. So I hope this series is helping you guys. If it is helping, so just one thing, hit the like button, comment down below how are you feeling, and of course I will see you with the next video of R-PYQ. Until then, happy learning.